Welcome everybody. This is a complete course on trigonometry and I'm very excited to present you all this course. Now this course starts off with the basics of trigonometry and then gradually it augments its capacity to be a full-fledged trigonometry course that is offered by universities all across the world. And not only that, if you are completing this course, you will not only become a stud in trigonometry, but you will be able to take on any competitive examinations, or for that matter, apply trigonometry in any areas of your life. Of course, for your professional development and for your professional growth. So take this course seriously, and the best way to do it is allocate 30 minutes every day and dedicate yourself, work on the questions. I have worked on all of these questions. All you need to do is just carefully listen to the lecture and then practice it. Practice makes it easy. So the more you practice, the better you become. And not only that, it will expand the horizons of your thought process, right? And it is imperative to have a mathematical bent of mind to become successful in life. Of course, having mentioned all of this, I wish you all good wishes. Let's go on with the course. Welcome students, this is a complete course on trigonometry. It starts all the way from basics and heads up to finish with advanced concepts. So with this course you will be able to tackle any trigonometric course offered by any universities all across the world. And it is imperative to understand that trigonometry is the universal language when it comes to any form of manufacturing engineering. So having mentioned that, it is important that you know this subject and have a complete grasp of this subject, because without this subject, as I mentioned to you, there cannot be any innovation, any creation when it comes to structural engineering. In fact, if you want to manufacture anything for that matter, you need the knowledge of trigonometry. Now, having mentioned that, let me just go ahead and introduce this subject. What exactly this subject is, you will have to understand the word trigonometry is a composition of two words. One is trigonon and the other is metron. Now this means triangle, this means measure. So if I were to write it in a single line, this means the science of measuring triangles, right? Now you have to understand that in those days they did not have any devices at all. The only relevant device they had to create architectural marvels is the understanding of the triangle. More specifically, it is the right triangle. So that has to be taken into account. So if you have the knowledge of the right triangle, the very word says right, you can get all things correct. That is the basic way to illustrate or put the subject in a nutshell. So having mentioned that, let me just head on to define the following concept. Since I have just mentioned to you that it is nothing but the science of measuring, we are talking about the most important concept when it comes to trigonometry is the angles. So you will have to know what is an angle. So what is an angle? We are hearing so much about these, right? What are angles? So this is plurality. If you want to talk about in singular nature, what is an angle, right? Now, an angle is nothing but, say for example, I'm mentioning it as theta, right? You can say theta, alpha, beta, anything for that matter. So in most commonly we use this Greek symbol theta. So what is it? It is nothing but the measure of distance between two rays. Now this is a key word. Now what is a ray? What is a ray? Now a ray is a part of a line, part of a straight line. Part of a straight line that has a fixed starting point. Fixed starting point, but no end point. Right? There is a popular proverb which starts with this sentence or this phrase: "A world without end." Right? Well, the ray is like that. So if you were to mention or draw the represent the ray, this is the ray. So it has the starting point and no end point. So this is the start point. So it's a fixed point here. This is a fixed point. Now we are much bothered about measuring the distance between two rays. Say you got a ray like this and you got another ray like this. Right? This is say OA and this is OB. Now theta would be present here. So this theta is the measure of the distance between two rays. So that is the understanding that you need to have. So just to have a recap, I just mentioned to you trigonometry being the most important sciences when it comes to any forms of engineering. That's point number one. Point number two is what is the word trigonometry stands for. It is made up of two words. One is trigonon and other is metron. Trigonon means triangles, metron means measurement. So to put it in a phrase or in a sentence of understanding, it means the science of measuring triangles. As I mentioned to you, in good old days, the most important attribute of a triangle is understanding the right triangle. So everything was connected, correlated or related to the right triangle. In trigonometry, you will see a lot of right triangles. That doesn't mean that you're not going to see any other triangles, but you will see right triangles more too often. So having mentioned to you the concept of right triangle or bringing in the term right triangle, it is imperative that we start off with the basics. The first thing that you will have to know is what is an angle. As I mentioned, the angle is nothing but the distance between two rays, and then it comes to what is a ray. A ray is a part of a straight line which has a fixed point but no end point. So this is the basic example of a ray, and you got the theta. Now theta is measured in two ways. So how do we measure theta? So let me state this. Measure of theta is done in two ways. So one is anti-clockwise direction, anti-clockwise, and other is clockwise. Now anti-clockwise is always positive, that is this side, right? Now clockwise is always taken to be as negative. So have these understanding in the corner of your mind. So having mentioned this, let's go ahead. Now let me draw to you all the measure and sense of angle. Now this is the axis, this is x-axis and this is y-axis. Now imagine you have a ray starting from this point and moving up to this point. So this is one ray, right? And you got another ray over here. So this is say OA and this is OB. Now this line which you call it, or which you see, is called as the initial side. Have that in mind. And this one is called as the terminal side. Terminal side. So this is the starting point, this is the end point. So this is going to be theta. So we are interested in measuring this theta. Now in this case theta would be positive, and concurrently if I were to draw the axis, the coordinate axis x and y,
and I have the ray OA here, and then I got the OB over here. Now if I were to, as I mentioned to you, this is the initial side and this is the terminal side. Now if I were to start the measurement from here and move down as it is the other way, then this theta value will be negative. So in this case it is anti-clockwise. This is anti-clockwise and this is coming down. In this case it is clockwise. So clockwise measure of theta will produce us a negative value and anti-clockwise will produce us a positive value. So this is a very important concept. That's the reason I made it a point to mention this. So we'll move on. Now this is a very important concept. It is the relationship between degree and radian. You have to understand degrees is what is called as the hexadecimal system and radians is what is called as the circular system. And using this system you can easily find another important term which is called as arc length and area of the sector. So these two important terms or technicalities can be achieved when it comes to any angle, or if you want to know the area enclosed by these angles. So having mentioned that, imagine that you have a circle in this fashion and you got the radius. So this is the radius and you got another radius joining them. This point is O. Now this is what is called as the arc, and in most of the questions you will be asked to find the length of the arc, right? And you got your theta, right? Now we always, to get the length of the arc, the formula is L is equal to R times theta. Now theta is measured in radians. So you will have to take the radian measure, even though they would be giving you in degrees. Relationship between, let me write that down. What is the relationship between degree measure and radian measure? So the faster we understand this, the easier would be the journey. So let me write that down. Degree measure divided by 90 is equal to 2 times radian measure divided by pi. So if I were to convert, say, 90 degrees into radians, then I will have to place 90 over there, divide by 90. This is 2 times radian measure divided by pi. So 90 gets cancelled. I move pi to the other side, bring 2 down. So this is going to be my radian measure, right? On the other hand, if you were to be required to convert 180 degrees, we always also indicate a degree like this. We place a small circle there. This is not 0, it's a small circle. So 180 degrees into radians. So what you will have to do is take 180, place it here and divide by 90. Over here it's going to be 2 times radian measure divided by pi. So 90 divides here 2 times. So this is 2 times pi is equal to 2 times radian measure. 2 gets cancelled. Therefore radian is equal to what? Radian measure is equal to pi. So if you were to write the relevant degrees and radians, then this would be the following. So we started with 90 degree, but over here let me start with 0 degree. 0 degree is same as 0 radians. And then 30 degrees, you've got 30 degrees is going to be pi over 6. Then you've got 45 degree, it is represented as pi over 4. And then you've got 60 degrees, it's represented as pi over 3. 90 degrees, it's represented as pi over 2. Then you've got 180 degrees, it's represented as pi. And then you got, if you want to move up, you got 270 degrees. Now you want to find the equivalent of 270 degrees. So you can use the formula. 270 divided by 90 is equal to 2 times r over pi. This divides here 3 times, so this is going to be 3 pi over 2. This is my radian measure. So 270 degrees is nothing but 3 pi over 2, right? And then you've got 360 degrees. So you will want to know what is 360. So take 360, you divide by 90. This is going to be 2 times r over pi. And this divides here 4 times. So it's going to be 4 pi divided by 2. 2 divides here 2 times. So this means 2 pi. So radian measure is 2 pi. So this is some of the standard values of degree measures and radian measures that we would be encountering. So let me just move on. Now in this class I'm going to give you the simplified conversion factor. We started off with this particular formula, the way in which the degree measure is related to radian measure is given in the following fashion. So it's going to be 2 times radian measure divided by pi, right? So this is what we had started off with. Now whenever you're given degrees, if you wish to convert it into radians, all you need to do is multiply this quantity by pi over 180. So this is the conversion factor you will have to adhere to. Now you might be asking me, how did we get this? It's simple. What you need to do is move this pi up. So this is going to be degree measure times pi divided by 90. You bring this 2 down, so it's going to be 2 here. This is my radian measure. So what happens when you multiply 2 with 90? So you're going to get degree measure divided by 2 times 90 is 180. So just place that 180 there, and you got a pi there, and that is what I have written down there. So degree measure multiplied with pi over 180 will give us the radian equivalent. So have that in mind. So instead of going about these confusing stages, all you need to remember is, given the degree, multiply it with pi over 180. So this is the important conversion factor that you will have to know. Now conversely, you might be asking, what would you do if you are being given radian measure? How am I to convert it into degrees? Yes, you guessed it correct. So the factor would get reversed. So you have radians here, and if you want to convert it to degrees, to degree measure, all you have to do is multiply it with 180 divided by pi. This goes for both positive values and negative values, so have that in mind. So let me just give you some illustrations to reinforce. Say for example, you have got 15 degrees and you would want to convert it into radian measure. Now all you have to do is take 15 degree multiplied with pi divided by 180. That's it. Now you can make the reduction say 5 divides here 3 times, 5 divides here 3 times, and 3 times 6, and 3 divides here 12 times. So this is going to be pi over 12 radians, right? So that's the solution. Now say for example 330 degrees, say you want to convert 330 degrees to radians. So how would you do that? So let me use a space here. So 330 multiplied with pi over 180, I can cancel the zeros. I can reduce by 3. 3 divides here 11 times, 3 divides here 6 times. So this is going to be 11 pi over 6 radians, right? So that is the conversion that I've applied. So negative values also follow the same thing. Only thing is that you got to place a negative sign. So one more question. Say imagine you are given 210 degrees and you want to convert it into radian measure. You multiply this by pi over 180. Cancel the zeros. 3 divides here 7 times, 3 divides here 6 times. So 7 pi over 6 radians. So that is for the radian measure. Now imagine you are given angles in radians. Say for example you are asked to convert radians to degrees. So how do you do that? Say you're given pi over 6. So all you need to do is multiply it with the conversion factor. In this case it's going to be 180 divided by pi. Pi gets cancelled. 6 divides here 30 times. So this is equal to 30 degrees, right? And say for example you are given 3 pi. Next question, convert 3 pi over 2 to degrees. So what you got to do, multiply this by 180 divided by pi. Pi gets cancelled. 2 divides here 90 times, 90 into 3, 270 degrees. So I hope you got this point. It's very important. Okay, now there is another important concept you will have to know. This is important. The relationship between turns and radians and degrees. Sometimes they will ask you, say, now you have to understand that this is the circle. We always deal with the circular measure in trigonometry. So if there is a question, say there is, say 1/24th turn, and you are asked to find 1/24th, 1 divided by 24, the turn on this circular measure. So how much would that be in radians and how much would that be in degrees? Now this entire circle is 2 pi radians. Have that in mind. This entire measure of this circle is 2 pi radians. So when they say 1 over 24, this means that 1 over 24 of 2 pi. So 2 divides here 12 times. So this is nothing but pi over 12. So when it comes to radians, they want you to find out what is pi over 12 in degrees. So you have to get the degrees. So as I mentioned to you, you want to convert this radians into degrees. You multiply by 180 over pi. So pi gets cancelled, and you got 4, right? 4 can divide 18 4 times, 16, 20, 45. 4 can divide this 3 times. So 3 can divide 45 15 times. So let me write that down here. Solution: 1 over 24th turn is nothing but pi over 12. In short, we write it as rad, which is nothing but 15 degrees. So this is a very important understanding. Suppose you are taking some scholarships examinations, MCQ will be used to filter people out. So questions like this would feature, right? Because these are all basics. So many times in MCQ, they want to check for the basics. If your basics are clear and straight, then nobody can stop you. So you have to get the first button correct, right? So understand the basics. So the next thing is, say for example, 1 over 16th term. What does this mean? They want you to get the radian measure for 1 over 16. So as I mentioned to you, this is nothing but 1 over 16 of 2 pi. So 2 divides here 8 times. So this is going to be pi over 8 rad. Now what is pi over 8 rad? So you got pi over 8. Now you want to get the value. So it's going to be 180 divided by pi. So pi gets cancelled. Now 2 divides here 4 times, even 4 divides, I could have taken 4, but anyway I started with 2. So it's going to be 90, and 4 divides here how many times? 4 divides here 2, 4 2s are 8. No, 4 cannot do that. So I have to reduce it with 2. So 2 divides here 2 times, 2 divides here 45 times. So it's going to be 22.5 degrees. Okay, so this is going to be 22.5 degrees. 1 over 16th term means pi over 8 rad, and in degrees it is 22.5. So probably I can give a few questions for you all to try them out. So I want you to find out what is 1 over 10th turn. You put the answer in the comment section. 1 over 12th turn and 1 over 6th turn, 1 over 4th turn. You have to do all this. 1 over 2 turn, 2 over 5 turns. Right? Find the radians and the equivalent degrees for all of these. Now the next important topic that we would have to focus on is how exactly we are going to deal with decimal degrees. In other words, degrees which have got a decimal part. So that is also something that we need to focus on. Now we have just seen how exactly we can convert degrees to radians and radians to degrees, and then we moved on to understand the relationship between turns and radians and degrees, and now it's time for us to handle degrees which do involve fractional quantities. So having mentioned this, it is imperative to understand that 1 degree is equal to 60 minutes. So this is the representation, and let me write it in sentence form. 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. And when we make the representation, we represent it like this: 60 prime and 60 double prime. So this indicates 60 seconds, this indicates 60 minutes. Now the next question is, how are we going to implement this? Now let me just give you a question. Say for example, convert 22.72 degrees into degrees, minutes and seconds. That's a question. Into minutes and seconds. So foremost, what we have to do is, we got nothing to do with the integral part, right? So all our focus is basically on 0.72. So what I wish to do is, I would like to take 0.72 and then multiply it with 60, because 1 degree is equal to 60 minutes. So we just multiply it first with 60. So when we do that, we would now have 6 times 2 is 12, 6 times 7 is 42, 43, and we got a 0 after the second. So this is how it looks, right? So when we write this, the decimal point is over here. So we have just successfully converted the fractional quantity into 43.2 minutes. Now you extract this fractional part. So this is 0.2. Now drop this. When I say drop this, it means we are not going to be looking into this for now. It doesn't mean that we can simply drop it off from the final solution. As of now, we are not going to be setting our focus onto the number 43. So we got this 2 minutes. So take this 0.2 and then you multiply it with 60. The outcome that you're going to get would be in seconds. So this is equal to 6 times 2 is 12. You got a 0, you place it there. Now the quantity here is out of the decimal place you got 1 digit. So you place a 1 digit. So naturally you're going to get 12 double prime. So when you're writing this, the most important part comes here is how are you going to write this. So when you are writing this, this is going to be equal to, let me show that to you. 12, we started off, place the 12 degrees like this, and then this is in minutes, place 43 with 1 prime, and then this is in seconds. So it's going to be 12 double prime. So this is going to be the final answer. This is a very important topic, and specifically, as I mentioned to you in MCQ, this plays a very vital part. Students, we are expected to convert this quantity negative 40 degrees 20 minutes to radians. So foremost, we would have to convert this entire quantity completely into degree measure, right? So for that, you take this 20 minutes and then you divide it by 60. I already mentioned to you 1 degree is equal to 60 minutes. So that is the reason I'm dividing by 60, because I would want to convert this quantity into degree measure. So clearly 0, 0 gets cancelled. You get 2 over 6, which is nothing but 1 over 3. So the understanding is 40 degrees 20 minutes is nothing but, of course there's a negative sign there, 40 1 over 3 degrees. This can be further rewritten as 40 times 3, that's 120, you add 1, that's going to be 121 divided by 3 with a negative sign degrees. So this is the entire conversion in degree measure. Now the question doesn't require us to give the answer in degrees. The question wants us to give the answer in radians. So you want to convert degrees to radians. What are you going to do? You take the value, which is negative 121 divided by 3, and you have to multiply it by pi over 180. So if you were to do this, this is going to be negative 121 pi divided by 3 multiplied by 8. 8 times 3 is 24, 2, 3 ones are 3, 4, 5, and that's going to be 540. So what is this? This is the radian measure for what? For negative 40 degrees 20 minutes, right? So that is the solution for this particular question. Now there is this concept, what is called as grad measure or grade measure. Sometimes you might be encountering questions involving, now if you want to convert grade to degree measure, then all you need to do is multiply the quantity by 90 over 100. So that is the conversion factor you will have to use. So based on that, let's do a question. So before I could start off with this measure, let me give you the spelling for this measure. The full form of this measure is as follows: gradients. So you can either represent it as GRAD or you can simply state it as gradients. Now the point comes here is, since I've just shown you, or I should say since I've just mentioned the conversion factor here, 90 divided by 100 to convert grade or grad into degrees, there is this equivalent relationship you will have to know, which is 100 gradients is equal to 90 degrees. So what is the meaning of this? It means there are 100 gradients present in 90 degrees. So that's the understanding of this statement. So as I had indicated to you, we will do a question which involves this grade measure and degrees. So the question is as follows. The angles of a triangle are given to be as 3x degrees, 4x over 3g, g stands for gradients, right, and 2 pi x divided by 75 radians, rad. So you got rad, grad and dig, right? So you're expected to find, if this is what has been given, find all the measures in degrees. Find all the measures in degrees, right? So let's get it started. So there's nothing here to convert because it already says 3x degrees, but we have to do the conversion for this. So 4x over 3g is converted into degrees by multiplying the quantity with 90 over 100. So this is going to give me the value in degrees. So this is nothing but 0 and a 0 can be cancelled. 9 times 4 is 36x, 3 times 10 is 30. So this is 30 degrees. Now it's time for us to convert 2 pi x over 75 radians to degree measure. Now this is equal to 2 times pi times x over 75. You want to convert this into degrees, you multiply this with 180 over pi. Now clearly pi can be cancelled, so you got 2 times x and then you got 180 divided by 75. Now you can use 15 times. 15 divides 75 5 times, and 15 divides 180 once, and then you got 3, and that's going to be 12 there. So 2 multiplied with 12 would give you 24, and you got an x there over 5. So we have achieved all of the conversions. Now a very important point. We know that the sum of the angles in a triangle equals 180 degrees. So that means the first angle is 3x degrees, and we have also converted the gradients to degree measure, and that was giving us 36x over 30 added with 24x over 5. This is equal to 180. Now if I were to take the LCM as 30, this one would give me 90x, this is going to be 36x, and this is going to be 6 4s or 24, 2, 12, 13, 14. So you got quite a number, so it's going to be 180. Now in fact you don't have to do this if you can reduce 36 over 30, as 6 divides 36 6 times, 6 divides 30 5 times. So in that way we would have a lesser problem in handling with huge numbers. It is not that you cannot do this, but sometimes some errors might creep up with whenever numerals calculations are involved. So we can avoid that by reducing these quantities prior to the simplification. So if I were to take 5 as the LCM, this would give me 15, this would give me 6, this would give me 24. Of course there is a x there, this is equal to 180. So this is going to be 30, 45 times x divided by 5 is equal to 180. This is what I've got. Now 5 divides here 9 times, so 9x is equal to 180. So x is equal to 9 divides 18 2 times, there's a 0 there. So x is equal to 20. Now if you remember, we were given 3x degrees, that's the first measure, and then for the second measure we got it as 6, we reduced it to 6 over 5 times x, and the third measure we reduced it as 24 over 5 times x. So substitute the value of 20. So this is 3 times 20, this is 6 over 5 times 20, this is 24 over 5 of 20. So this gives us 60 degrees, this gives us 24 degrees, this gives us 16, 1, 4 to the 8, this gives us 96 degrees. So if you were to be given this question in choice, your answer should be 60, 24, 96. So that should be the solution for your question. Let's do this question, students. Two arcs of the same length in two circles subtends angles 60 degrees and 75 degrees at the center, at their centers. You are expected to find the ratio of their radii. When it is plural, you say radii. If it is singular, you say radius. So just to give a visualization, you got an arc in two circles. Say this is C1 and C2, and this is subtending an angle of say 60 degrees. This is 60 degrees, and let it be L1. This is L2, 75 degrees. Now if this radii is R1 and R2, we are expected to find what is R1 over R2. In other words, you can also write it like this: R1 is to R2. This is what is required, right? Now we already knew a formula that length, or I should say arc length, is equal to L is equal to R times theta, right? So in this case L1 is equal to R1 theta, and it says same lengths. So in this case, even though I write L2 is equal to R2 times theta, this is theta 1, theta 2, this is given that L1 is equal to L2. So for C1, we've got L1 is equal to R1 times 60 degrees. Now 60 degree in radian measure is pi over 3, and L2 is R2 over, now you got 75 degrees. 75 degrees in radian measure. Now we can convert 75 degrees to radians by multiplying it with pi over 180. Now 15 divides here 5 times, and 15 divides 180 12 times, right? So this is going to be 5 pi over 12. So if I were to represent this, I got here 5 pi over 12. Now it's given that L1 is equal to L2, right? So what I wish to do now is, this is given. So because of this, I can equate these two components. So this would mean R1 times pi over 3 is equal to R2 times 5 pi over 12. Pi can be cancelled, and if I were to move these two things, cross multiply, it's going to be 12 times R1 is equal to 15 times R2. So 3 divides here 4 times, and 3 divides here 5 times. So we need R1 over R2, right? So therefore R1 over R2, move this R2 down. So you got a 5 there, and then you got a 4 there. Okay, so the ratio is going to be 5:4. Students, we have this question. The question is as follows. If the angular diameter of the moon be 30 minutes, how far from the eye should a coin of diameter 2.2 centimeter be held to hide the moon completely? Now let me explain to you this question. Now you have the moon and you got the eye watching the moon. Say let me draw the angular diameter. Now this is the angular diameter for the moon, and this is given to be as 30 minutes. So you have the eye watching the moon. Now you have to place a coin so that this coin completely blocks, right? Completely blocks the moon. We would have done this when we were little kids. Children always used to try to play this game. So the question wants us, how far should you hold the coin so that the moon is blocked? Now you've been given theta. Now theta is 30 minutes. That is the angular diameter. Now this is the coin. The coin is actually over here. So you are actually interested in finding out this distance. This distance has to be calculated. Now how are we going to calculate this distance? Now all that we can see here is there is an arc here and there is a theta. Now is it okay that we can use L is equal to R times theta? Can we use that to evaluate the distance? So that is an interesting question. So we are actually looking to find this length, right? Now the eye has been placed here. Actually, if we can stretch this, the eye would be the central point. So let me just stretch this like that. Okay, so the eye is actually the center and this is actually moving out like that. So that's the reason we were given the angular diameter. So since I placed this point over here, the eye over here, we are actually looking to get the distance from this point to the coin, right? The arc that is made by the coin. Now clearly, if we were to go and look into the arc length definition, the arc length is something of the same fashion. So this was termed to be as L, this is theta, and this is R, right? So this is what we are looking for, this distance. So that is nothing but the R that we are hunting for, and it is actually hidden. So we would be using this formula, L is equal to R times theta. Now we are given theta in minutes, so I want to convert into degrees. So what I wish to do is, foremost I'll have to, let me write that down. Theta is equal to 30 minutes is converted into degrees. To convert it into degrees, I have to divide by 60. So this is now in degrees. Now I already mentioned to you, whenever you are placing the value of theta, you have to place it in radians. So we have to convert this into radian measure. So to convert a quantity which is in degrees into radian measure, all that you need to do is multiply the quantity by pi over 180. So clearly I can reduce this quantity 30 over 60 into 1 over 2 and rewrite this as pi over 360 radians. So this is the radian measure. So we are actually got the following. We have the angular diameter, which is given, right, and r is what is required. So let me just place that, and theta is pi divided by 360. Now extracting the value of r, we would get 360 multiplied with 2.2 divided by pi, right? So this is the system we will get. Now we would take the value of pi to be as 3.14 and rewrite this as 360 times 2.2 divided by 3.14. If you were to compute this, this would be approximately 252 centimeters. So the value is 252 cm, and that would be the solution to this question. Now important observation is that you have to use the value of pi to be as 3.14. So have that in mind. Now it's time for us to learn about trigonometric ratios. Foremost, we need to know the three important ratios, which are known to be as sine theta, cos theta, tan theta. Now when I say trigonometric ratios, they are nothing but the ratios for the right triangle. So if you were to take a right triangle, say A, B, C, this side is called as the opposite side, this is the adjacent side, this is the hypotenuse side. Now the ratios of these sides are represented as sine, cosine and tan. Say for example, if I were to take sine theta is nothing but opposite side divided by hypotenuse. Right? So cos theta is going to be adjacent side divided by hypotenuse, and tan theta is going to be opposite side divided by adjacent side. So this is the ratios, or I should say these are the trigonometric ratios by which the right triangle is represented. Now foremost, let us talk about f of x is equal to, say, sine x. Now the graph of sine x is actually in this fashion. So it starts from 0 and it hits 2 pi over here. Right, so at pi the graph will hit 0, and at pi over 2 the graph will hit positive 1, right, and at 2 pi the graph hits 0 again. Now between pi and 2 pi you have a value called as 3 pi over 2. At 3 pi over 2 the graph will hit negative 1. So if you were to extend this sine x graph, sine x will not go beyond negative 1 on the negative side of the axis, and it will not go beyond positive 1 on the positive side of the axis. And this curve will be repeating up until infinity, both on the left side and the right side. So if you were to talk about the domain, The domain means the values that x can take. X can take all values that are contained in the real number. But the function can only take values between -1 and +1. So the range is between -1 and +1. This is a very important concept that you will have to understand. Right? So the next point is periodicity. The period is the graph will repeat itself at every 2 pi intervals. So 0 to 2 pi, this will be the loop. Again another 2 pi, the same loop will be repeating. So the graph will be moving up like that. So the period is 2 pi. Is the function even or odd? The function is an odd function. Now what exactly does it mean when I say the function is odd? F of negative x is equal to negative f of x. This is the meaning of it. So if I were to take x is equal to negative x into this function, it will produce me negative f of x. So sin x is an odd function. Now, is sin x a bijective function? Is it bijective? Bijective means, is it one-to-one onto? Or in other words, is it injective or surjective? No, sin x is not a bijective function. So when I say bijective, it should be one-to-one, but it isn't. Say for example, if I were to take a point, say 1/2, and if I were to draw the line, it fails the horizontal line test. So that means over here, the curve, as I mentioned to you, would be repeating itself like this, right? And then it will be going up again. So according to the horizontal line test, the intersection of the line and the curve should occur at only one point. But in case of this particular point 1/2, the number of intersection that is taking place is infinite. So the function is not bijective. Of course, it is just an additional information that I wish to provide you here. So having given you this, let us move on. So the next function we would like to discuss would be the cos x function. So if you were to draw the graph at the 0, cos x will hit 1 and it will go down and it will come up like this. And then it would move up like this and the wave would be produced. So this is x. Right, so this is the approximate graph for cos x. Now at exactly pi/2, cos x will hit 0, right? That is important. And at pi, cos x will hit -1. And at 0, cos x will hit +1. And this order would be repeating itself. Now if you were to take 2 pi, cos 2 pi is +1, so it hits +1 here. So that is the graph. And if you were to write the domain is all x element of real number. So it can take any value on the x-axis. But the range will be only from -1 to +1. That is the range of cos x. And the next important point you will have to know is it is periodic. And the period is 2 pi. Right? Because it starts here and it ends here. So you will have to make that observation. Sin x is also periodic. But the only point that is splitting cos x and sin x is the point 0. When x is equal to 0, sin x is 0, but cos x hits 1. So at 2 pi, it hits 1 again. So that is a full form, or I should say a loop, one complete wave that has been created by the cosine graph. So its period is 2 pi, and the next important point you will have to know is it is an even function. Okay, it's an even function. So meaning f of negative x will give me f of x. That's the idea here. So if you were to substitute x is equal to negative x in cosine function, it will produce the function back again. And another important point you will have to know, if f of x is equal to cos x, it is not bijective, as I mentioned to you. Now why am I so much concerned about bijective? It means, does this function have an inverse? No. Cos x does not have an inverse. To have an inverse, the function should be bijective. So cos x is not bijective. Clearly, if you can apply the horizontal line test, you can see that the intersection is at multiple points. So the test for bijection will fail in the case of cos x. So have that in mind. Cos x does not have an inverse. So that's a critical point of observation. So having got this, let us move on to the next trigonometry function. And before I could go, cos x trigonometric ratio is adjacent side divided by hypotenuse side. Right, so this is the formula that we will be using. Now the next important function that we would like to study is the tan x function. Now tan x, you'll have to know when x is equal to 90, tan 90 will hit infinity. That is a very important point that you will have to take into account. In other words, for 2n positive 1 times pi over 2, tan of this value will be hitting infinity. For n taking values from 0, 1, 2 up until infinity, whatever be the case. So in this case, n is element of integers. So if we were to draw the graph, so this is 0, this is pi over 2, this is n is equal to 1, that would give me 3 pi over 2, n is equal to 2, it's going to be 5 pi over 2, n is equal to 3, 7 pi over 2. So the graph will be hitting infinity at all these points. So on the other end, this is negative pi over 2. This is going to be negative 3 pi over 2 and negative 5 pi over 2, negative 7 pi over 2. So the graph starts from 0, right? It is moving up, but exactly when it comes to pi over 2, it wouldn't, in fact it would just keep on moving. So this is the way the graph would move. And on the other hand, it will move up, down like this. So at x is equal to pi over 2, there is actually an asymptote here. So asymptote has to be drawn. So this is the way we draw the asymptotes. So there is no line of contact, or I should say there is no point of contact, right? So the line falls at negative pi over 2 and it rises at positive pi over 2. Now between pi over 2 and 3 pi over 2, you got a value pi, right? Now if you were to calculate the value pi, tan pi is nothing but sin pi divided by cos pi. Sin pi is 0, cos pi is negative 1. So at pi, the hit is at 0. So if I were to draw the graph hits this point like this and it moves up like that and it flows down. So there is an asymptote. So we need to draw that asymptote. And so similarly, it hits this point. There is a pi there, negative pi. So there is a hit and the graph moves up and it flows down. And we have to draw the asymptote. Okay. So that's an approximate graph. So I hope you are able to catch the gist of it. So similarly at 2 pi there will be a hit on the axis, on the x-axis, because that's going to give us 0, right? So having got that, let us write down the domain. Clearly I have mentioned to you the domain would be all x element of R such that I need to get this point out. So it should not have 2n positive 1 times pi over 2. So this point should not be included such that n is element of z. So this point will be removed from the domain, because at that particular point the function is actually becomes out of bound, or the function vanishes actually, because of the fact that tan 90 hits infinity. In fact, it's the better way is to represent is it approaches infinity, because it can't hit infinity, it can only approach. Okay, approaches infinity. So that has to be removed from R. Now the range is, from the graph itself you can see that it's going to be R, right? Because you can clearly see it has the ability to go all the way down, it has the ability to go all the way up. So the best way to represent the range is the set R. And period, in this case, if you were to observe, at every pi the graph will repeat itself. So the periodicity for tan x graph is pi. Now since tan x has got sin x, the function is an odd function. So these are some of the important characteristics of the tan x graph, which is important to perform questions that are dealing with the function as such. Now we will start off with trigonometric formulas and identities that are required. So when I say trigonometric formula, it means it comprises of trigonometric table, the periodicities, and the reciprocal identities, the complete list. So that's exactly what I'm going to give you here. So foremost, let's start with something basic, identities. So the first and foremost one which we all are supposed to know is sine squared theta. I'm using theta, you can use theta, alpha, beta, or phi or x, because this just mentions an angle. Since it is conventionally used, I'm using theta there. So the first one is sine squared theta positive cos squared theta is equal to 1. The next one is sine squared theta is equal to 1 minus cos squared theta. The third one is cos squared theta is equal to 1 minus sine squared theta. And then 4, you got secant squared theta negative tan squared theta is equal to 1. And the fifth one is cosecant squared theta negative cot squared theta is equal to 1. So this comprises of basic identities. Now there is something called reciprocal identities which we will have to know. Reciprocal identities. So though they are all such presented in this following fashion. 1 over, in fact let me write it like this, 1 over sine theta is equal to cosecant theta. Number 2, 1 over cos theta is equal to secant theta. Number 3, 1 over tan theta is equal to cot theta. Right? So that's a very important formula that you will have to know. 1 over tan theta is equal to cot theta. Now these formulas can also be interchanged. Say for example, you can likewise write sin theta is equal to 1 over cosecant theta. You can just flip them, right? And cos theta is 1 over secant theta. So that is also possible, right? I have mentioned it for cosecant theta and secant theta, but we can also mention it in terms of sin theta. But usually they don't do it, but apparently it's always possible. So from here, in this case, formula number 6, I can write tan theta is equal to 1 over cot theta. So these can be used whenever there arises a demand, there arises a requirement. So we need to keep an open mind when it comes to problem solving. So it is imperative to mention here that all these are taken from right-angled triangle. Right-angled triangle. So you can use the word right-angled triangle or right triangle. It doesn't matter because it has an angle 90 degrees. So let's move on. Now the next important information that we will have to have in our minds is what is called as the trigonometry table. Now you will have to apply some memorization techniques here, because that would come in handy, because we cannot be applying the formulae or resorting to the calculator every time we encounter an angle. So if you have it in your mind, stored in your mind, you can be efficient when it comes to solving questions against the race that time puts up. So let's start. So the first row will have angles in degrees, right? I'm giving it both angles in degrees. And the second row is going to have angles in radians. RAD stands for radians. So usually we start with 0 degree and then 30 degrees followed by 45 and then 60 and then 90, 180, 270 and then 360. That's it. So these are all standard angles which you have to know. So in terms of radians, 0 degrees is 0. This is going to be pi over 6. This is pi over 4. This is pi over 3. This is pi over 2. This is pi. This is 3 pi over 2 and this is 2 pi. Right? So now comes the famous sine. So when we're talking about sine, we're talking about sine 0, right? So sine 0 is 0, sine 30 is 1 over 2, sine 45 is 1 over root 2, sine 60 is root 3 over 2, sine 90 is 1, sine 180 is 0, sine 270 is going to be negative 1, 3 pi over 2, and this one is going to be 0. So this is for sine. And then you got cos 0 is 1, cos 30 is root 3 over 2, cos 45 is 1 over root 2, cos 60 is 1 over 2, cos 90 is 0, cos 180 negative 1, cos 270 that's going to give me 0, cos 360 that's going to be 2 pi, that's going to be 1. So that's for cos. Now tan 0 is 0. Tan 30 is going to be 1 over root 3, because tan is sine over cos, so sine divided by cos, 1 over 2, root 3 over 2, so you flip it, you get 1 over root 3. And tan 45 is 1, and tan 60 is root 3, tan 90 is infinity, tan 180 is 0, right? and tan 270 is infinity again because of the involvement of pi over 2, and tan 360 is going to give me 0. So these are for the main trigonometric arteries, right? So now comes the reciprocal. So sine 1 over sine is cosecant, right? So what I can do now is I will start, instead of starting with cosecant, because cosecant and the sine are further away, so let me start something closer to tan. So that's going to be cotan. So cot. So cot 0 is actually, cot is 1 over tan, right? So 1 over 0 will be infinity, and this one is going to be root 3, this is going to be 1, this is going to be 1 over root 3. Tan 90 will give me 0 here, right? And tan 0 is going to be infinity. So this is 180, because tan 180 is 0. When it comes to cot, it's going to be infinity. And this is going to be 0, and this is going to be giving me infinity. So that's fine. That's a nice way to place the values. So now comes after cos, I should say after cot, you got cos. Cos is actually secant theta, right? So let me write that down so that we can go up further like that. So secant theta is nothing but 1 over cos, right? So secant 0 is 1. This is going to be 2 divided by root 3. I can write it like this. This is going to be root 2. This is going to be 2. This is going to be infinity, right? Because secant 90 is 0. So this is going to give me infinity. This is going to give me negative 1. This is infinity. And this is going to be 1. So that is for secant. So let me just draw the block. So now comes cosecant. Cosecant is actually 1 over sine, right? So 1 over 0, that's infinity. This is 2. This is root 2. This is 2 over root 3. This is 1. This is infinity. This is negative 1 and infinity. So this is what we have got for cosecant. So that's a nice way. So all that you need is 1, 2, 3, sine theta, cos theta and tan theta, and you will be able to complete this beautiful table. So we'll move on, students. Now next comes what is known as sum and difference formula. So this is a very important concept you will have to know. The first one is sine of A positive B is equal to sine A cos B positive cos A sine B. It's formula 1, formula 2. Sine of A minus B is equal to sine A cos B minus cos A sine B. Cos of A positive B is equal to cos A cos B minus sine A sine B. Cos of A negative B is equal to cos A cos B positive. And it is negative, it becomes positive, and this positive becomes negative. So it's going to be sine A sine B, right? Now we got a formula for tan. Tan of A positive B, this is very important, is equal to tan A plus tan B divided by 1 negative tan A tan B, and tan of A negative B, that's also critical, right? So that is going to be equal to tan A negative tan B divided by 1 positive tan A tan B. Now I can actually prove this, that tan of A positive B is equal to tan A positive tan B divided by 1 negative tan A tan B. So let me give you this proof. So I want to consider the right hand side, which is tan A plus tan B divided by 1 negative tan A tan B. So I know tan is sine A over cos A, and tan B is sine B over cos B divided by 1 negative sine A cos A sine B cos B. Now if I were to take the LCM, cos A cos B, this would give me sine A cos B plus sine B cos A divided by this, again I'm taking the LCM as cos A cos B, so that's going to be cos A cos B negative sine A sine B. So cos A cos B can be cancelled. Sine A cos B plus sine B cos A, what is that? That's nothing but sine of A plus B. So this is equal to sine of A plus B divided by cos A cos B negative sine A sine B. Cos A cos B negative sine A sine B. What is that? Cos of A plus B. So write that, cos of A plus B. Now what is sine over cos? Tan. What is the argument? A plus B. So which is equal to the left hand side. So this is just proof for you to understand. So having given that, let me move on to formula number 6. I have added this to 6. So in 6 we will have to look into double angle identities. So let me state that, double angle identities. Now just some other information. Now I can similarly replace tan by cot. So let me just consider that. So tan is 1 over cot, right? So this is going to be 1 over cot of A positive B, which is equal to 1 over cot A plus 1 over cot B divided by 1 negative 1 over cot A times 1 over cot B. Now this is equal to, if I were to take the LCM as cot A cot B, this is going to be cot B positive cot A divided by cot A cot B negative 1 divided by cot A cot B. Cot A cot B can be cancelled. So you have 1 over cot of A positive B is equal to cot A plus cot B divided by cot A cot B negative 1. So if I were to flip this, I move this and move this and I push that down. So I would get, therefore this would mean I got cot A cot B negative 1 divided by cot A plus cot B. I've already moved this to the other end, so it's going to be cot of A positive B. So you got a beautiful formula here. So I can take this as 6. Cot of A positive B is this. Now simultaneously you can have cot of A minus B, right? It's all the same way. So we will stop with 6 and then we will move on to studying the formulae connecting double angle identities. The first and foremost formula that we will have to know is sine 2x is equal to 2 times sine x cos x. So this is of high importance. Okay, now from this there are other deductions that are possible. So let me just consider 2 times sine x cos x. Now what I wish to do is I would like to divide by 1, and then I would like to rewrite 2 times sine x cos x over 1 as sine squared x positive cos squared x. It's fair enough, right? Now I would like to take cos squared x out as a common factor, and that would give me sine squared x over cos squared x positive 1. But sin x over cos x is equal to tan x, and this would mean sine squared x over cos squared x is equal to tan squared x, right? So I can substitute that. So this is equal to 2 times sine x cos x divided by cos squared x of tan squared x positive 1. Now I would like to cancel a cos and a cos here, giving me 2 times sine x divided by cos x times, I'm going to write tan squared x positive 1 as 1 positive tan squared x. Right? Now let me divide the numerator and the denominator by cos x. So that would give me 2 over sine x divided by cos x divided by cos x divided by cos x times 1 positive tan squared x. Cos x gets cancelled, giving me 2 times sine x over cos x is tan x divided by 1 positive tan squared x. So I got a new formula. What is that? Sine 2x, which was written as 2 times sine x cos x, can also be written as 2 times tan x divided by 1 positive tan squared x. A very, very important formula that will come in handy in solving many questions. Now let's head on to cos. So formula 2. Now cos 2x is cos squared x negative sine squared x. So this is an important formula also. Now simultaneously we can have many representations for cos 2x. Since I've started with cos squared x negative sine squared x, I'm going to rewrite sine squared x as 1 minus cos squared x. So this is going to give me cos squared x negative negative positive cos squared x and a negative 1, which is going to be 2 times cos squared x negative 1. So this is another important formula. Now instead of replacing sine squared x with 1 negative cos squared x, what would be the situation if I were to replace cos squared x with 1 negative sine squared x? So that's going to be 1 negative sine squared x followed by a negative sine squared x, and this is going to give me 1 negative 2 times sine squared x. Another important deduction we have arrived at. So cos 2x can also be written as 2 times cos squared x negative 1, or 1 negative 2 times sine squared x, or cos squared x negative sine squared x. Now what we can further do is we can actually deduce cos squared x minus sine squared x again in a different fashion. So what I would do is I would like to write cos squared x negative sine squared x to be as cos squared x negative sine squared x divided by 1, now which is nothing but cos squared x negative sine squared x divided by 1 can be written as cos squared x positive sine squared x, right? Now let me take cos squared x out. So if I were to take cos squared x out, I would get 1 negative sine squared x divided by cos squared x for the numerator. In the denominator, again I wish to take cos squared x out. This is going to give me 1 positive sine squared x over cos squared x, right? Now cos squared x can be cancelled. Sine squared x over cos squared x is tan squared x. So I got 1 negative tan squared x divided by 1 positive tan squared x. You see that? This is also a very important deduction for cos 2x. To wrap up, let me give the equivalent for tan 2x. Now tan 2x is equal to 2 times tan x divided by 1 negative tan squared x. This is 3. And for secant 2x is equal to secant squared x divided by 2 negative secant squared x. And number 5, cosecant 2x. Let me write that down here. Cosecant 2x is equal to secant x cosecant x divided by 2. So these are all some of the double angle identities which would come in very much handy. So this is cosecant 2x, and secant 2x is secant squared x divided by 2 negative secant squared x. All of these things can be easily proved, and with that we will actually move on to other identities. Students, let us do the following questions to get a greater insight into trigonometry. So we are given this question: consider a square of side 4 centimeter and that a man runs at a distance of 1 centimeter from the sides of the square. Find the distance. They are asking us the total distance covered by the man. So we are given a square. So this is the square and the sides of the square are given to be 4 centimeter, 4 centimeter, 4 centimeter, 4 centimeter. And a man is actually running, right? And the distance between the man and the square is 1 centimeter. So if the man is running along like this distance is 1 centimeter. So he runs like this. Naturally he has to take a bend, then he runs again. Over here he has to take a bend, then he runs again. Over here he has to take a bend, then he runs again. Over here he takes a bend. So there are actually 4 bends. Now if you were to actually make an observation, you will find that there is a quadrant being made over here. There are 4 quadrants. So if there is a circle, if you were to divide the circle by 2 lines, you will see that 4 quadrants make up the circle. So actually what the man is doing, apart from covering the distance along the sides of the square, he is also covering 1 full circle. So the formula would be total distance covered by the runner, covered by the running man, is equal to the distance covered for the square, that's 4 into 4, plus the circle, that's going to be 2 pi r. So this is going to be 4 times 4. So let me just write that as 4 square, positive 2 times pi. My r over here is 1 centimeter, right? This is 1 centimeter, 1 centimeter, and 1 centimeter. So r is equal to 1 centimeter. So that would mean I now have 16 positive 2 times pi. But if I were to take the value of pi as 3.14, then this would be 16 positive 8 to 6, and if I were to add 16 with 6, that would give me 6 added with 6 is 12, carry 1 to 22.28 cm. So this is the total distance covered by the runner. So that is the solution. Of course, this is a simple question, but it's always good to start with questions of meager sum difficulty and then gradually scale up. So we'll move on to the next. Consider formula 7. So I'm going to show you how exactly it is proved. So cosecant square theta negative cot square theta is equal to 1. So what I wish to do is I will say consider the left hand side. So what is on the left hand side? cosecant square theta negative cot square theta. I'm going to replace cosecant square theta as 1 over sin square theta. Cot square theta is cos square theta over sin square theta. If I were to take LCM as sin square theta, I get 1 negative cos square theta. 1 negative cos square theta is sin square theta divided by sin square theta. They get cancelled, is equal to 1, which is equal to right hand side. So everything can be proved, and we will also be using cot theta to be as cos theta over sin theta, and tan theta to be as sin theta over cos theta. So these are all some popular directions. So having given that, the next one that you will have to know is sin raised to the power of 4 theta positive cos raised to the power of 4 theta is equal to 1 negative 2 times sin square theta times cos square theta. This is a very popular identity which you will have to remember. Now how do I prove it? So let me just start out like this. Consider the left hand side, which is sin raised to the power of 4 theta positive cos raised to the power of 4 theta. I'm going to rewrite this as sin square theta positive cos square theta raised to the power of 2. If I expand this, I would get 2 times sin square theta cos square theta. So I can take that out. So this is going to be 2 times sin square theta cos square theta. But sin square theta added with cos square theta is 1. So this is going to be 1 negative 2 times sin square theta cos square theta. So this is a very important formula, and it is imperative that you take note of it. Now there is another important trigonometric identity which you will have to know, and that is sin raised to the power of 6 theta positive cos raised to the power of 6 theta is equal to 1 negative 3 times sin square theta cos square theta. Now I can give you the proof. So I'll start off like this. Consider the left hand side, which is sin raised to the power of 6 theta positive cos raised to the power of 6 theta. I'm going to rewrite this as sin squared theta raised to the power of 3 positive cos squared theta raised to the power of 3. Now there is a formula in algebra. We know that a cubed positive b cubed is a positive b times a squared negative ab positive b squared. So using this formula over here, this is nothing but a positive b. So sin square theta positive cos square theta times, and you have a squared. So a squared is going to be this raised to the power of 2. So that is going to be sin square theta. This is my a, right? But I have to raise it to the power of 2. So that would mean I got sin raised to the power of 4 theta negative ab. My a is sin square theta, my b is cos square theta. So this is going to be sin square theta cos square theta positive b squared. My b is cos square theta, squared is going to be cos raised to the power of 4 theta. So I can rewrite this. This is a formula. So I can rewrite this as sin square theta positive cos square theta is 1 times, I'm going to club these two together. This is going to be sin raised to the power of 4 theta positive cos raised to the power of 4 theta negative sin square theta cos square theta. But what is sin raised to the power of 4 theta positive cos raised to the power of 4 theta? This is the formula. You see that? Take this and substitute here. So this is going to be equal to 1 negative 2 times sin square theta cos square theta. Already there is sin square theta cos square theta. Sin square theta cos square theta can be added. So that would give me 1 negative 3 times sin square theta cos square theta. So this is a very important identity that you will have to remember. So what is the identity? The identity is sin raised to the power of 6 theta positive cos raised to the power of 6 theta is equal to 1 negative 3 times sin square theta cos square theta. Next, we will have to know what is called as the cast rule. You can either call it as cast rule or the name that you would like to start with. They will also mention it as ASTC rule, right? And then I will also explain to you the reduction formula. So it's a very important topic, and I would say it's the art of trigonometry. When I say art, I meant this art, right? The core concept in trigonometry. Now, if you were to take the quadrant, now we always refer trigonometry relativity with quadrant. Always we talk about the angles with reference to the fourth quadrant. So this is the first quadrant. So when I say quadrant, you spell it like this: QUADRANT, the quadrant. So this is one quadrant. So this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Of course, the angles, the measure is from 0 to 180 degrees, and then it goes up to here 270 degree and ends here at 360 degrees. In the first quadrant, we say A. So that means all ratios are positive. All ratios are positive. So what does it mean all ratios are positive? It means sine is positive, cos is positive, and tan is positive, and the reciprocals. The reciprocal of sine is cosecant theta, it's positive. Reciprocal of cos theta is secant theta, it's positive. Reciprocal of tan theta, that is also positive in the first quadrant. Now in the second quadrant, only sine is positive. Only sine is positive, and its reciprocal. The reciprocal for sine is cosecant theta, right? And cosecant theta is positive. So only these two are positive in the second quadrant. In the third quadrant, tan is positive and it's reciprocal. That's cot. Only these two are positive. In the fourth quadrant, cos alone is positive, and its reciprocal, which is secant theta, that is positive. So when we say exactly cast, so we talk about like the CAST. That's what we say. So have that in mind, and with some problems you will be able to gain a mastery on that. Now, having mentioned the cast rule, now let me mention the reduction formula. Now there are two important formulas which you will have to know, and they are very powerful. That is, if you were to be asked to find sine of some constant multiple of pi plus theta, the outcome will always be either plus or minus sine theta. There wouldn't be any change in this. The only thing that will change is the sign, either a plus or a minus, but sine will always be occurring with the angle. So this is one. The next formula is, if you were to be asked sine of some constant times pi over 2 positive theta, then the outcome would be plus or minus cos theta. So in this case, cos will be there no matter what, because of the fact that you got k times pi over 2. But the only change would be either a plus or a minus. So using this, we would be doing problems, and as I always mention, the best way to understand any concept is problem solving. So we will continue this lecture in the following class, students. Until then, have a nice night. Students, we would be finding now the value of the following. Now the first question is, what is the value of sine of pi negative theta? Now clearly in the formula I have given you, sine of k times pi positive theta would be equal to plus or minus sine theta, depending upon the quadrant that we have. So in this case, the problem is sine of pi negative theta. Now if we were to draw the quadrant, we know all ratios are possible. Sine alone is positive here, and tan is positive here, and cos is positive. So when I say cos is positive, it means cos and its reciprocals are positive, sine and its reciprocals are positive, tan and its reciprocals are positive. So this is going to be 0, this is 90, this is 180, this is 270, and this is 360 degrees. Now pi negative theta, now this is pi. Now whenever you have a negative sign, you are basically talking about a coordinate or a point between 180 and 90. So remember, always negative sign means you move up, positive sign you move down. So since it is in the second quadrant, sign is always positive here. So this is going to be, I know that it's going to be sine theta because of the formula I've given you, and the sign is going to be positive. So that is the solution for the first question. Now question number 2. Let us see what would be the situation if they have given us sine of pi over 2 negative theta. I've clearly given you the formula. Sine of k times pi over 2 positive theta is equal to plus or minus cos theta. So 90 degree is over here. I already told you, if it is negative, it will move in this direction. So that means we are looking at a quantity which is in the first quadrant. First quadrant means all ratios are positive, so the sign is going to be positive. But apparently we need to have a cos theta there because of the formula. So that is the solution for the second question. So let's go and do the third question. Third question wants us tan of pi positive theta. Now remember, the formula which I've given you for sine will also go for tan. Okay, so have that in mind. So in this case, we would be looking at, in this case we're getting sine here, so we would be getting tan here, tan theta. The main point is it a positive sign or a negative sign? Is it a plus or a minus? So as I mentioned to you, 180 is over here between the second quadrant and the third quadrant, and anything positive will be located over here. So this would mean tan is always positive in this case, so it's going to be plus or positive tan theta, depending upon what you would like to say, whether it's positive tan theta or plus tan theta. Now coming to the next question, question number 4. Let's see what happens to secant of 3 pi over 2 positive theta. Now what is secant theta? Now secant theta is nothing but 1 over cos theta. So it's a reciprocal of cos. Secant theta is a reciprocal of cos. Now we have secant of 3 pi over 2 positive theta. So the question is, what would be the output? Now when it is sine, please watch here, if it is sine k pi over 2 positive theta means we are getting cos. On the contrary, if it is cos, then we would get a sine. So in this case it is secant, so we would get a cosecant. Okay, so 3 pi over 2, 3 pi over 2 is nothing but 3 multiplied with 90, which is nothing but 270 degrees. So the position is over here, 270 degrees is over here. Positive sign, as I mentioned to you, positive means it will be located on this side. So over here cosine is actually a positive sign, positive ratio. Cosine along with this reciprocal, which is secant, will produce a positive ratio. So in this case we will have a positive sign. Okay, so moving on, let's do the next question. The next question is cot of 11 pi over 2 negative theta. Now what is this? Now as I mentioned to you, when we add tan, the outcome would be cot, but in this case we got cot because of the presence of pi over 2, so the outcome is going to be tan. Now the question is it a positive tan theta or a negative tan theta? That is the decision that we will have to take. So how do we take it? Now first foremost, let us find out what is 11 pi over 2. 11 pi over 2 is nothing but 990. Whenever an angle that we get is greater than 360 degrees, we have to keep subtracting 360 degrees from this angle until we get a value which is lesser than 360. So in this case, we got 990. Let me subtract 360 degrees. So this is going to be 0, this is going to be 3, and from 9 I have to take away 3, I will get 6. So now I got 630 degrees. Again, it's greater than 360 degrees. So subtract 360 degrees from this. So this is going to be 0. I borrow 1, 13. From 13 I take away 6, that will be 7. This is 5. From 5 I take away 3, it's going to be 2. So 270 degrees is less than 360 degrees. So we stop here. So where is 270 degree? It is between the third quadrant and the fourth quadrant. So this is the point that we are looking for. Now the question is, we have negative. So negative means we go towards the left. Okay, so this is the location that we are looking for. Now in this case, tan is positive and its reciprocal is positive. That is, cot is also positive. So we have a positive sign. Simple, isn't it? So finally, let us talk about secant of 7 pi positive theta. Now what is this 7 pi? 7 pi is nothing but 7 times 180. What is that equal to? 0. 7 times 8, 7 8s are 56, 5, and 7 1s are 7, positive. We need to add 5, so we are getting 1260. So we have to subtract 360. So let's see what happens. So as I mentioned before, if an angle is greater than 360, you keep subtracting 360 from the outcome. So let me do that. 360, I'm subtracting, I get 0, 0. This is going to be 900. That's 9. So again, it's greater than 360. I'm going to subtract 360 now. 0, 10, and 4. This is 8. I get 5. So 540. Again, I subtract 360. So 0. This is going to be 8, 4, 180. So 180 degrees. So 180 degree actually lies between the quadrant 2 and quadrant 3. So this is the point that we're looking for. Now positive sign. Positive sign means it will go down. In this case, only tan and its reciprocal cot is positive. So we will have a negative sign there, right? And since we are talking actually about secant, secant is nothing but the reciprocal of cos. So directly this would also be cos. In this case, instead of we need to place a reciprocal for cos, right? So we will place here negative secant theta. Students, let's do this question. We are asked to find the value, and this is the expression that's been given. Tan pi over 11 positive tan 2 pi over 11 positive tan 4 pi over 11 positive tan 7 pi over 11 positive tan 9 pi over 11 positive tan 10 pi over 11. So this is the question that is being given to us. Now let me rewrite this as follows. This is, I'm not going to do anything to tan pi over 11, and I will also retain tan 2 pi over 11, and I will also retain tan 4 pi over 11. Now tan 7 pi over 11, I would like to write it as tan pi negative 4 pi over 11. 11 times pi gives me 11 pi, minus 4 pi divided by 11 would be 7 pi over 11. Positive, I want to write 9 pi over 11, tan 9 pi over 11 as tan pi negative 2 pi over 11. So this, if you were to simplify, this is going to be 11 pi minus 2 pi divided by 11. So that's going to be 9 pi over 11. So we would be getting this. So followed by positive tan pi negative, I would be having this as pi over 11, because 11 times pi gives me 11 pi minus pi, that's going to be 10 pi. divided by 11. So this is what we would get. Now, having obtained this, now we know that tan of pi negative theta. What is that? Tan of pi negative theta. This is going to give me tan theta, of course, that is there. But we need to decide on the sign. Is it a plus or a minus? Now go to the quadrant. First quadrant, all ratios possible. Second quadrant, sine alone is possible. Third quadrant, tan is possible. I mean, when I say possible, it means positive, right? So that's exactly what I'm meaning. So all ratios are positive. Sine alone is positive. Tan alone is positive. Cosine alone is positive with the fourth quadrant. Now, as I mentioned to you, when you talk about 180 is over here between the second and the third quadrant. And when you are required to subtract something, I told you, you should go above. So over here, you go up. If it is positive, you go down. So if you are here, you are expected to take a minus like this, you will have to go to the left. And positive sign will always lead you to the right. So I have already mentioned this. So in this case, it's 180 negative. Over here, negative means it lands up in the second quadrant and only sine is positive here. So tan is not positive. So this would mean you would get a negative. We would be using this formula. So by this formula, what would happen? Let me rewrite that. The expression. So this expression would now be rewritten as, so let me have it like this, tan pi over 11 positive tan 2 pi over 11 positive tan 4 pi over 11. Now tan of pi negative 4 pi over 11. So this is going to be negative of the angle, right? So it's going to be negative tan this angle. That's going to be 4 pi over 11. So positive, this is tan of pi negative 2 pi over 11. So this is going to be negative, right? So it's going to be negative of tan 2 pi over 11. So it's already positive here. Positive times negative will become negative. So finally, tan of pi negative theta. So that's going to be negative tan theta. So this is going to be negative tan of pi over 11. So clearly positive pi over 11, negative pi over 11 can be cancelled. This is going to be negative tan 2 pi over 11 and positive tan 2 pi over 11. They can also be cancelled. This is tan 4 pi over 11 and followed by negative tan 4 pi over 11. So they can be cancelled. So giving me the output of 0. So that is the solution for this beautiful question. So we can move on to the next question. So next, students, we will have to deal with negative angles. What would be the situation when theta is negative? So when I talk about negative angles, we are talking about the trigonometric ratio of sine, cos and tan. So sine of a negative angle, that's negative theta, is going to be negative sine theta. A very important outcome. And cos of negative theta is equal to cos theta. And similarly, you got tan of negative theta is equal to negative tan theta. So the reciprocal of sine is cosecant. Similarly, cosecant of negative theta is equal to negative cosecant theta, and reciprocal of cos is secant. So secant of negative theta is equal to secant theta. Reciprocal of tan is cot. So cot of negative theta is equal to negative cot theta. This is called even function. And this along with this are called as odd function. Okay, so have that in mind, even function and odd function. Let's do this question, students. We are expected to find the value of sine for 20 degrees times cos 390 degrees positive cos 300 degrees times sine of negative 330 degrees. Now, since sine of negative theta is negative sine theta, I would be using that over here and rewriting this entire component as, this is sine 420, right? So this is going to be sine of 420 cos of 390 negative cos 300 times sine 330. This is what I've got. Now let me evaluate first sine 420. Now I would like to write sine 420 as sine of 450 negative 30. Now I've told you already, if you are given an angle which is greater than 360, this is clearly greater than 360, subtract 360 from this. So 450 negative 360 would give me 90 degrees. So that means we are looking at an angle which is actually between, or I would say it is in the between first and the second quadrant, right? So 90 degrees over here. So this is what we are looking at. Now I can actually rewrite this as sine of 5 times pi over 2, because this is going to give me 90. 90 times 5 is going to be 450 negative. This is actually, let me just take it as theta. So from the formula which we have studied earlier, this is going to be equal to cos, right? So this is cos theta. The only thing is that we are worried about the sign, whether it's positive sign or negative sign, because it's 90, so it's over here, so that means all ratios are positive, so there's going to be positive cos theta. So according to this, of course we don't have to mention this is for your understanding. So what I'm going to do is I'm going to rewrite this as sine of 5 times pi over 2 negative 30 degrees, which is nothing but cos of 30 degrees, and the sine is actually a positive sign, okay? Because when we talk about you know the sign being negative, so it would be on the first quadrant over here. So that's why I'm just taking it as positive. In fact, it is positive. But what is cos 30? Cos 30 is going to be root of 3 divided by 2. This is the value for sine of 420. So we have got that value, and let me place it in a box. Now next comes cos of 390 degrees. Now what is cos of 390 degrees? I can write cos of 390 degree as cos of 360 degree positive 30 degrees, right? Now what is this? This is nothing but cos of 2 times pi. This is k times pi positive theta. Now this is going to be equal to cos theta. There wouldn't be any change in it, but the only thing is that is it plus or minus. Now 360 degrees is over here, right? So if I were to talk about a positive sign over here, if we are going to take a plus, it will land up in the first quadrant where all ratios are positive, right? So that would mean this is rewritten. Anyway, this is basically the formula which we have. So it's going to be positive here. So let me write the outcome here. So it's going to be cos of 2 times pi positive 30 degrees, which is going to be positive cos 30, which is going to be root of 3 over 2. So we've got the value for cos. So in fact this is actually cos of 390 degrees. So this is the value for cos 390. So having obtained cos 390, let us obtain what is cos 300 degrees. Now cos 300 degrees is nothing but, I can rewrite this as cos of 360 degree negative 60 degrees, right? Now this is nothing but cos of 2 times pi negative theta, right? So in fact it's I can just, let me just write the formula out. So this is going to be cos of theta, but I'm not sure if it is going to be plus or minus, so let me check that out. So 360 degrees over here, so if it is minus, it is going to come down here, where cosine is positive, so it's going to be positive sign there. So that would mean this is equal to cos of 2 times pi negative 60, which is equal to positive cos of 60, which is nothing but 1 over 2. So that is the value for cos 300 degrees. So now comes sine. We need to find sine 330 degrees. Now sine 330 degree is nothing but sine of 360 degrees negative 30 degree, which is nothing but sine of 2 times pi negative 30. Now of course we all know this is going to be sine 30, but the question is it positive or negative? So 360 is here. Now if I were to take a negative of this, okay, it is going to come down here. Only cosine is positive, so it's going to be negative sine 30, which is nothing but negative 1 over 2. So if I were to take the values and substitute, so therefore this would imply, let me write down the question, sine of 420 times cos of 390 negative cos 300 times sine 330 is equal to sine 420 is root 3 over 2 times sine cosine 390. Cosine 390 is root of 3 over 2 negative cos 300. Cos 300 is 1 over 2 times sine 330. Sine 330 is negative 1 over 2. So this is going to give me root 3 times root 3 gives me 3. 2 times 2 gives me 2 squared. 1 times 1 with a negative sign gives me positive. It's going to be 1. 2 times 2 is going to be 2 squared. I take the LCM as 4. This is going to be 3 positive 1, which is nothing but 4 divided by 4, which is equal to 1. So this is a beautiful question and it requires some working. So I hope you enjoyed this question, students. We'll move on to the next one. Students, let's do this question. We are expected to evaluate the following expression, which is 3 times of sine raised to the power of 4 of 3 pi over 2 negative alpha positive sine raised to the power of 4 of 3 pi positive alpha negative 2 times of sine raised to the power of 6 of pi over 2 positive alpha positive sine raised to the power of 6 of 5 pi negative alpha. Right, now this is going to be cos, and because of even power, plus or minus, it's not going to matter. So this is going to be cos raised to the power of 4 alpha. Positive, this is going to be sine. As I mentioned to you, the degree is 4. So this would produce as sine raised to the power of 4 times alpha. Negative 2 times, this would produce as cos raised to the power of 6 times alpha. This would produce as positive sine raised to the power of 6 times alpha. So this is what we've got. Now I will be using the identity. What is the identity? We know that since we know that sine raised to the power of 4 alpha positive cos raised to the power of 4 alpha is equal to 1 negative 2 times sine squared alpha times cos squared alpha. Also we know that sine raised to the power of 6 alpha positive cos raised to the power of 6 alpha is equal to 1 negative 3 times sine squared alpha times cos squared alpha. These two identities we proved. So with the help of the identity, I am going to rewrite this as 3 times of 1 negative 2 times sine squared alpha times cos squared alpha negative 2 times 1 negative 3 times sine squared alpha times cos squared alpha. Now this implies you now have 3 negative. 3 times 2 is 6. So let me write that. 6 sine squared alpha cos squared alpha negative 2 times negative negative positive 6 times sine squared alpha times cos squared alpha. Positive 6 times sine squared alpha times cos squared alpha can be cancelled with 6 times sine squared alpha cos squared alpha with a negative sign. 3 added with negative 2 would give me 1. So this is the solution for this beautiful question. And these are some of the important identities you will have to know. So to start with, sine of A positive B is equal to sine A cos B positive cos A sine B. Identity 2, sine of A negative B is equal to sine A cos B negative cos A sine B. Identity 3, cos of A positive B is equal to cos A cos B negative sine A sine B. And finally, cos of A negative B is equal to cos A cos B positive sine A sine B. So when we talk about compound angles, these are the compound angle formula connected with sine and cosine. So having mentioned this, let's move on, students. Now, having given you the compound angle formula for sine and cosine, now let me give you the compound angle formula involving tan and cot. So let me write down compound angle identities, in fact. I call them as identities involving tan and cotan. So the first and foremost important one is tan of A positive B is equal to tan A positive tan B over 1 negative tan A tan B. Formula number 2, tan of A negative B is equal to tan A negative tan B divided by 1 positive tan A tan B. So this is for tan. Now let me write the equivalent for cotan, that's cot. So cot of A positive B is equal to cot A cot B negative 1 divided by cot A positive cot B, and cot of A negative B is equal to cot A cot B positive 1 divided by cot. In this case it would have to have a reversal here. So this is A minus B, so we won't have it as cot A negative cot B, we'll have it as cot B negative cot A. So that is how it would be obtained as. Now we can verify all of this, right? It's possible to verify each and every formula, and that wouldn't be a difficult task. So having given this compound angle formula, I would suggest that you practice them thoroughly so that it becomes second nature for you. Let me just show you the proof of one of these formulae. So I would like to show you how exactly cot of A negative B is equal to cot A cot B positive 1 divided by cot B negative cot A. Now what I wish to do is I would like to consider the right hand side. So what do we have in the right hand side? We got cot A cot B positive 1 divided by cot B negative cot A. Now I can rewrite cot A as cos A over sin A times cot B as cos B over sin B positive 1 divided by cot B as cos B divided by sin B negative cot A as cos A divided by sin A. Now if I were to take the LCM for the numerator, this is going to be sin A sin B, and I would have cos A cos B positive sin A sin B, right? This entire thing is divided by, if I were to take the LCM as sin A sin B, I would get cos B sin A negative cos A sin B. Now this has to be divided by sin B sin A. Clearly you can see sin A sin B sin B sin A, they can be cancelled, giving us cos A cos B positive sin A sin B divided by, I can write this as, okay, let me write it as cos B sin A negative cos A sin B. So this is what I've got. Now cos A cos B, and I've got sin A sin B. So this is going to be cos of A minus B divided by, now I got sin A cos B negative sin B cos A. So what is this? This is nothing but sine of A minus B, right? But what is cos over sine? Cos over sine is nothing but cot. And what do we have? We got A minus B. And what is that? That is nothing but equal to the left hand side. You see that? So hence proved. So that's the end of solution. So having given you all this, there is one more important formula you will have to know. So this is 1, 2, 3 and 4. There is a fifth one which is very important, and that is tan of pi over 4 plus or minus a, which is equal to 1 plus or minus tan a divided by 1 minus or plus tan a. Now this result can be easily proved from tan of a plus b formula, right? So I can just show you this. So if we were to ask tan of pi over 4 positive a, we can just use tan of a plus b, which is nothing but tan a plus tan b divided by 1 negative tan a tan b, which is in this case is going to be tan pi over 4 plus tan a divided by 1 negative tan pi over 4 times tan a. Tan pi over 4 is 1 positive tan a divided by 1 negative tan pi over 4 is 1 times tan a. So I have that in mind. This is 1 plus tan a divided by 1 minus tan a. So this is what we have got for tan pi over 4 positive a. So this is the result. So the result can also be obtained for tan pi over 4 negative a. So the sign will get reverted. So having given you all this formula, we can move on to do application oriented questions. So when I mean application oriented question, I mean how exactly or where exactly we apply these compound angle return identities. Students, we are going to see further important identities which would come in very much handy. The first one is sine of a positive b times sine of a negative b is equal to sine squared a negative sine squared b. This is a very important identity. The question is, how are we going to get it proved? So let me just start off like this. Consider the left hand side, which is sine of a positive b times sine of a negative b. We know the formula for sine of a positive b, or a plus b, which is sine a cos b positive cos a sine b. This has to be multiplied with sine of a minus b, which is nothing but sine a cos b negative cos a sine b, right? So this is a plus b times a minus b, which is nothing but a squared minus b squared. So this is rewritten as sine squared a times cos squared b negative cos squared a times sine squared b. I would like to rewrite cos squared b as 1 negative sine squared b, and similarly I would like to rewrite cos squared a as 1 negative sine squared a. I would like to distribute the quantity, so that would give me sine squared a negative sine squared a times sine squared b negative sine squared b negative negative positive. This is sine squared a times sine squared b. Negative sine squared a times sine squared b would be cancelled with positive sine squared a sine squared b, thereby giving me sine squared a negative sine squared b, which is equal to right hand side, hence the result. Right, so this is a very important identity that we would be using in future. So having obtained this proof, we will move on, students. So similarly, there are two more identities which are important, and that would be involving cos of a positive b multiplied with cos of a negative b, which is equal to cos squared a negative sine squared b is the second one, and there is the third one, which is nothing but tan of a positive b positive c, which is equal to tan a positive tan b positive tan c negative tan a tan b tan c divided by 1 negative tan a tan b negative tan b tan c negative tan c tan a. Right? Now next comes what we call as the transformation formulae. So we looked into the product when sine of a positive b is multiplied with sine of a negative b. Now it is addition, right? Summation. So the first one is going to be sine of a positive b positive sine of a negative b is equal to 2 times sine a cos b, followed by sine of a positive b negative sine of a negative b is equal to 2 times cos a sine b. So have that in mind. So in this case it's cos a sine b. And formula 3, cos of a positive b positive cos of a negative b is equal to 2 times cos a cos b. And formula 4, cos of a negative b followed by a negative sign cos of a positive b is equal to 2 times sine A, sine B. Now, having given you all this, if I were to take A positive B to be equal to C and A negative B to be equal to D, if I were to add, then this is going to be 2A is equal to C positive D. Therefore, A is C positive D divided by 2. Now, if I were to take the value of A and substitute it over here, then I can suitably extract the value for B, which would be C negative D divided by 2, right? Because instead of adding here, if you were to get rid of A, let me show you that also. So I get A positive B is equal to C. In this case, A negative B is equal to D. I can subtract and get rid of A. So this is going to be negative, this is going to be positive, this is going to be negative. So A gets cancelled, giving me 2 times B is equal to C negative D. Therefore, B is equal to C negative D divided by 2. So this is the value for B, right? So if I were to substitute them in formula 1, what would happen? So therefore, I can rewrite 1 to be as sine of A positive B. In place of A positive B is going to be sine C positive A negative B, which is going to be sine D is equal to 2 times, in place of A it's going to be C positive D divided by 2 sine of C positive D divided by 2 times cos of C negative D divided by 2. So this is a important formula. Now I can just change everything. So formula 2, let me just write that down. Formula 2 can now be rewritten as sine of A plus B, which is nothing but sine C negative sine D is equal to 2 times cos of A, which is C positive D divided by 2 times sine of B, which is C negative D divided by 2. And formula number 3 is going to be cos A positive B, which is cos C positive cos of A negative B, which is D, is equal to 2 times cos of A C positive D divided by 2 times cos B, which is C negative D divided by 2. And formula number 4 is also rewritten as cos of A negative B, which is cos D negative cos A positive B C cos C is equal to 2 times of sine of A, which is C positive D divided by 2 times sine of B, which is C negative D divided by 2. Very important formula. Okay, so you will have to practice them. So practice makes perfect. Students, let's do this beautiful question by applying the formula which we just studied. So the question is given as follows: let alpha comma beta be such that alpha negative beta lies between pi and 3 pi. Now if sine alpha positive sine beta is equal to negative 21 over 65 and cos alpha plus cos beta is equal to negative 27 over 65, then we are expected to find the value of cos of alpha negative beta divided by 2. Now this is a question. Now let me start the solution in this fashion. given, what is given? Sine alpha plus sine beta is equal to negative 21 over 65. Now there is a formula which connects sine alpha positive sine beta. What is the formula? Sine C positive sine D is equal to 2 times sine of C positive D divided by 2 times cos of C negative D divided by 2. So this is nothing but 2 times sine of alpha positive beta divided by 2 times cos of alpha negative beta divided by 2, right? So this is equal to negative 21 divided by 65. So that's what we have got. Now also what we have got also given is cos alpha plus cos beta is equal to negative 27 divided by 65. So there is also a formula which connects cos alpha added with cos beta. What is that? That's cos C positive cos T. Now that is nothing but 2 times cos of C positive D divided by 2 times cos of C negative D divided by 2. So we get cos and a cos. But in this case we get sine and a cos. So this is going to be 2 times cos of alpha positive beta divided by 2. I'm just applying the formula. Positive cos of alpha negative beta divided by 2 is equal to negative 27 divided by 65. Now I'm going to divide one by the other. Okay, so this is going to be equal to 2 and 2 can be cancelled. Cos alpha negative beta divided by 2, cos alpha negative beta divided by 2 can be cancelled. So this is going to give me sine of alpha positive beta divided by 2 divided by cos of alpha positive beta divided by 2 is equal to negative 21 over 65. I flip it, I get 65 over negative 27. They become positive. 65 gets cancelled. This is 21 over 27. Now 3 divides here 7 times, 3 divides here 9 times. So this is 7 over 9. I can rewrite this as tan alpha positive beta divided by 2 is equal to 7 over 9. Now let me go and draw the right triangle. Now this is theta, opposite side by adjacent side, hypotenuse side. Now the angle given is alpha positive beta divided by 2 and opposite side is 7, adjacent side is 9, and this hypotenuse side is going to be 9 squared positive 7 squared. So what is that? 9 squared is 81, 7 squared is 49. So what do we get? 81 added with 49, 9 added with 1, 10, carry 1. This is 12 and 13, 130. So that's going to be, this is going to be root of 130, right? Now this is for sine, so therefore this is for tan, right? The values that we have just applied is for tan. From here we extract the value for sine. Therefore sine of alpha positive beta divided by 2 is going to be opposite side divided by hypotenuse side. What is opposite side? 7. Hypotenuse side is root of 130. This is for sine of alpha positive beta divided by 2. But we are expected to find the value for cos of alpha negative beta divided by 2. How am I going to get that? By using this equation, right? So if I were to name this as 2, therefore using 2 we get, what do we get? First write that down. 2 times sine of alpha positive beta divided by 2 times cos of alpha negative beta divided by 2 is equal to negative 21 divided by 65. This is going to be 2 times sine of alpha positive beta divided by 2 is 7 divided by root of 130. We need cos of alpha negative beta divided by 2, which is equal to negative 21 divided by 65. Now I have to use this part of the page, right? So if I were to flip it, or I should say cross multiply, is going to be negative 21 over 65 times root of 130 divided by 2 times 7, right? Now what happens here if I were to 7 divides here 3 times, right? And is there anything else I can handle with? I cannot handle anything else much more. So that's the last thing I can handle. So this is simplified, and we can just reduce that. So I can use this side. So this is going to be equal to, let me write that down, negative 3 times root of 130 divided by 2 times 65. So that's going to be 130, right? So this is 130, and I can further rewrite this as 3 times root of 130 divided by, this is going to be root of 130 times root of 130. I can cancel one of this, giving me negative 3 times root of 130, right? So this is the value for cos of alpha negative beta divided by 2. So this is the solution. Of course, we need to do some, some simplification is required, but it's still okay. So we have achieved the solution, and that's the important part of this particular question. Let's do this question, students. We are expected to find the value of sine 15 degrees. So how are we going to do this? Now I would rewrite sine 15 degrees to be as sine of 45 degrees negative 30 degrees, right? Then I will apply sine of a negative b formula. Now what is sine of a negative b formula? We know that sine of a negative b is sine a cos b negative cos a sine b. So by this formula, this is going to be sine 45 cos 30 negative cos 45 sine 30. Now we know that sine 45 is 1 over root 2, and cos 30 is root 3 over 2, cos 45 is 1 over root 2, sine 30 is 1 over 2. So this is going to be root of 3 over 2 times root 2 negative 1 over 2 times root 2. If I were to take the LCM as 2 times root 2, I would get root 3 negative 1. I wish to multiply the numerator by root 2 and divide by root 2. This would give me root of 3 times root 2 would give me root 6 negative root of 2 divided by 2 times root 2 times root 2, that's going to be 2 times 2, which is rewritten as root of 6 negative root of 2 divided by 4. So this is the value for sine 15 degrees. Now there is an interesting observation that we can make here. Now sine 15 degrees can be rewritten as sine of 90 minus 75 degrees. But what is this 90 degrees, which is nothing but sine pi over 2 minus 75. This comes back to our popular formula which we started off in the beginning of this particular lecture, and this is going to give me cos, and in place of theta I've got 75. Now this is actually 90 minus theta, so 90 is over here between the first and the second quadrant, and minus, in this case all ratios are positive, so that's going to be plus here. So in other words, our sine 15 is also cos 75 degrees, so have that in mind. Now what if they ask us to find sine 75 degrees? Now this can be rewritten as sine of 45 degrees positive 30 degrees by using the formula sine of a positive b we get sine 45 times cos 30 positive cos 45 times sine 30. Sine 45 is 1 over root 2, cos 30 is root 3 over 2, cos 45 is 1 over root 2, sine 30 is 1 over 2. So if I were to take the LCM as 2 times root 2, this would give me root of 3 positive 1. I wish to multiply the numerator by root 2 and divide the quantity by root 2. So this is going to give me root of 6 positive root of 2 divided by 4. And what is this? This is nothing but sine 75 degrees. Students, I wish to give you further identities which are very important, which would come in very much in handy to solve questions. That would be sine A times sine of 60 negative A multiplied with sine of 60 positive A is equal to 1 over 4 times sine 3A. So this is one identity. The second one is for cos. Cos A times cos of 60 negative A times cos of 60 positive A is equal to 1 over 4 times cos 3A. Now if we were to divide 1 by 2, then we will get the third one, and that is going to be sin A over cos A. That's nothing but tan A. Similarly, sin 60 negative A divided by cos 60 negative A, that's going to be tan of 60 negative A. Sin 60 positive A divided by cos 60 positive A, that's going to be tan of 60 positive A. 1 over 4 will be cancelled with 1 over 4, giving me tan 3A. So that's a very good identity we have got, students. Now you might be wondering, how is it we are going to achieve a proof for this? Now let me just give you that. Foremost, let me state the identity. This is what we have been given. Sin A times, now I would like to write this as sine of 60 positive A times sine of 60 negative A. Fair enough, it's not going to make any change at all, which is equal to 1 over 4 times sine 3A. We are expected to prove this. So what I would like to do is, I would like to start off by stating, consider the left hand side. What is that? Sine A times sine of 60 positive A times sine of 60 negative A. Right? Now we know a very important result. What is that? Sine of A positive B multiplied with sine of A negative B is equal to sine squared A negative sine squared B. We just saw this result. So this would mean I can now rewrite sine A times sine of 60 positive A times sine of 60 negative A to be as sine A stays as it is, parenthesis, this is going to be sine squared of 60 negative sine squared A. Now what is sine 60? Sine 60 is root 3 over 2, right? So sine squared 60 is going to be root 3 over 2 squared, which is nothing but 3 over 4. So I would substitute that. This is equal to sine A divided by 3 over 4 negative sine squared A. If I were to take the LCM as 4, this is going to be 4 times sine squared A divided by 4, which I can rewrite it as 3 times sine A negative 4 times sine A times sine squared A. That's going to be sine cubed A divided by 4. I can take 4 out and rewrite this as 3 times sine A negative 4 times sine cubed A, which is equal to 1 over 4 times sine 3A, which is equal to the right hand side, hence the result, right? It's a beautiful result. So students, we will continue our study in the next lecture. Before we head on to further topics, I would like to review the concepts that we have studied in the previous class. So foremost, let us do the review by performing some few questions, and that would be the best way. So we have a question given: sine theta is 21/29 and theta lies in quadrant 2. Then we are asked to find the value of secant theta added with tan theta. Now if you were to take the quadrants, this is the first quadrant 0 to 90, this is second quadrant 90 to 180, and this is the third quadrant, this is the fourth quadrant 270 to 360. So in the second quadrant only sine is positive. When I say sine along with its reciprocals, right? So definitely the reciprocal of sine is going to be cosecant theta. So cosecant theta and the sine would enjoy the positive values in quadrant 2. But when it comes to secant is actually equal to 1 over cos. Now cos is only positive in the fourth quadrant, so definitely secant will be negative, and of course tan is only positive in the third quadrant. And given the quadrant being the second quadrant, definitely secant is going to be negative and tan is going to be negative. So the value that we will have to get would be a negative of some quantity. So that is the first inference that you need to draw from this given question. So apart from that, this is a straightforward question, and this uses the concept of right angle ratios that I have introduced to you. Now this is theta, and this is opposite side, adjacent side, and hypotenuse side. And we know that sine theta is opposite side divided by hypotenuse, and we have been given 21/29. This side is 21, this side is 29. If I were to take this side as x, then clearly by the right angle ratios I can rewrite this as x squared. Positive 21 squared is equal to 29 squared. So from here I get 29 squared negative 21 squared. On the left it's going to be x squared. So you can multiply 29 into 29. 9 9s are 81. You carry 8. 9 2s are 18. Added with 8 will give you 26. 9 2s are 18. 1. 2 times 4, add 1 to that will give you 5. This is 1. And 14 and 8. So you have 8 4 1, and then you multiply 21 with 21. 1 times 1, 2, 2, 4, 1, 4, and then there is a 4. So this is the value that you've got, and you have to subtract this. So 8 4 1 and 4 4 1. So this is going to give you 0 0 and 4. So this is 400. So x squared is equal to 400. X is equal to root of 400. Right, so clearly the outcome is going to be equal to 20. So I have found x is equal to 20. So from here, if I were to write my secant value, secant is, as I mentioned to you, to get secant I need to extract the value of cos, and to extract the value of cos I got to know the formula for cos. So cos theta is nothing but adjacent divided by hypotenuse. So in this case it's going to be 20 divided by 29. So 1 over 20 divided by 29 is equal to 29, and I flip it, I get 29 divided by 20. So as I mentioned to you, the value of secant in the second quadrant should be negative. So this should carry a negative sign. So let me write that down. So therefore secant is negative 29 over 20. So that's fair enough. So next comes tan theta. So let me just perform tan theta. Now tan theta is nothing but opposite side divided by adjacent side. My opposite side is 21, adjacent side is 20. But tan theta lies in quadrant 2. So tan is negative there. So the value is going to be negative 21 over 20. Now since they are asking us to get the value of secant theta added with tan theta, this is going to be negative 29 over 20 added with negative 21 over 20. LCM is 20, and 29 added with 21, 9 added with 1, 10, and then 2 with 2, 4 added with 1 will give me 50. So I get a negative sign and a 50. So we can cancel the zeros, giving us a value of negative 5 over 2. So this should be your result. So therefore secant theta added with tan theta is equal to negative 5 over 2. Now most times they will ask you a question in multiple choice, and you will have this as one of the choices along with positive 5 over 2, right? Most of the times student would pick this value for the very fact that he or she would think that just by merely applying the right triangle concept, the outcome would be the accepted value. But apparently it is not so. The most important part that you will have to pay attention here is theta lies in quadrant 2. So having mentioned this knowledge point, we will move on to the next question. So let's move on to question number 2. So we're given that if secant theta added with tan theta is equal to positive 4, then the quadrant that theta lies is dash. So we are expected to find in which quadrant these two values would be lying in. So the understanding is, I've got a value for secant theta, I got a value for tan theta, I'm adding them both and I'm getting a positive value. Now where can this positive value lie? So they're asking you to say this in layman term. Where is the house for secant theta and tan theta which are producing a positive value? So you got these 4 quadrants. So quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Now clearly you know tan is only positive in quadrant 3. Secant is only positive in quadrant 4 over here, because secant is nothing but 1 over cos. Cos is only positive here. Apart from this that I have just shown you for tan and for secant, the question is saying that these two ratios are getting added together and they are producing a value, and it is your responsibility to house it because the value is a positive value. Now where can this value obviously be housed? Over here, because over here from the concept of cos which I just mentioned to you, cosine is positive, all ratios are positive, sine is positive, tan is positive. It is only here all ratios are positive. So straightforward, the solution is going to be quadrant 1. Only in quadrant 1 this is actually possible. Apart from quadrant 1 this is not possible. So the value for theta being equal to 4, the outcome being equal to the ratios that are producing me a positive value, for that to occur theta should be in quadrant 1. So I mentioned that. that completes the solution to this question. But on the other hand, if they were to ask you, okay, also find the value for secant theta and tan theta, it is here you would meet up with some challenges, because we are being given only the sum, but from the sum we have to extract the individual values for the ratios. So that is going to be a bit of challenge if you are not aware of the exact algorithm that goes in. So I will mention that. Let me give you that solution. So I have given you the first solution, so this is already done. I'm going to focus on this solution. So solution, let me write down what is given. Given secant theta positive tan theta is equal to 4. Now from trigonometric ratios, we know that. What do we know? We know that secant square theta negative tan square theta is equal to 1. Now we also know that a squared negative b squared can be rewritten as a negative b times a positive b, right? So from this concept, I can rewrite this as, this would mean I got secant theta negative tan theta multiplied with secant theta negative tan theta is equal to 1, right? But secant theta added with tan theta is equal to 4. So if we were to take this as sum 2, so this would mean I can rewrite 2 as, in place of secant theta positive tan theta, I'm going to substitute 4. So it's going to be 4 times secant theta negative tan theta is equal to 1. This implies secant theta negative tan theta is equal to 1 over 4. Now I have taken this as 2, let me take this as 1, let me take this as 3. So using 1 and 3, we now have, using 1 and 3, we now have, what do we have? We got secant theta added with tan theta is equal to 4, then secant theta negative tan theta is equal to 1 over 4. So you add both the things together. So clearly when you do that, negative tan theta positive tan theta get cancelled, giving me 2 times secant theta is 4 added with 1 over 4, which is nothing but, I take the LCM, 4, 16 added with 1, which is nothing but 17 over 4. So from here, secant theta is equal to 17 divided by 2 times 4, cross multiply, you get 17 over 8. So this is one value. So I've got the value for secant theta. So I'm going to substitute this in 1. So what happens when I substitute this in 1? So this is 17 over 8 positive tan theta is equal to 4. You move this to the other side. So this implies tan theta is equal to 4 negative 17 over 8. Take the LCM as 8. So this is 32 negative 17. So 32 take away 17. This is going to be 5. And from 2 you take away 1. So you get 15. So this is equal to 15 divided by 8. So what is this? This is my tan theta. So from here clearly you can understand, if they were to ask you the second part, then you need to do some working, right? Because the first part is a straightforward question, but the second part you need to work on. So most of the times, if they were to ask you as a multiple choice, then they would also include this also, right, as a requirement. So you will have to work it out. So without working it out, you cannot guess and check. So that wouldn't give you the right answer. So having mentioned that, students, let's move on. Now this is the question involving allied angles. I already explained to you this concept. So let's write the question down. The trigonometric ratio x that satisfies the equation cosecant of 90 positive theta positive x times cos theta times cot of 90 positive theta is equal to sine of 90 positive theta. So we are expected to find that x. Now you would have been given some choices, say A is cos theta, B is some sine theta, C is some secant theta, and D is some tan theta. Some choices would have been given. You will have to go and pick up the right choice. So now let me just consider this cosecant of 90 positive theta. Now what is cosecant theta? Cosecant theta is nothing but 1 over sine theta. So this is nothing but 1 over sine of 90 positive theta. Now I already mentioned to you sine of pi over 2 positive theta. Now foremost go to the cost which I have explained to you, 0, 90, 180, 270 and 360. Now clearly this is going to be giving us a positive sign because of the presence of the argument 90 positive theta, so we can place a positive sign, and evidently we are going to be having a cos theta there. So this is a known truth. So because of this fact, therefore I can write cosecant of 90 positive theta, which I have represented as 1 over sine of 90 positive theta, is equal to 1 over cos theta. 1 over cos theta is nothing but secant theta. So I have now cosecant of 90 positive theta to be equal to secant theta. So this is the outcome for cosecant 90 positive theta. Now we also have cot of 90 positive theta. Let us go to the cos diagram. So this is 0, this is 90, 180, 270 and 360. Now 90 positive, over here only sine is positive, so cot is definitely going to give us a negative outcome. And as usual, this is 90 positive theta, so from the allied angle formula this is going to give us tan theta, so it's going to be negative tan theta, so that is also done. Now we are given sine of 90 positive theta. As I mentioned to you, 90 positive theta would put us over here in the quadrant number 2. In quadrant number 2, sine is positive, and because of the argument 90 positive theta, this is going to give us cos theta. So this is also done. So hence the given question, which is cosecant of 90 positive theta, positive x times cos theta times cot of 90 positive theta is equal to sine of 90 positive theta, can be rewritten. This is going to be secant theta positive x times cos theta. This is going to be negative tan theta. This is going to give me cos theta. Secant theta is 1 over cos theta plus x times cos theta. I'm going to write tan theta as sine theta divided by cos theta. So that would mean cos can be cancelled, giving me cos theta. So this implies I now have 1 over cos theta plus x times cos theta. Of course there is a negative sign here, so let me place that over there. On the right hand side I have no, this is actually sine theta, right? So you got a sine there with a negative sign, and I got a cos theta. So what I'll do, I'll bring this side. and move this to the other side. So that would give me 1 over cos theta, negative cos theta, is equal to, negative would become positive, so it's going to be x times sine theta. Now I can clearly take the LCM as cos theta. That will give me 1 negative cos square theta is equal to x times sine theta. Now 1 negative cos square theta is sine square theta divided by cos theta is equal to x times sine theta. I can cancel a sine, so this is going to give me sine theta divided by cos theta is equal to x. Therefore x is equal to tan theta. So if you were to look into the choice, this is actually choice number D. Okay, that should be the solution for this question. Of course, this question can be done within a minute, but since I need to explain this, I have taken a little bit lengthier duration in placing the elaborate result. So the next question is an interesting question. So let me write the question down. Question number 4. So it states the following: the general value of theta satisfying sine theta is negative 1 over 2 and tan theta is equal to 1 over root 3 is what? They want this. So we have been given the following choices. Choice A is a 2n pi positive pi over 6, an element of integers, and choice B, n pi positive pi over 6, an element of z. C, 2n pi positive 7 pi over 6, an element of z, and D, n pi positive 7 pi over 6 with an element of z. Right? So remember, z stands for integers, set of integers, set of all integers. Right? It has to be represented as z. I have seen somewhere where people are representing it as I. This is incorrect. You can't represent the notion of integers representation from z to I, because this has a different representation. So make sure that n is represented in this fashion, right? Because mathematics is a language, as I always mention to you, and we need to stick to the rules and the laws. So we can't give our own, representations. So having mentioned this, because each of these representations are associated with the person who has found that out, right? So you can't take away and nullify the contribution made by these people. So, and also these are all established standards that has to be followed. Okay, so having mentioned that, let me move on. Now you have been given a question in this fashion and you got a list of choices. And foremost, before we can go on, let us observe these choices. This is 2n pi positive pi over 6, and pi over 6 stands for 30 degrees, right? And 7 pi over 6 stands for 210 degrees. Now you got n pi and 2n pi. Now you would be prompted to make a choice with this being as one of the selections, n pi positive pi over 6, right? Now we will have to examine this first. Now let me write down these values. Say I start with n pi positive pi over 6. Now if I were to take n is equal to 1, then the value is going to be 180 added with 30 degrees, right? And that can be taken as an argument, and we can take this argument for tan of 180 positive 30. So that means, let me use this diagram. So 0, 90, 180, 270 and 360. So tan of 180 plus 30. So this is 180 and it ends up over here. So that looks a good choice because tan 30 is positive 1 over root 3. That looks good. Now this is going to be equal to tan 30, which is equal to positive 1 over root 3. And if I were to take this same value for sine of 180 positive 30, this is going to give me, over here its sign is negative and it's going to be sine 30, I get negative 1 over 2. So this is okay, but there is one problem. This has to be true for all values of n element of z. Now if I were to take n is equal to 0, then I would end up with producing pi over 6, and pi over 6 is nothing but 30 degrees, and if I were to substitute in tan 30, that's going to give me 1 over root 3. That is fine. But the same pi over 6, when I substitute it for sine, this is going to be sine 30, and that is going to be producing me positive 1 over 2, which is a contradiction to the question. Right? So clearly this has to be dropped. Do you understand the argument that I'm coming at? So this cannot be true for all values of z. So that is the reason I am dropping this value out. So this value goes off. Now let me just move up and show you one more case. Now let me just consider n pi positive 7 pi, this one. So I'm just placing it here, n pi positive 7 pi over 6. Now I'm going to take the value for n to be equal to 1. And when I take the value n to be equal to 1, this would give me 180 positive 7 pi over 6. Now what is 7 pi over 6? That's nothing but 210 degrees. Now if you were to add these two, you would get 390 degrees. Now let me go and show you where exactly 390 degrees is. Now clearly, if you were to apply the concept which I've taught you, since it goes beyond 360 degrees, if you were to subtract this, say, let me show that to you, 390 negative 360, this is going to give me 30 degrees. So clearly I can find the value for 30 degrees. So that would mean tan 30, that's 1 over root 3, and sine 30, that's going to be positive 1 over 2. The value is found. But the question is, they are sines. That is where the complication comes. So let me just show you where exactly 390 degrees is located. Now, you start here, 360 degree will land you up in one spin, right? Plus, you have to add 30 degrees, right? This is actually 360 plus 30. That is what is going to give you 390. So if you were to add 30 degrees, that would take you to the first quadrant. Now in first quadrant, all ratios are positive. So sine 30 would be producing you 1 over 2, and tan 30 would be producing a positive 1 over root 3. But there is again a contradiction to the given value. So this should also be dropped. So I've already shown you why this is dropped. Now I'm showing you why this is dropped. So now all that we have left with choice A and choice C. So you will have to select which of these two choices is going to be the solution. So let me now take choice A and show it to you. Now choice A is given to be as 2n pi positive pi over 6. Now let me take the value for n to be equal to 0. The moment I take the value for n to be equal to 0, I would get 30 degrees. Now tan 30 produces me, tan 30 would give me 1 over root 3, that's fine. But the problem will be sine 30. Sine 30 is giving me 1 over 2. As I mentioned to you, this contradicts the given value. So clearly we cannot take this. This is dropped. Now the only set of values, or I would say the last remaining warrior that would have to be tested, is going to be the quest. So we have been given 2n pi positive 7 pi over 6. So let's check if this warrior is going to be qualifying. If he qualifies, then hats off. Now first and foremost, what I would like to do is I would like to assign n to be equal to 0. That's the basic check. Now if I were to take n is equal to 0, I would get 210 degrees. Now just go and examine where 210 degrees is falling. So if I were to start here, this is going to be 180 and 210 will land me up over here. Over here, sine is negative. Sine theta will give me a negative value. So clearly, this is our choice. Because if you were to write this as sine of 210 degrees and go up and rewrite this as sine of 180 positive 30, 180 positive 30 will land us up in the quadrant 3. And quadrant 3, sine is negative. So that's going to give me negative sine of 30 degree, which is negative 1 over 2, right? That's the value, negative 1 over 2, which concurs with the value given in the question. And so therefore the choice is this 2n pi positive 7 pi over 6. Of course, this question needs some detailed understanding, so that's the reason I was a little bit elaborate, because it is imperative that students understand why this is the scenario and how to reach this scenario. Because I do not believe in giving displayed slides and then explaining it, because that wouldn't stimulate the creativity of the individual, because studies have shown that PPTs are basically not increasing the creativity, because the brain, when it sees these so-called PPTs, it gets stuck. So there is no way that the brain is allowed to expand and extrapolate the ideas. So that is the reason, if you want to do mathematics, you will have to use either chalk and talk, or you should get a good notebook and practice and practice and practice. Let's do this question, students. This question uses the concept of compound angles. So we will be applying compound angles, which I've already explained to you in the previous class. So the question is as follows. It wants us to find the maximum value for this expression. 1 positive sine of pi over 4 positive theta positive 2 times cos of pi over 4 negative theta. Right? Now let me just consider 1 positive sine of pi over 4 positive theta positive 2 times cos of pi over 4 negative theta. Now I'm going to use sine of a positive b formula, which is nothing but sine a cos b positive cos a sine b. And then I would be using cos of a minus b formula, which is cos a cos b. With negatives here, so it's going to be positive sine a sine b. So if I were to take this as 1, therefore I can rewrite 1 as 1 positive sine pi over 4 cos theta positive cos pi over 4 sine theta positive 2 times of cos pi over 4 cos theta positive sine pi over 4 sine theta. This is equal to 1 positive sine pi over 4 is 1 over root 2 multiplied with cos theta. Cos pi over 4 is 1 over root 2 multiplied with sine theta positive 2 times of cos pi over 4 1 over root 2 cos theta 1 over root 2 sin theta. So this is equal to 1 positive. I can take root 2 out, 1 over root 2 out. That would give me cos theta positive sin theta. I can take 2 over root 2 cos theta positive sin theta. So I got a cos theta positive sin theta. Now if I were to take that out, this is going to give me cos theta positive sin theta of 1 positive root 2 positive 2 over root 2. So this is what I have got. Now what I wish to do is I would like to actually write this 2 as root 2 times root 2, so that this can be rewritten as 1 positive cos theta positive sin theta times 1 over root 2 positive root 2 into root 2 divided by root 2. So I can cancel it off, and thereby I will now have an expression in this fashion: 1 positive cos theta positive sin theta times 1 over root 2 positive root 2. So this is what we have got. Now what we need to do is we need to perform some manipulation for this cos theta positive sin theta. So what I will do is I will multiply this by root 2 and I divide this by root 2. So if I were to do that, I can rewrite this to be as 1 positive, I'm going to take root 2 out, I'm going to rewrite this as 1 over root 2 times cos theta positive 1 over root 2 sin theta multiplied with 1 over root 2 positive root 2. So this is what we have got. Now this is equal to 1 positive root 2 times, now 1 over root 2 I can have that as sine pi over 4 times cos theta. Now 1 over root 2 I can have that as cos pi over 4 sin theta times 1 over root 2 positive root 2, right? This is what I've got. Now what is this? I would like to rewrite this entire component in this fashion: 1 positive 1 over root 2 positive root 2 times root 2 of this entire thing can be rewritten as sine of pi over 4 positive theta, right? Now the question wants us to find out when will this produce a maximum value. This has to give us a maximum value. Now we all know the range of sin theta, right? And given that information, also we know the ranges of sin theta, cos theta, because those are the two trigonometrical ratios which are pertinent here. Now clearly we have sine of pi over 4 positive theta. Now this has to hit the maximum, right? This has to produce the maximum, and the maximum produced, or I should say the maximum value that sine is capable of producing is 1. So it has to reach 1. Anything less than that would not be sufficient enough for us to achieve our goals. So sine has to hit its maximum value. So that is the understanding that you will have to apply here. So why do we do that? Because our objective is to produce a maximum value for this expression. And as I mentioned to you, that is only possible if this trigonometrical ratio sine hits its maximum value. So that is going to be 1. That's all. This problem is solved. So 1 positive, just distribute root 2 inside. So it's going to be root 2 divided by root 2. Root 2 times root 2 will give you 2. So there's going to be 1 positive 2, which is going to be 4. So this should be the value. 4 will be the solution. So usually they might put this question in multiple choice. They may give you the following choice: A is 2, B is 3, C is 4, and D is 1, something like that. So your choice should go to C. So this is the maximum value that is being produced. So that is going to be the review for all the concepts that we studied in lecture 1. So now we are heading on to do questions, or I should say understanding the concept of trigonometric equations. So this is the start of the lecture. So students, let's start with trigonometric equations. So this is the second lecture and a new topic. So how do we define this concept, trigonometric equation? In simple terms, an equation consisting of trigonometric functions. It can be functions, it can be ratios, separated by equality sign is called a trigonometric equation. So this is the crude definition, right? Example, we can have something like this: tan x positive sin x is equal to some alpha. I'm not specifying the value. Anything, it can be tan x, it can be cot squared x or cot squared, some value alpha negative sine squared alpha is equal to, say, some value a over b, something of this fashion. So the usual order or the usual representation is you should ensure that there is an equality here. If there isn't any the equality, or I should say if you are not able to find the presence of an equality sign, then we are not dealing with the equation. So trigonometric equation is made up of two words: trigonometry plus equation. So you need to have the equality sign. So without the equality sign, if they were to give you some question like this, so they're asking you, is this a trigonometric equation? And they give you like this, say sine theta plus cos theta. The answer is no. This is not a trigonometric equation. No. Right? So on the other end, if they are giving you something like this, say sine theta negative cos square theta is equal to 2. Is this a trigonometric equation? The answer is yes. Simple as that. Right? So we will do some questions. The best way to understand a concept is to do questions. Now, one good thing about trigonometric equation is that the understanding of the concepts have already been achieved in lecture 1, followed by a series of examples which I've just given you as review at the start of this chapter. So this chapter is not a difficult chapter. So let's get it started. Now the next important concept you will have to know is what is expected of you. So what is your objective whenever you are solving a trigonometric equation? So this is very important, right? You need to understand what is expected from you. That is the purpose of giving you that question. So if you're not able to understand what is expected from you, then how are you going to solve the question? Because of the very fact, say for example, this is a question posed to a data scientist. So a certain company, it sends out for an interview, and the position is data scientist. So after shortlisting one particular person, right, the boss of this company calls this person for the interview, right? So there is this interview for this data scientist. The boss is very impressed with this person's performance, so he gives him a data cluster. So data cluster is nothing but a series of data set. and tells him to analyze the data set. So immediately the data scientist, right, poses the question back to the boss. Right, so let me just draw these two people here. So you got the boss here and you got the data scientist. So the question comes back to the boss. The question is, you're asking me to analyze, what do you want to know? What do you want to know? The boss immediately tells him, look, that's why I have given you the data set. So you analyze and tell me what exactly should I know. Are you following the pattern here? Let me reiterate. The boss gives this guy, he wants to employ this data scientist. And so he gives him the data set and tells him, analyze. The data scientist looks at the data set and tells him, what exactly do you want to know? And the boss tells him back, that is the reason I'm going to employ you. What am I supposed to be knowing from the data set? So there is a circle that would eventually start here, a spiraling circle. The question from the boss to the data scientist and the data scientist giving back the question, and it would never end at all. So the point I wish to emphasize here is the boss in its, or the approach followed by the boss, might be correct, but from the perspective of the data scientist it is highly flawed. Because you walk into a doctor's office, unless you tell the doctor what is the issue or the concern that is plaguing you, the doctor wouldn't be in a position, to understand what is exactly tormenting you or disturbing your sleep, right? You cannot simply go to the doctor and say, can you analyze what's my problem? In fact, nobody, no science or technology that is existing out there can be in a position to tell what is exactly happening in an individual's body. So because that is the way things are actually geared up. So why am I taking this time and explaining to you? Everything would have been sorted out in this boss and data scientist case if the boss would have told the data scientist what he is looking for in the data set. There is a huge haystack, right? You got a huge haystack. Nobody knows what you have lost in the haystack unless you tell the person that you have lost a spade or a jewel. Because the brain is such a powerful organ that immediately it will visualize that particular missing object and search for it, designing its own algorithm with it. So, having mentioned this illustration, to solve a trigonometric equation, you have to first understand what you are looking for, or someone has to tell you what you should look for. What you should look for. Simple as that. So that's why I'm just telling you what you should look for. You should look for the value of the unknown. What unknown? Angle that satisfies the equation. What equation? Trigonometric equation. Right? So this is your objective, finding the unknown angle. So having mentioned that, let's move on. Let me give you this illustration. for better understanding. Solve sine theta is equal to 1 over 2. Now the unknown angle here is theta, and you are expected to find the values of theta. If you were to solve this, clearly you can see that theta can be 30 degrees, theta can be 150 degrees, theta can be 390 degrees, and so on and so forth. Now, if you were to be given some restrictions, so based on the restrictions, you can limit these values, and that would be the solution. If they were to give you the restrictions, you can pick up these values and state the solution. If no restriction is given, this should be the solution for this particular equation. So that is the best illustration to understand trigonometric equation in brevity. But that wouldn't be sufficient enough to cover the topic. So we will have to do examples after examples so that you get a better understanding of the topic. Now, additionally, there are a few important things that you will have to know. Now, if sine theta is equal to 0, then the value of theta will be equal to n times pi, where n is the element of z. So, for all values of n present in z, theta equal to n pi would satisfy this equation. So that is the first point that you will have to know. Point number 2, if you were to take cos theta is equal to 0, then theta would take all values of the form 2n positive 1 times pi over 2 for n element of z. So in this case, n can take any values present in the set z. So have this in mind, and these two are very important concepts. So if you were to list out the values for sine theta, with theta being equal to 0, pi, 2 pi, 3 pi, 4 pi, and so on and so forth, sine is going to be producing 0 here, sine pi is going to be 0, sine 2 pi is going to be 0, sine 3 pi is going to be 0, sine 4 pi is going to be equal to 0, and so on and so forth. So this is for sine. So that's the reason I have just placed theta is equal to n times pi. Now if you were to take the value for cos theta, and theta is equal to, in this case I take n is equal to 0, the first value that I would get is pi over 2, and then n is equal to 1. This is going to give me 2 added with 1, 3 pi over 2, and this is going to produce, for n is equal to 2, 5 pi over 2, and n is equal to 3 times 2, 6, 7 pi over 2. So n is equal to 4, 8, positive 1, 9 pi over 2, right? For all of these values, cos pi over 2 is 0, cos 3 pi over 2 is 0, cos 5 pi over 2 is 0, cos 7 pi over 2 is 0, cos 9 pi over 2 is 0, and so on and so forth. So this is the value that would be the outcome when theta takes the value 2n positive 1 of pi over 2. So this is clearly visible from the graph, right? If you were to draw the graph of sine. Sine 0 is 0. It starts here. Let me show you that. It starts here. Then at pi over 2, it will hit 1. So this is the maximum value that sine will take. So at pi over 2, it hits 1. And then at pi, it will just come down. It will hit 0. Of course, if I were to stretch the graph, it goes like this, and subsequently at 2 pi the graph actually goes down, and at 2 pi it will rise up, and exactly at 2 pi it will hit the point 0. So this is a point 0, and this would be occurring even for the negative side of the axis. This is the positive side. For negative side, subsequently you will have the curve being repeated. in the manner that I've shown you, right? So on the negative end, it's going to be negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So the same graph would be occurring there. So having mentioned that, that's fine. Now, if we were to draw the graph for cos, right? Now cos of 0 is equal to 1. So cos it's 1 at this particular point. Now exactly at pi over 2, right? At pi over 2, cos will hit the point 0. Of course, cos pi will produce us a negative value, so it goes down all the way here, right? And exactly at 3 pi over 2, so this is going to be 3 pi over 2, it will rise up and hit this particular point at 0. And of course at 2 pi, cos 2 pi will be hitting positive 1 exactly over here, and then at 5 pi over 2 it will come down to hit the point 0. So this is the graph for y is equal to cos x, this is the graph for y is equal to sin x. So I've just shown you how the wave is occurring. So having got that, let's move on. I would like to take this to be an example. Sin theta is equal to 1 over 2. If we were to draw the graph of sin theta is equal to 1 over 2, there are two parts here. One is left hand side and right hand side. First, let me draw the graph for sin theta. Say y is equal to sin theta. So that graph would be roughly in this fashion. Alright, it would be a wave, right? Now, if I were to draw the graph for y is equal to 1 over 2, then that would be a constant line. Okay, this is the rough graph. Now, if I were to ask you, find the point of intersection of the line y is equal to 1 over 2 versus the curve, sine curve y is equal to sin theta, what would you say? You have a point of intersection here. Let me use pen. You got a point of intersection here, 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 and that subsequently you're going to have infinite number of points of intersection of y is equal to 1 over 2 versus y is equal to sin theta, right? So if I were to ask you, find all the points of intersection, that is called as the general solution. Have that in mind. So what is the meaning for definite the general solution? If someone were to ask you, find all of these points of intersection, clearly we know there are infinite set of points where y is equal to 1 over 2 is intersecting with the curve y is equal to sin theta. So to get all of the solutions is called as a general solution. Number two, there is another solution that is called as the principal solution. Now what is the principal solution? Principal solution is to obtain all of the solution that are given in the interval 0, 2 pi. So this is a very important understanding, because in all of the questions you will either be asked to obtain the general solution or the principal solution or both. So just to reiterate, the principal solution is found in the interval, closed interval 0, open interval 2 pi, right? And the general solution is nothing but to obtain all of the intersecting points of, in this case it's y is equal to 1 over 2 and y is equal to sin theta. So that is what is of critical importance in understanding trigonometric equations. So having mentioned that, let's move on, students. Okay, students, having defined the two terminologies, the general solution and the principal solution, the most important question now is, how are we going to obtain the principal solution? Say for example, for sin theta is equal to 1 over 2. Now if we were to consider the graph Now clearly there are 2 points of intersection here. So as I mentioned, there is a point of intersection here, there is a point of intersection here. And the graph is flowing from 0 to 2 pi. This point is going to be 2 pi, right? We already know that. So between 0 and 2 pi, there are 2 points of intersection. Now clearly we know that when sine theta is equal to 1 over 2, theta value is going to be pi over 6. So this value, this point of intersection is going to be pi over 6. Now the next important question is, what would be this value? In other words, what would the value of theta be for this point of intersection? Now clearly we know that it's going to be 5 pi over 6. Now the question comes is, what if they would have given us, instead of the sine curve, they would have given us some other function? How are we going to extract the value of theta? Because it is imperative that we obtain the value of theta. That is obviously the principal solution, right? The point of intersection. But if in case we were to encounter functions which aren't too familiar, then extracting the point of intersection would become a challenge. In other words, extracting the value of theta would become a challenge. That would be at times a little bit tougher to crack. So what I wish to do here is, I would like to give you an alternative technique without the use of graphs to obtain the principal solution. Now foremost, this particular method has got 3 steps. Now the first step is, whatever be the equation given to you, take the modulus sign and then write that as sine alpha. Okay, so mod of 1 over 2 is going to be positive 1 over 2. Now step 2 is, find out where exactly this particular value is located. In other words, in which of these quadrant. Now clearly I mentioned to you that we use the concept of cast, C-A-S-T. All ratios are possible, sine alone is positive. When I say possible, it means positive. So in the first quadrant all ratios are positive, second quadrant only sine is positive, third quadrant tan alone is positive, and in the last quadrant cos alone is positive. When I say cos, it means their respective reciprocals also will be positive here. Now clearly if sine alpha is equal to 1 over 2, it's a positive sign here, and that is possible only in the first quadrant and in the second quadrant. Okay, so that has been zeroed in. So in step number 3, the values, it is imperative that you know this, you have this in the corner of your mind. The values that theta would take would be given as follows. In the first quadrant, theta takes alpha. In the second quadrant, theta takes pi minus alpha. In the third quadrant, theta takes pi positive alpha. In the final quadrant, theta takes 2 pi negative alpha. So this is important. Now clearly we know that sine alpha is equal to 1 over 2, which is positive, and that occurs in the first quadrant and in the second quadrant. So if I were to write the solution, okay, clearly the principal solution, okay, for sine theta is equal to 1 over 2 is alpha and pi negative alpha. Okay, but clearly we know that alpha is equal to pi over 6 because sine 30 is equal to 1 over 2. So this is going to be pi over 6, and in this case it's going to be pi negative pi over 6, which is equal to 6 pi negative pi over 6, which is 5 pi over 6. So therefore the principal solutions are pi comma 5 pi over 6. Okay, so I have extracted the value of theta even without the use of graphs. Let's do another question, students. So we are given in this case sine theta is equal to negative 1 over 2. So step 1, according to step 1, we take the modulus of this value negative 1 over 2 and write it in this fashion: sine alpha is equal to 1 over 2. Now step number 2 is to find out where exactly we would get 1 over 2, and the sign has to be negative, right? So if I were to represent this by the popular cast, C-A-S-T. Sine is negative in the third quadrant and in the fourth quadrant, right? So step number, let me write that down here. Step number 3 would be to write that popular quadrant for theta. Now theta takes alpha here. Over here it takes pi negative alpha. Over here it takes pi positive alpha. Over here 2 pi negative alpha. Right? So since the value of sine is negative in the third quadrant and in the fourth quadrant, the principal solution is pi positive alpha and 2 pi negative alpha. But what is alpha? We have taken alpha value to be as, in fact, sine alpha is equal to 1 over 2. So alpha is going to be 30 degrees. So this is going to be pi positive pi over 6, which is nothing but 6 pi positive pi over 6, which is equal to 7 pi over 6. Now for this, it's going to be 2 pi negative pi over 6, which is equal to 12 pi negative pi over 6, which is equal to 11 pi over 6. So therefore, the principal solution is going to be 7 pi over 6 comma 11 pi over 6. So that is the solution, students. Cosecant x is equal to negative 2. Alright, and we are expected to find the principal solution. Now cosecant x is equal to negative 2. So this would imply 1 over sine x is equal to negative 2. Therefore sine x is equal to negative 1 over 2. So this is the understanding. So step number 1, we take the modulus of this and write it as sine alpha is equal to 1 over 2. Now step 2, you will want to locate the quadrant where sine x is equal to negative 1 over 2 occurs. In other words, where exactly sine occurs in a negative fashion, or in which of the quadrant sine becomes negative. So however you want to represent, you can make the representation. So clearly if we were to apply the cast measure, we know that sine is going to be negative in the third quadrant and in the fourth quadrant. So having got that, let us go to step number 3 and find out the values that theta can take in these quadrants. In the first quadrant, theta takes alpha, or in this case x will take alpha. Second quadrant is going to be pi negative alpha. Third quadrant is going to be pi positive alpha. The fourth quadrant is going to be 2 pi negative alpha. Now clearly we know, since I've taken sine x is equal to modulus of negative 1 over 2, which is nothing but 1 over 2, we are actually dealing with theta to be equal to, or in this case alpha value is going to be pi over 6. Okay, so alpha is equal to pi over 6, because pi over 6 is nothing but sine 30, and sine 30 gives us 1 over 2. So therefore the principal solutions are going to be the third quadrant and the fourth quadrant. So that would be pi positive alpha and 2 pi negative alpha. So if I were to substitute the value of alpha, I would get pi positive pi over 6 comma 2 pi negative pi over 6, which can be rewritten as 6 pi positive pi over 6 and 12 pi negative pi over 6, which is equal to 7 pi over 6 comma 11 pi over 6. So this is our principal solution. Students, now it's time for us to obtain the general solutions. Now when sin x is equal to sin alpha, then the general solution is given as x is equal to n pi plus negative 1 raised to the power of n times alpha. Similarly, when cos x is equal to cos alpha, x is given to be 2 times n times pi plus or minus alpha. When tan x is equal to tan alpha, x is given to be as n pi plus alpha. Now subsequently, when sine squared x is equal to sine squared alpha, cos squared x is equal to cos squared alpha, and tan squared x is equal to tan squared alpha, the general solution is given to be as x is equal to n pi plus or minus alpha. So it's important that you have this in mind. Here you get only plus, over here you're getting plus and minus. So have that in mind. To understand this concept, let us do a question. Imagine we are asked to obtain the general solution for tan squared x is equal to 1. Now before I could give you the solution, please do not write this as tan x is equal to root of 1. Don't do that, because you will end up with a solution that is contradictory to the very fact that tan squared x is equal to 1. So having mentioned that, so this is a no action. So we are given tan squared x is equal to 1 and we are expected to obtain the general solution. So what I would be doing, I would be rewriting tan squared x equal to 1 to be as tan squared of pi over 4, right? Pi over 4 is nothing but 45. So tan 45 is 1. Tan squared of that particular value, 45, will still be equal to 1. So I'm not doing anything different. Now this is similar to the one that we have studied. So you can clearly write that this is similar to tan squared x is equal to tan squared alpha, where the general solution is given to be as what? X is equal to n pi plus or minus alpha. So if I were to write here the general solution, hence the general solution is x is equal to n times pi plus or minus, what's the value of alpha here? Pi over 4, where n is an element of integers. So that is the solution. To be more precise, the general solution for the given question. It states that sin x is equal to 0 and we are expected to solve. This is a trigonometric equation. Now for this equation there would exist, as I mentioned to you earlier, there are two solutions for this. One is called the principal solution and the other one is called the general solution. Now for the principal solution to exist, the interval has to be given, whereas in case of general solution, the name itself states it is a general solution. You don't have to specify the interval. So in this case you got sin x is equal to 0. Now suppose they had given you find all x such that x is contained in the interval 0, 2 pi. If this were to be the question, clearly they have specified the interval. Now if you were to look into the graph of sin x, you can clearly see sin x starts at 0 and ends at 2 pi. So this is exactly for all x contained in the interval 0, 2 pi. Now if you were to write down the solutions, clearly you can see that at x is equal to 0, sin x hits the origin at 0. Again at x is equal to pi, sin x hits 0, and then at 2 pi, sin x hits 0. So the solution for this would be x is equal to 0 and then x is equal to pi and then followed by x is equal to 2 pi. So this is going to be my solution set. This is called the principal solution. If you were to see the sin x graph, the sin x graph is actually an infinite graph. It continues. It just rises up again and then it hits and then it flows, right? So there is no stoppage for that particular progression. So in that case, we need to obtain the general solution. So for general solution, what we do is, we know that if sin x is equal to sin alpha, then the general solution is given as x is equal to n times pi plus negative 1 raised to the power of n times alpha, right? Now the question states that sin x is equal to 0. Now what I wish to do is, I would like to rewrite this right hand side 0 as sine of 0. So clearly this would mean my alpha is equal to 0, right? Because sine 0 is going to be 0. Now where do I get the alpha from? The first value that produces sin x to be equal to 0. So in this case, x is equal to 0 is basically producing me 0. So that's why I'm just taking that value to be alpha. Now since I've got alpha, therefore the general solution is going to be x is equal to n times pi positive negative 1 raised to the power of n. Alpha is equal to 0, so paste the 0. So 0 multiplied by anything would give me 0, eventually leaving me with x is equal to n pi, which is the general solution. So that is how you obtain the general solution for this particular question. So I've got the principal solution as well as the general solution. So that would be the conclusion for this question. So we'll move on to the next question. This is the nice question. Question number 2. Solve 2 times sin x negative 1 is equal to 0. So this is a trigonometric equation and we are given this 2 times sin x negative 1 is equal to 0. So foremost what I wish to do is, I would like to just consider this. Consider 2 times sin x negative 1 is equal to 0, because usually this is how we start the solution from the problem. Now I would move negative 1 to the other side. So this would give me 2 times sin x is equal to positive 1. Bring the 2 down. So I get sin x is equal to 1 over 2. This is the positive value. Now if you were to go to the quadrant, which I have mentioned to you in the previous class, 0 to 90, this is 180, and 270 and 360, right? So over here, alpha, all ratios are positive. This is going to be pi minus alpha, and this is going to be pi positive alpha, and this is going to be 2 pi negative alpha. So first quadrant, all ratios are positive. Second quadrant, only sign is positive along with this reciprocal. Third quadrant, tan is positive along with this reciprocal. So now we have got sin x is equal to 1 over 2, which is nothing but it's a positive sign there. So sin x is positive over here. So that would mean I can extract theta here or x here. And in this case, I can also extract the value of x from here. Now this is going to be sin x is equal to, now when exactly would we get 1 over 2? If this is going to be 30 degrees, right? So I have clearly written sin x as being equal to sin alpha. This would mean alpha is equal to 30 degrees, which in case is going to be pi divided by 6. So I've got the alpha here, so pi over 6 is there, and to get the next value we need to subtract pi negative alpha. Okay, this is the next angle, so this is going to be pi negative pi over 6, which is going to be 5 pi over 6. So I've got a pi over 6 and a 5 pi over 6. So the principal solution being pi over 6 comma 5 pi over 6. So that is the value. So we can place them in parentheses, and now it's time for us to write the general solution. So if sin x is equal to sin alpha, then x is equal to n times pi positive negative 1 raised to the power of n times alpha. Now my alpha is pi divided by 6. So this is equal to n times pi positive negative 1 raised to the power of n times pi over 6. So this is my x value, and you can state GS or general solution. Right, so this is the completion for this question. It's a lovely question, and we will move on to the next one. Let's take question number 3, students. We've been given root of 2 times cos x negative 1 is equal to 0. And we are asked to solve this trigonometric equation. So foremost, let me start off by consider root of 2 times cos x negative 1 is equal to 0. So I'll move the 1 to the other side. This in turn would give me root of 2 times cos x is equal to 1. From here I can rewrite cos x is equal to 1 over root of 2. So cos x is positive. So I can write cos x as cos alpha, which is possible because of the fact cos x is being equal to 1 over root 2, which is nothing but cos 45 degrees. So this would mean alpha is equal to 45 degrees, which can also be rewritten as pi divided by 4. Now if you were to draw the cos diagram, 0, 90, 180, 270 and 360, alpha is over here. It means all trigonometric ratios are positive. Over here pi negative alpha, only sine alone is positive. Over here pi positive alpha, tan alone is positive. Over here 2 pi negative alpha. So cos is positive here along with this reciprocal. So it's also positive over here, positive over here. So therefore the solution set is going to be pi divided by 4, that's fine, followed by 2 times pi negative pi divided by 4. So what is this? 4 times 2 is going to give me 8 pi over 4 negative pi over 4, which is rewritten in this following fashion. Which is going to be 7 pi over 4. Now cos 7 pi over 4, just to give you some additional information. Now we know that cos pi over 4 is nothing but cos 45, right? Cos 45 is 1 over root 2. This is actually trivial because of the fact that we know the value. Now cos 7 pi over 4 is nothing but cos of 315 degrees. Now this is also equal to 1 over root 2 because of the fact that we have achieved the value, because of the understanding that we have of the quadrant. So that's exactly what I wish to draw your attention to. Now the general solution is different. Now since we have cos x to be equal to cos alpha, the value of x is given as 2n times pi plus or minus alpha. This is the general solution. So if you were to rewrite this for the first value, pi over 4, x is going to be equal to 2 times n times pi plus or minus pi over 4. So this is the general solution. So that is the solution for this question. Now students, let's do the next question. Question number 4. We expected to solve this question given that tan x negative root of 3 is equal to 0. Let me just start off by considering the given question. Consider tan x negative root 3 is equal to 0. If I were to move this root 3 to the other side, this would give me tan x is equal to root of 3. Now this is actually root of 3 over 1. Now this is produced when x is equal to pi divided by 3. So that means when x is equal to 60 degrees or when x is equal to pi over 3. Right? So we got the value pi over 3. Now if we were to draw the quadrant, let me just show you the quadrant which I've already drawn. I got alpha, pi negative alpha, pi positive alpha, 2 pi negative alpha. Tan is positive in the third quadrant as well as in the first quadrant. So the values are alpha and pi positive alpha. So that's the principal solution. So therefore the principal solution is going to be alpha comma pi positive alpha, which is equal to pi over 3 comma pi positive pi over 3. So this is equal to pi over 3 comma 3 times pi positive pi, that's going to give me 4 pi over 3. So principal solution is done. Now to obtain the general solution, when tan x is written as tan alpha, or instead of saying, it's up to you, you can say when or use the term if. Okay, then x will be equal to n times pi positive alpha, there's no plus or minus, where n is element of z. Now in all these cases, whenever you see n, it's by default element of z, set of integers. So use the letter z. Okay, so that is the solution. So this would mean the general solution is going to be n times pi positive, use the first angle pi over 3, and that is the solution for the question. To find the general solution for sin x is equal to negative root of 3 over 2. So first what we will have to do is, to solve this question, it comprises of two steps. So step number 1, we will have to find the principal solution, and step number 2, we will have to then head on to find the general solution. Now let's execute step number 1, that is finding the principal solution. So to find the principal solution, we have got 3 steps, right? For the first step, what we would do is we would take the modulus of this quantity and write it as sine alpha is equal to root of 3 over 2, right? Now what would be the value for alpha here? Now clearly sine 60, right? Sine 60 is going to be root 3 over 2. So alpha is pi divided by 3, right? So having got that, next step number 2, we will have to know when exactly or where exactly sine takes the negative value. So if I were to apply the cast concept, C-A-S-T, sine is negative in the third quadrant and in the fourth quadrant. So that will take us to step 3, where the first quadrant takes, where theta takes the value alpha, second quadrant is going to be pi negative alpha, third quadrant pi positive alpha, final quadrant, fourth quadrant is 2 pi negative alpha. Since we are basically concerned with the third and the fourth, the principal solution in this case is going to be pi positive alpha and 2 pi negative alpha. So this would mean pi positive, the alpha is pi over 3, and 2 pi negative pi over 3, right? So this is going to give me 4 pi over 3 and 6 pi negative pi, that's going to be 5 pi over 3. Now take one of these values. So clearly we can say that therefore this implies the principal solution is found to be as 4 pi over 3 comma 5 pi over 3, right? So that is for the principal solution. Now out of these two values, we can choose one of the value to be as alpha and then head on to obtain the general solution. So what I wish to do is, let me write that down, general solution. Now we know that when sin x is equal to sine alpha, the value for x is given to be as n pi plus negative 1 raised to the power of n times alpha, right? So that would mean my sine x in this case is going to be sine of, I've taken alpha to be as 4 pi over 3. So this is going to be sine of 4 pi over 3. Now sine of 4 pi over 3 is obtained because of the principal solution we have just received, or in other words, we have just achieved. So I'm just taking one of these values. Now having obtained this, clearly we can hence obtain the value for x, which is going to be n times pi plus negative 1 raised to the power of n times 4 pi over 3. Now what is this? This is the general solution. So clearly you can put this in a box. So that is the solution for this beautiful question, students. We will head on to the next one. Let's do another question, students. This question is given to be as sine squared x is equal to 1 over 4. So what I'm going to do is I'm going to write this 1 over 4 as sine pi over 6, because sine pi over 6 will give me 30, right? Sine 30 is 1 over 2, but I need to produce 1 over 4, so just square that. So subsequently this is rewritten as sine squared pi over 6. So remember, do not transfer the square to the other side and write it as square root of 1 over 4. That is not going to be working at all. So this would mean this is of the form sine squared x is equal to sine squared alpha, which would mean x is equal to n pi plus or minus alpha. So hence the general solution is going to be equal to n pi plus or minus, what's the value of alpha? It's pi over 6, right? And n is any integer, right? So that is going to be the solution, and we can box the result. So we will move on to the next question, students. Let's do another question, students. In this question we are given cot x is equal to negative 1. Now we haven't seen anything involving cot, isn't it? But however we know that cot x is equal to 1 over tan x. So rewriting this, we are going to have 1 over tan x is equal to negative 1. Therefore tan x is equal to negative 1. Now to obtain the principal solution, actually the question wants us to find the general solution, right? So for that, as I mentioned to you, it involves two steps. One, we start off by finding the principal solution, and then we move on to obtain the general solution. So the steps for obtaining the principal solution is as follows. So step number 1, we take the modulus. So therefore we now have tan alpha is equal to positive 1. Now step number 2 is to zero in the quadrant. So we employ CAST. Now tan x is equal to negative 1. Where exactly tan is negative? Clearly in the second quadrant and in the fourth quadrant. Now step number 3 is clearly the possible values that theta can take in among the, in other words, x can take in this quadrant is as follows. Alpha, this is going to be pi negative alpha, pi positive alpha, and 2 pi negative alpha. So therefore the values of for the principal solution is going to be lying in the second quadrant and in the fourth quadrant. So this would mean my alpha in this case, clearly we know that alpha is equal to pi over 4 here, right? because that's 45. So that's going to be pi negative pi over 4 comma 2 pi negative pi over 4. So this is equal to 4 pi negative pi, that's 3 pi over 4, 8 pi and 7 pi over 4. So I will take one of these values for obtaining the general solution. So what I will do is I will take 3 pi over 4. Now we know that when tan x is equal to tan alpha, x is equal to n pi positive alpha. So this is the general solution. So in this case, this would mean tan x is equal to, I'm choosing the first value, tan of 3 pi over 4, which would mean my general solution is equal to n pi positive 3 pi divided by 4, where n is an element in the integer, in the set integers. So this is the solution for this question. Students, the next topic we would be learning is known to be as number of solutions. Right, so we will have to extract the number of solutions that are occurring in a given equation. So having mentioned that, it is imperative that you take note of this particular topic, and it is of critical importance. And having mentioned that, let us move on to do a question. Now we have been given sine 4x is equal to negative 1 over 2, and x is contained in 0, 2 pi. Right? Now a point of observation. If you were to draw the graph of sine 4x, it would be a real challenge because this is a compressed graph. So what we would be doing is we would try to convert sine 4x into sine x, because we know the graph of sine x, right? If it were to be sine x is equal to negative 1 over 2, then it would be a cakewalk for us, because the graph of sine x is well known to us, but the graph of sine 4x, to draw it would be a real challenge. So having mentioned that, what I wish to do is I would like to convert sine 4x into sine x. Now how are we to do that? So let us just start off like this. Now this is given, right? Given that sine 4x is equal to negative 1 over 2. Now the interval given for x is between 0 and 2 pi. Now what I would like to do is I would like to take the value or the coefficient of x, which is 4, and then multiply it out, and that would give us 4 times x is contained in 4 times 0 is 0, 4 times 2 pi is 8 pi. So this is what I'm doing. Now having done this, what I wish to do is I would like to now, let me write that down here. So sine 4x is equal to negative 1 over 2. So this is what I have got. Now the next step is I would like to take, let 4x be equal to theta. So if I were to take sine 4x is equal to theta, then that would mean I now have sine theta is equal to negative 1 over 2, where theta is in the interval 0, 8 pi. Right, now if you were to draw this, then the graph would look something like this. So 0 to 2 pi. So let me just draw the graph. So the graph of sine x is going to be like this. It's going to hit here and then move up and hit and then move up and then hit and then move up and then hit and then move up. Right, so let me give the coordinates now. So this is going to be 2 pi and then 4 pi and then 6 pi, and then this is going to be 8 pi, right? Now let's draw y is equal to negative 1 over 2. So if this point is negative 1 over 2, so if you were to draw the line, so find the points of intersection. So we've got 1 here, 2, 3, 4, 5, 6, 7, 8. So what are the number of solutions? So therefore the total number of solution is what? 8. And that is the exact, or I should say the correct answer. Alright, so we have achieved that because of our understanding of the sin x graph. Now the best way to gain mastery of this particular section is to do more questions. So that's exactly what we are going to do. Let's move on, students. Let's do another question, students. We are given secant 3x is equal to 2 with x being contained in 0, pi. Now we are expected to find the total number of solutions. So what I wish to do is I would like to write this as 1 over cos 3x is equal to 2. Therefore cos 3x is equal to 1 over 2. And the x is lying in the interval 0, pi. Now foremost what I wish to do is, I know clearly drawing the graph of cos 3x is going to be an Herculean affair, so I don't want to tread on that. So what I would do is I would like to change the 3x into cos x or cos theta and then move on to obtain the solution. So before I could do that, I would like to extend this interval. So let me write this down. Cos 3x is equal to 1 over 2. Multiplying this by 3, I get 3x element of 0, 3 pi. So the interval is stretched. Next step is I would like to let 3x be equal to theta, and that would give us cos theta is equal to 1 over 2. And 3x is equal to theta. So this is going to be theta element of 0, 3 pi. Now if we were to draw the graph for cos theta, the graph would look something like this. So it starts here, comes down, then moves up, hits here, then moves up and hits down. So let's place the points. So clearly over here it's going to be pi. So this is going to be pi, this is going to be 0, and this is going to be 2 pi, and this is going to be 3 pi, right? And the interval is 0 to 3 pi, so it's enough that we go up until 3 pi. Now if I were to draw the value y is equal to 1 over 2, then the hit, if I were to hit, let me draw the graph, y is equal to 1 over 2, and find out the number of hits from 0 to 3 pi. So that would be, I get a hit here, that's 1, I get a hit here, that's 2, I get a hit here, 3, and this is beyond 3 pi, right? So there are 3 hits, that means there are 3 solutions. So you can write that down. Therefore the total number of solutions for this given question is how much? 3. And that is the solution for this particular question, students. Let's do this question, students. We've been given to find the number of distinct solutions of the equation 5 over 4 times cos squared 2x positive cos raised to the power of 4x positive sine raised to the power of 4x positive cos raised to the power of 6x positive sine raised to the power of 6x is equal to 2 in the interval 0, 2 pi. This is a lovely question. So foremost what I wish to do is I would like to consider the given equation. So this is the solution. Consider the given equation. So what is that? That is 5 over 4 cos squared 2x positive cos raised to the power of 4x positive sine raised to the power of 4x. I'm clubbing it as one term, and then cos raised to the power of 6x positive sine raised to the power of 6x is equal to 2. I would like to apply a formula which we have already studied. So if I were to apply that formula, this is cos squared 2x, this is going to be 1 negative 2 times sine squared x cos squared x positive 1 negative 3 times sine squared x times cos squared x is equal to 2. Now I can add 1 and subtract that 2 there. So that would mean I can cancel these terms and I can rewrite them as 5 over 4 cos squared 2x negative 2 times sine squared x cos squared x negative 3 times sine squared x cos squared x is equal to 0. I can add these two together. That would give me 5 over 4 cos squared 2x negative 5 times sine squared x cos squared x is equal to 0. So that is nice. Next what I wish to do is I would like to multiply by 4 and divide by 4. So this is going to be 5 over 4 cos squared 2x negative 5 over 4 times 4 times sine squared x cos squared x is equal to 0. I would like to have a 5 over 4, that's why I am just manipulating in this fashion. Now this is rewritten as 5 over 4 cos squared 2x negative 5 over 4. I'm going to write this 4 times sine squared x cos squared x as 2 times sine x cos x raised to the power of 2 is equal to 0. This is rewritten as 5 over 4 cos squared 2x negative 5 over 4. 2 times sine x cos x, that's going to be sine 2x raised to the power of 2 is equal to 0. 5 over 4 is common, I can take it out, so I get cos squared 2x negative sine 2x raised to the power of 2, that's going to be sine squared 2x is equal to 0. So I got cos squared 2x negative sine squared 2x, and I know a formula. What is that? Cos squared x negative sine squared x is equal to cos 2x, but in this case you got cos squared 2x. So I can rewrite this as 5 over 4 of cos 4x is equal to 0, which implies cos 4x is equal to 0, and we given x to be in the interval 0, 2 pi. Now as I mentioned to you, drawing the graph for cos 4x is not going to be an easy affair. So I would consider it in this fashion. I would like to stretch this interval. So I got cos 4x is equal to 0, and I multiply the x is actually x element, right? So x by 4. So now it's going to be 4x element of 0, 8 pi. So now the interval is stretched. So let me take 4x to be equal to theta. That would mean I now have cos theta is equal to 0, and theta is contained in the interval 0 to 8 pi. Now if I were to draw cos theta's graph 0, so it's going to start here, it's going to come down and move up, come down and move up come down, move up, come down, and move up, and come down, and move up, like that. So let me mention these points, right? So this is going to be 0, and it hits the bottom. This is going to be pi. It raises up, right? So that's going to be 2 pi there. It hits here, it's going to be 3 pi. It moves up, 4 pi. It's down, 5 pi. Moves up, 6 pi. It's down, 7 pi. Moves up, is 8 pi. So this is the point that we are looking for, right? So if I were to place in the intersection, cos theta is equal to 0. So there is an intersection here, over 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 here, and this is beyond 8 pi, right? So 1, 2, 3, 4, 5, 6, 7, 8. So total number of solutions, therefore total number of solutions in this case is equal to 8. So that is the end of this beautiful question, students. Welcome, students. We have been continuing our study on trigonometric equations. Now we are expected to solve this question. So we got 2 times sin x negative cos x of 1 positive cos x is equal to sin squared x, given the interval being 0, 2 pi. So foremost, what I will do is I will start off by considering the given question. 2 times sin x negative cos x times 1 positive cos x is equal to, I would like to write sin squared x as 1 negative cos squared x. After which I would like to write 1 negative cos squared x as 1 negative cos x multiplied with 1 positive cos x. On the left hand side I've got 2 times sin x negative cos x times 1 positive cos x. So if I were to move everything to the left hand side, I would get 2 times sin x negative cos x times 1 positive cos x negative 1 negative cos x times 1 positive cos x is equal to 0. I would like to take 1 positive cos x as a common factor. That would give me 2 times sin x negative cos x, and that is followed by negative 1 negative cos x times, and that has to be equated to 0. So this is further rewritten as 1 positive cos x times 2 times sin x negative cos x negative 1 positive cos x is equal to 0. Positive cos x negative cos x gets cancelled, giving us 1 positive cos x times 2 times sin x negative 1 is equal to 0. So from here I get 1 positive cos x is equal to 0, and 2 times sin x negative 1 is equal to 0. This is going to be cos x is equal to negative 1. So that would mean x is equal to pi, right? Which is obviously in the given interval, right? So this is one solution. The next solution is going to be 2 times sin x is equal to 1. Sin x is equal to 1 over 2. Now over here we will have to obtain the principal solution. So if I were to take the modulus, then the step 1 would be sin alpha is equal to 1 over 2, step 1. Step 2, find out the quadrant in which the sign value is positive. So if I were to take the representation CAST, all ratios are positive, sign alone is positive. So we want the value of sign to be positive, right? So that is possible only in the first quadrant and the second quadrant. So the values for the first quadrant and the second quadrant, alpha and this is pi negative alpha, pi positive alpha, 2 pi negative alpha. So we are looking at this point and this point. So let me write that down. Now clearly in this case alpha is going to be equal to pi over 6, right? Pi divided by 6 is nothing but 30. Sine 30 is 1 over 2. So over here alpha is equal to pi over 6, that's one value. And next we will have to obtain pi negative alpha, which is nothing but pi negative pi over 6, which is 6 pi negative pi over 6, which is 5 pi over 6. So this is the value. So therefore the solution set is going to be, I got the following: pi over 6, pi, and 5 pi over 6. So all of this are in the region 0, 2 pi. So this is the solution for this question. Now you might be wondering, why have I not cancelled one positive cos x with the left and the right? Right? Don't do that. If you're going to be doing it, you would not get this solution, right? This solution would be missed out. Of course, you can come back again and start assigning 1 plus cos x is equal to 0, but most would not go back in achieving this solution. So that's a reason, as a precautionary measure, don't cancel it. Just proceed with the solving the system, and finally you extract the value. Students, let's solve this question. We've been asked to find the solution for this following question. So the question is as follows: find the general solution of the equation 2 sine squared 2x positive 6 sine squared x is equal to 5. So we are expected to obtain the general solution. So whatever solutions are there, we have to get the general solution. So what I would do is I will start off by saying consider 2 times sine squared 2x positive 6 times sine squared x is equal to 5. Now I would like to write this as sine 2x raised to the power of 2 positive 6 times sine squared x is equal to 5. I know that sine 2x is 2 times sine x cos x. That has to be raised to the power of 2. I get 6 times sine squared x is equal to 5. I can square them. I would get 4 sine squared x cos squared x positive 6 times sine squared x is equal to 5. Now I would like to use this part of the space. So 2 times 4 is 8, and I have sine squared x cos squared x positive 6 times sine squared x is equal to 5. Now let me rewrite cos squared x as 1 negative sine squared x. So this is 8 times sine squared x of 1 negative sine squared x positive 6 times sine squared x is equal to 5. So this is going to be 8 times sine squared x negative 8 times sine raised to the power of 4x positive 6 times sine squared x is equal to 5. I can add these two and get as 14 times sine squared x negative 8 times sine raised to the power of 4x is equal to 5. So this is what I've got. Now what I can do is I can actually push everything to the right hand side. So that would mean I will now have 5 positive 8 times sine raised to the power of 4x negative 14 sine squared x. So rewriting this, we get 8 times sine raised to the power of 4x negative 14 sine squared x positive 5 is equal to 0. Now I can factorize this as follows: 8 times sine raised to the power of 4x negative 10 sine squared x negative 4 times sine squared x positive 5 is equal to 0. I can take 2 times sine squared x out. That would give me 4 times sine squared x negative 5. 2 times 5 is 10 with a negative sign. That's going to get me 10 sine squared x with a negative sign. Followed by, if I were to take 4 out, that would give me sine squared x negative 5. So I cannot take 4 out. If I were to take 4 out, I need to write this as 5 over 4. Then that would give me unwanted issue. So I can take negative 1 out. So if I were to take negative 1 out, this is going to be negative 1 times 4 sine squared x. That's fine. So negative 4 sine squared x is there. I need to get positive 5. So that would mean negative 5 here. So negative 1 times negative 5 would give me positive 5. So that's it. That's fair enough, right? So 4 times sine squared x minus 5, 4 times sine squared x minus 5. So I can take 4 times sine squared x minus 5 as a common factor, giving me 2 times sine squared x negative 1 is equal to 0, right? Now this would mean 4 times sine squared x negative 5 is equal to 0, and 2 times sine squared x negative 1 is equal to 0. From here, 4 times sine squared x is equal to 5, which means sine squared x is equal to 5 divided by 4. 5 over 4. This is greater than 1. So that means no solution. Okay, not possible. The solution cannot exist here because this value 5 divided by 4 is greater than 1. So we have to drop this. So this is dropped. Okay, drop this. So now we have 2 times sine squared x negative 1 is equal to 0. So 2 times sine squared x is equal to 1. So sine squared x is equal to 1 divided by 2. So I can rewrite this as sine squared x is equal to, I need to get 1 over 2, right? So I can write this as sine 45, right? Sine pi over 4, that's giving me 1 over root 2. If I were to square it, I would get 1 over 2, right? So I can rewrite this as sine squared x is equal to sine squared pi over 4. This would mean my alpha is equal to pi over 4. If you remember our previous discussion in obtaining the solution, this is the way we actually explained in the process of extracting alpha. So that would mean the solution is going to be of the form, this means n pi plus or minus alpha. This is the general solution that we have obtained. So this would mean n pi plus or minus alpha is pi divided by 4, where n is an element of integer, right? So that is the solution for this beautiful question. So students, we will move on to the next question. Let's do this question, students. We are expected to find the general solution of the equation 1 negative tan theta times 1 positive sine 2 theta is equal to 1 positive tan theta. So this is what we have been given. So foremost, let us start off by considering the given system, which is 1 negative tan theta times 1 positive sine 2 theta is equal to 1 positive tan theta. Now we know a formula for sine 2 theta, which is 2 times tan theta divided by 1 positive tan squared theta, right? This is multiplied with 1 negative tan theta is equal to 1 positive tan theta. If I were to take the LCM as 1 positive tan square theta, this would give me 1 positive tan square theta positive 2 times tan theta times 1 negative tan theta, right, which is equal to 1 positive tan theta. Now this is a perfect square, so I can rewrite this as 1 positive tan theta raised to the power of 2 times 1 negative tan theta divided by 1 positive tan square theta is equal to 1 positive tan theta. Okay, so now we have two components. Now, as I mentioned to you, if you are going to be cancelling these two terms, you have to be a bit careful. What I'm going to do is I'm just going to cross multiply and bring the terms to the left. So this is going to be 1 negative tan theta times 1 positive tan theta raised to the power of 2 is equal to 1 positive tan theta times 1 positive tan square theta. Let me bring these terms to the left, and that would give me 1 negative tan theta times 1 positive tan theta raised to the power of 2 negative 1 positive tan theta times 1 positive tan square theta is equal to 0. Now 1 positive tan theta, 1 positive tan theta can be taken out, and that would in turn give me 1 negative tan theta times 1 positive tan theta. 1 positive tan theta is already taken out, so this is going to be negative of 1 positive tan square theta is equal to 0. So this is further rewritten as 1 positive tan theta times, this is 1 negative tan square theta, negative 1 negative tan square theta is equal to 0. So positive 1, negative 1 can be cancelled, and this in turn is going to be 1 positive tan theta times negative 2 times tan square theta is equal to 0. So this is what I've got. So from here I get 1 positive tan theta is equal to 0. This is going to be negative 2 times tan square theta is equal to 0. Clearly tan square theta is equal to 0. I can rewrite this as tan square theta is equal to tan squared of 0, which would mean alpha is equal to 0, right? Because tan squared 0 is sine squared 0 over cos squared 0, and that's clearly would give me 0. So alpha is equal to 0. So the general solution in this case is going to be theta is n pi plus or minus alpha. So that would mean n pi plus or minus 0, which is nothing but n pi. So n pi is the solution. So let me write that out. Theta is equal to n pi. Okay, so for this part. Now coming back to this part, in this case tan theta is equal to negative 1. Therefore I can write this as tan theta is equal to tan of 3 pi over 4. So clearly in this case theta is going to be n pi plus alpha, which is nothing but 3 pi over 4. So therefore the solution set, therefore the solution is going to be n pi union n pi plus 3 pi divided by 4. This is the complete solution for this question. So it's a lovely question, students. To see the next type of trigonometric equations. So this type is of this form: a times sine x positive b times cos x is equal to c. Now if you get this form, instantly what you need to do, you have to divide by root of a squared positive b squared, and repeat that, a squared positive b squared over here root of a squared positive b squared. Now what is exactly this a over root of a squared positive b squared? So if you were to draw the right angle triangle and taking this as some alpha and this to be a and this to be b, this is going to be root of a squared positive b squared. Now sine alpha is a over root of a squared positive b squared, and cos alpha is equal to b over root of a squared positive b squared, right? So if I were to take this as say 1, let me take it as 2. Let 1 be a times sine x positive b times cos x is equal to c. So this is the original form, right? So therefore I can rewrite 2 to be as a over root of a squared positive b squared, that's nothing but sine alpha times sine x positive cos alpha times cos x is equal to c, which I can rewrite as cos x cos alpha positive sine x sine alpha is equal to c, which is nothing but cos of x negative alpha is equal to c. Okay, so this is a very important part. In fact, this is c over root of a squared positive b squared root of a squared positive b squared and root of a squared positive b squared. Okay, so we can't miss that out. So having given you this, let me head on to do related questions of this type. Students, we are being given this question: find the general solution of sin x positive cos x is equal to root of 2. Now foremost what I would do is I would consider the given question, which is sin x positive cos x is equal to root of 2. Now this is of the form a times sin x positive b times cos x is equal to c, where a is equal to 1, b is equal to 1 and c is equal to root of 2, right? So what did we do? We just took the value of a squared positive b squared and we divided it throughout. So that's going, in this case, is going to be 1 positive 1, which is equal to root of 2. So we will take this value and divide the entire quantity by this root 2. So this is all for your understanding. You don't have to write this as part of the solution. Just keep this at the corner of your mind. So this is going to be 1 times sin x positive 1 time cos x is equal to root of 2. And I would divide this by root 2, divide this by root 2, divide this by root 2. Now clearly root 2 can be cancelled. Now I got 1 over root 2 times sin x positive 1 over root 2 times cos x is equal to 1. I would like to write 1 over root 2 as sin pi over 4 times sin x positive cos pi over 4 times cos x is equal to 1. I can rewrite this as cos x times cos pi over 4 positive sin x times sin pi over 4 is equal to 1. So this is nothing but cos of x negative pi over 4 is equal to 1. I can further rewrite this as cos of x negative pi over 4. It's 1. I can instead replace 1 as cos 0. Now this is of the form cos x is equal to cos alpha. So that would mean x negative pi over 4 is equal to alpha is 0 degrees, right? So the solution, so instead of just going like this, okay, we will have to write the general solution. So therefore the general solution, I don't have to specify this, the general solution is going to be 2n pi plus or minus alpha. This is the general solution for this. So in this case my alpha, okay, so the alpha is 0 degrees here. So on the left hand side we are going to have x negative pi over 4 is equal to 2n pi plus or minus 0 degrees, right? So this can be further rewritten as, let me use this space. So if I were to push this pi over 4 to the other side, I would get x is equal to 2n pi positive pi over 4. So this is the general solution where x is element of z. Welcome students. In this class we will be performing some review of topics that we have studied previously. So foremost I would like to start off with some basic application of the identities that we have come across. Now suppose, imagine that you are being given as something of this fashion: a times sine of bx positive c. Now this is a famous identity which is of the form sine of a positive b, right? We have come across this identity. We know this. This is a well-known formula. So I will be applying this. Now this can be rewritten as a times of sine of bx times cos c positive cos bx times sine c. Now an observation you need to take into account is the fact that there is a presence of a variable x. So this is the unknown variable, and the requirement is to find this particular unknown. So I can clearly distribute the value of a inside and rewrite this as a times cos of c times sine bx positive a times of sine c times cos bx. So I've got a quantity. Now what I wish to do is the variable which is present here, I don't want to touch this variable, but what I will do is I will take this quantity a times cos of c to be equal to some m, and a times sine of c is equal to some n. It's up to you, whichever value you want to take it as m, you take it. There is no problem at all in that. Now if you were to consider m squared positive n squared, then this is going to be a times cos of c raised to the power of 2 positive b times this is actually a times sine c raised to the power of 2, which is equal to a squared times cos squared c positive a squared times sine squared c. If I were to take a squared out, this is going to give me a squared of cos squared c positive sine squared c. Now what is sine squared c positive cos squared c? That's going to be 1. So this is nothing but a squared of 1. So this would mean I now have a relationship in this fashion. M squared positive n squared is equal to a squared. Now this will come in handy in solving many related questions. Now from this we can have a few of the relationships being expressed here. Now if you remember, we started off with this particular formula and then we assumed that a times cos c is equal to m and a times sin c is equal to n. So therefore what I can do is also now we can write a times sine of bx positive c to be as, in place of a times cos c I'm going to substitute m times sine bx positive. In place of a times sine c I'm going to substitute n times cos bx. Right, so you got a formula in this fashion where if they're asking you to find the value of a, you can clearly write this, where a squared is equal to m squared positive n squared, and just in case if they want to find the value of cos c, what exactly is cos c or what exactly is sin c, then from here you can clearly see that from here, therefore cos of c is m over capital A. Now this is achieved. Along with that you got sin c. So sin c is equal to n over capital A. So you got two expressions from which the unknowns, no matter whatever they are asking, can easily be obtained. So this is a very important deduction that we have just achieved. Let's do this question, students. We've been given this question: express 4 times root of 3 sine 5x positive 4 times cos of 5x in the form of a times sine of bx positive c. Right? So solution. So let me start off with this statement. We know that a times sine of bx positive c is equal to, I'm going to be using this expansion which we have got. So this is equal to m times sine bx positive n times cos bx. Now comparing the, imagine, let me take this as 2, comparing the right hand side of 2 with 4 times root of 3 sine 5x positive 4 times cos 5x, we observe that. So what do we observe? You can clearly see that m is equal to 4 times the root of 3 and bx is equal to 5x and n is equal to 4, right? Now we have to obtain the value for c. So how are we going to obtain the value for c? Now let's use this formula. Cos c is equal to m over a. Okay, and also this also implies a squared. We need to get the value of a, right? So a squared is equal to m squared positive n squared. Let's finish this off. So substituting 4 times the root of 3 raised to the power of 2 positive 4 raised to the power of 2, what do we get? This is going to be 16 times 3 positive 16, which is equal to, this is going to be 16 of 3 positive 1, which is nothing but 64. So a squared is equal to 64, therefore a is equal to 8. So we got the value for 8, And now cos of C is equal to m divided by A, right? We can use that. But what is my m? My m is 4 times root of 3 divided by 8, which is nothing but cos C is equal to root of 3 divided by 2, and sine of C is n over A. My n is going to be 4 divided by A is 8, which is nothing but 1 over 2. So we got cos C, and I should say we got cos C and we have got sine C. Now let us find out the value for C. Now we start with taking the modulus, so this is going to be equal to root of 3 divided by 2, which would mean my value of C should be equal to 30 degrees, because cos 30 would give me root 3 over 2. So C is 30 degrees, which means the value of C is pi divided by 6. Now it is also imperative to note that both cos C and sin C are producing a positive value, which means it's only possible that they are present in the first quadrant. In first quadrant we are going to be utilizing alpha, in the second quadrant pi negative alpha, in the third pi positive alpha, over here it's 2 pi negative alpha. So clearly this is what we are looking for, right? C is equal to pi over 6, because of the fact that both these values are positive. Cosine is positive, sine is positive. So therefore we have got C, we have got all the requirement. So this means 4 times root of 3 sine 5x positive 4 times cos 5x, which has been equated with A times sine of bx positive C, is going to be equal to, my value of A is 8, nice, times sine of my bx is found to be as 5x, positive, my angle C is going to be pi over 6. So this is a beautiful solution, students, and we can move on to the next question. Students, let's do this question. We have asked to be finding the value of x. So the question is find the value of x such that we have a trigonometric equation. So that is going to be, we are given that sine x times sine of 2x positive cos x times cos of 2x is equal to root of 3 over 2. Right? We expected to get the value of x. Now this is very similar to, I'm starting the solution here. On observation, the left hand side is similar to cos, right? Because two signs are coming, so it's going to be cos, and you got a positive sign, cos of A negative B, right, which is nothing but cos A cos B followed by a positive sign and sin A sin B. The only thing is that it starts with sin A sin B instead of cos A cos B, but still A positive B is equal to B positive A. So we would use this formula. So this would mean we can rewrite sin x times sin 2x positive cos x times cos 2x as cos of A minus B, right? A and B. So it's going to be x minus 2x. So this means if I were to take this as 1 can be rewritten as cos of x negative 2x is equal to root of 3 divided by 2. What is this? This is nothing but cos of negative x is equal to root of 3 divided by 2, which means cos is an even function. So cos of negative x is going to give us cos x, which is equal to root of 3 over 2. Now if I were to take the modulus, I can rewrite this to be as cos alpha, and over here it's going to be cos x. So cos x is equal to cos alpha, where alpha is equal to, this is going to be 30 degrees. So pi over 6. Now go to the quadrant. Pi over 6 is going to be over here, right? Cos is positive. So cos is positive in the first quadrant and in the last quadrant. Yeah, that would mean the fourth quadrant. So over here and over here. So two positive values are there. Now this is actually not specifying any interval. So we have to get the general solution. Now I mentioned to you that cos x is equal to cos alpha. Then this would mean the value of x is going to be alpha plus or minus 2 times n pi, right? In this case I am taking plus. The reason is we got the value of alpha as a positive value. Now there is one important thing you got to know. Now before getting the general solution, you will have to extract those other values, because we have got just pi over 6 for this point, but there is another value for this. So this value is obtained by taking 2 times pi negative alpha, and then we will substitute in the general solution, right? So this is for the general solution, but this is for the extracting the principal solution. So this is equal to 2 times pi, my alpha is pi over 6, which is nothing but 12 pi negative pi divided by 6, which is equal to 11 pi over 6. So therefore the general solution, if you were to start with, then we can have the solution to be as this, right? Alpha positive 2n pi, that could be the solution. So pi over 6 positive 2 times n times pi, where n takes the value, right, set of all integers. N is present in the set of all integers. Now on the other hand, if you were to take 11 pi over 6, then this would also produce me the required value. So 11 pi over 6 plus 2n pi, right? So either you take this, or depending upon what is required. So that would be my solution for x. So this is the value for x. Students, we got an interesting question here. We have been given sin x positive sin 3x is equal to cos x. We are expected to find the value of x present in the interval 0, 2 pi, right? So that is what is required. Now this is similar to, we will be using this all important formula. What is that? Sin A positive sin B is equal to 2 times of sin of A positive B divided by 2 times cos of A minus B divided by 2. I have given you this formula. Please see the video on the complete list of formulae for trigonometry. So using this, if I were to take this as 1, therefore 1 can be rewritten as 2 times of sin of x positive 3 times x divided by 2 times cos of x negative 3 times x divided by 2 is equal to, on the right side I've got cos x. Now if I were to simplify this, this is going to be 2 times of sin of x added with 3x will give me 4x divided by 2 times cos of negative 2x divided by 2 is equal to cos x. Now clearly 2 can cancel 4, giving me 2. So this is going to be 2 times sin of 2x. Now 2 can be cancelled, giving me cos of negative x is equal to cos x. So let me use this part of the page. So this is going to be 2 times sine 2x, cos of negative x is going to give me cos x, which is equal to cos x, because of the fact cos is an even function. Now let me push this cos to the left side. So I would now have 2 times sine 2x times cos x negative cos x is equal to 0. Let me take this cos x out. So that would mean I now have cos x of 2 times sine 2x negative 1 is equal to 0. Now from here I can rewrite this as, this would mean either cos x is equal to 0 or 2 times sine 2x negative 1 is equal to 0. From here I can rewrite sine 2x is equal to 1 over 2. And this is a beautiful equation that we have got, 1 and 2. Now let me just consider cos x is equal to 0. Consider cos x is equal to 0. Now if you were to draw the graph of cos x, when x is equal to 0, cos x it's 1. So it's going to flow like this, right? Now at pi over 2, cos 90 hits 0. So this is pi over 2 here. And this is going to be pi. So cos pi hits here negative 1. This is going to be negative 1. And this is positive 1 there. And then it rises up. And then it would hit 2 pi over here. Right? So this is 2 pi. And then it flows down. Now we have been given x to be contained between 0 and 2 pi. So if I were to write the solution, there is a point here, one point of intersection, cos x is equal to 0, there is one point here, there is another point, 2 points, and we can't push there. So let me just start. If this is actually just a small correction, this is half open, right? This is closed and open. That is the interval that is being given. Now in case if it is completely open, let me just assume that now we will be considering this to be as half closed and half open. So let me just make that slight alteration. So this is going to be open and this is going to be closed. In other words, we are actually looking for points from 0 to 2 pi. So that means 2 pi is basically left out. Of course, because if we were to look into the graph of cos x is equal to 0, cos x hits 0 at this point, pi over 2, and again it hits 0 at 3 pi over 2. But we are not going to take 2 pi because of the fact the interval is open, half open, right? So it is because of the interval we would avoid the point 2 pi. So if you were to consider all values of x for which cos x is equal to 0, now clearly you can see that this means x will be equal to pi over 2 and 3 pi over 2. So these are the two values that are good for x given the equation cos x is equal to 0. Now let us work for sine 2x is equal to 1 over 2. This is what we've been given, and x is contained in 0 comma 2 pi. So this is closed and this is open. Now if I were to take, let theta be equal to 2x. So I will take that assumption. Now let me just put this, and I'm not going to apply it as of now. Now what I wish to do in the interval is I'm going to multiply by 2. So this would mean 2x is the element of 0 comma 4 pi. So this is what I've got here. Now if I were, now I'm going to apply theta is equal to 2x. Now if I were to take theta to be equal to 2x, then if I were to take this as 3, so 3 can be rewritten as sine theta is equal to 1 over 2. Now let me draw the graph of sine theta. So if you were to draw the graph of sine theta, it would be something of this fashion, right? It's a waveform. It goes. So this is 0, and probably we need a bigger graph. So at pi over 2, sine will hit the point 1. At pi it's a 0, and then at 2 pi I think we need to have a bigger graph so that you will be in a better position to visualize it. So let me try to draw the graph over here. So I have this, it goes on, it goes on, it goes on, it goes on. So this is long enough graph. Now sine theta is equal to 1 over 2. Now before that, let me just plot the point. 0, this is pi, this is 2 pi, this is 3 pi, and this is going to be 4 pi. So the point is over here. Now if I were to draw 1 over 2, let me draw 1 over 2. So this is going to be the graph. Now if you were to check the points of intersection, now that will give us the number of solutions, right? So first I want to decide on the number of solutions. So number of solutions, that's going to be our first priority. When sine theta is equal to 1 over 2, okay, that's the graph that we are looking for, 1 over 2. Now there is a point of intersection over here, there is a point of intersection over here, that's a point of intersection over here, and there is a point of intersection over here. So we got 4 points. We can't take this point because it is open, right? So 4 solutions are there. We need to cater to 4 solutions. Now, okay, that's received. So let me go to the quadrant and locate those solutions. Now clearly, if you were to see here, sine 30 gives us 1 over 2. So theta is pi over 6. So we need to extract 4 values. Now going to the quadrant, sine is positive in the first quadrant and sine is positive in the second quadrant. So pi over 6 should be over here. It is over here, right? Pi over 6 over here for the first value. Now we know that this quadrant receives all alpha. This quadrant receives pi negative alpha, right? Now the important part here is that we need to extract those values from the general solution. So clearly I mentioned to you, if some sine theta is equal to some sine alpha, then the value of theta is equal to, let me give you that value, n times pi plus followed by negative 1 raised to the power of n times alpha. So this will give us in general all the solutions. But taking alpha, in this case when I say alpha, we are talking about this value, right? Alpha is equal to 30 degree produces this. So probably I can state here instead of this is okay, but this indirectly means if I were to write this as sine theta is equal to sine alpha, then the meaning is alpha is equal to pi over 6. That's the understanding. So 4 solutions have to be obtained. That means we start with n is equal to 1 and stretch all the way to 4. 1, 2, 3, 4. That's exactly what we are going to do. So when n is equal to 1, let me write down the solutions here. This is going to give me pi, okay, pi plus n is equal to 1. That's going to be negative there. So let me place a negative sign followed by pi over 6. So this is going to be 5 pi over 6. That's a next value, right? So this is going to be 5 pi over 6. Okay, so now when n is equal to 2, so when n is equal to 2, this is going to be 2 times pi negative 1 raised to the power of 2, that's going to be positive, and followed by pi over 6, and this is going to be 6 times 2, right? 6 2s are 12, 12 positive 1, that's going to be 13 pi divided by 6. Now this 13 pi over 6 is going to be falling over here, 13 pi over 6. Now I have taken n is equal to 1, n is equal to 2, and the next value is n is equal to 3, because those counts for n would complete the 4 solutions that we are talking about here. So n is equal to 3 would give me, this is going to be 3 pi, right, negative pi over 6. So this is going to be 18 pi minus pi divided by 6, which is going to be equal to 17 pi over 6. Right, 17 pi over 6, and that is going to be over here, 17 pi over 6. So if you were to be talking about the solutions, we need here, let me write down the solutions. Pi over 6, okay, this is for sine value. Pi over 6, 13 pi, in fact I need to follow it up with 5 pi, okay, 5 pi over 6, 13 pi over 6 and 17 pi over 6. We are not finished yet, but an important observation that we need to take into account is that we have taken theta to be equal to 2x, and these are the values that we have obtained for theta. So this is going to be 2x here. So we need the value of x. So let me write down the values of x. So this is equal to x being, so pi over 12, right, you got to multiply by 2, comma 5 pi over 12, comma 13 pi over 12, comma 17 pi over 12. I know we have a little bit restrictive space, so I'm trying to give you the entire solution in one go. So these are the values of x for this particular question, students. I hope you enjoyed this. Students, we've been given this question and we are expected to prove this using the identities that we have studied. Now in the numerator we got cos 4t negative cos 2t. In the denominator we got sin 4t positive sin 2t. So having got this information, I will start off by stating this. Consider the left hand side. So I would be rewriting cos 4t followed by negative cos 2t divided by sin 4t positive sin 2t. Now we know that cos A negative cos B is equal to negative 2 times sine of A positive B divided by 2 times sine of A negative B divided by 2. Also, we know that sine A positive sine B is equal to 2 times of sine of A positive B divided by 2 times cos of A negative B divided by 2. So we will be using these two formulae in the left hand side. So if we were to do that, so this is going to be equal to, so therefore the left hand side will be rewritten as negative 2 times sine of 4t positive 2t divided by 2 times sine of 4t negative 2t divided by 2 over 2 times sine of 4t added with 2t divided by 2 times cos of 4t negative 2t divided by 2, which is equal to, the 2 and the 2 can be cancelled. I got a negative sign there. Now these two components will get cancelled. I've got sine of 4t negative 2t will give me 2t divided by 2 over cos of 2t divided by 2. So 2 and 2 gets cancelled, 2 and 2 gets cancelled. So this is going to be negative sin t divided by cos t, which is nothing but negative tan t, which is what is required. So this is the requirement. So this is equal to right hand side, hence proved. So you got to state that. So we given another question. We are expected to prove cos of A positive B divided by cos A multiplied with cos B is equal to 1 negative tan A times tan B. So what I would do is I will start off by considering the left hand side, which is cos of a positive b divided by cos a cos b. Now we got a formula. What is that? Cos, we know this, cos of a positive b is equal to cos a cos b, positive sign, so it's going to be negative sin a sin b. So if I were to use this, using this, if I were to take this to be as 1, hence the left hand side of 1 becomes, so in place of this I'm going to write cos a cos b negative, in fact I should use lowercase, right, a and b, followed by sin a sin b divided by cos a cos b. Now we know from algebra a positive b divided by c is written as a over c positive b over c. So by that fact this is equal to cos a cos b divided by cos a cos b negative sin a sin b divided by cos a cos b. Cos a can be cancelled, cos b can be cancelled, giving me 1 negative sin a over cos a. I can rewrite it like this, multiplied with sin b over cos b. This is equal to 1 negative sin a over cos a is tan a, sin b over cos b is tan b. Now what is this? This is nothing but the right hand side. So this is equal to right hand side, hence proved. Students, let's do some questions using the double angle formula. Now I have given you several formulae. Now you can check the lesson video on that. Now foremost, let us start with sine 2 alpha. Now I'm going to write, I have given you the formula, but yet I would like to derive the formula here. Now I can write sine 2 alpha as sine of alpha positive alpha, and then I would use sine of a positive b, compound angle formula, which is nothing but sine a cos b positive cos a sin b, right? So that would mean this can be rewritten as sine alpha times cos alpha positive cos alpha times sine alpha. Now I've got a sine alpha cos alpha, sine alpha cos alpha. I can add them down, thereby leading me to obtain 2 times sine alpha times cos alpha. So this would mean sine 2 alpha is equal to 2 times sine alpha times cos alpha. This is a famous identity. Now having got this, let me just apply this identity in solving a simple question, right? Probably, let's do this. This is an example. The question is express, say 14 times sine 6x times cos 6x in a single term. So that's a question. So now what I wish to do is I would like to write it in this fashion, right? So 2 should be there, sine 6x is there, and cos 6x is there. Now since I've taken 2 inside, there should be a 7 there, right? Now if I were to take theta to be as 6x, then this can be rewritten as 7 of 2 times of sine theta times cos theta which is equal to 7 times of, now 2 times sine theta cos theta is equal to sine 2 theta, sine 2 theta, but my theta is 6x, so this is equal to 7 times of sine of, if I were to place 6x here, this is going to become 12x. So what's the solution? Solution is nothing but 7 times sine of 12x. That's the answer. Now let's do this question. We have been given cos of 9 over 2 times x times sine of 9 over 2 times x. Now whenever you got a product of sine and a cos, you can very well use the popular sine to alpha formula or sine to theta. So we know that sine to alpha is equal to 2 times sine alpha times cos alpha. Now consider this quantity. Consider, I'm not going to write it as cos and sine, I'm going to write it as sine 9 over 2 times x times cos 9 over 2 times x, right? AB is equal to BA. So I would multiply this by 2 and I'm going to divide by 2. So 2 over 2 times sine 9 over 2 times x cos 9 over 2 times x, and then I'm going to rewrite this as 1 over 2 and I'll move this 2 inside. So it's going to be 2 times sine of 9 over 2 times x times the cos of 9 over 2 times x. Now let me take theta to be equal to 9 over 2 times x, right? So that would mean this is going to be equal to 1 over 2 times of 2 times sine theta times cos theta. But what is this? 2 times sine theta cos theta. That's going to be sine 2 theta. But what is theta? My theta is 9 over 2 times x, right? So 2 can be cancelled. This is going to be 1 over 2 times sine 9x. This is the solution to this question. So actually what they're asking is that they want us to write this particular term as a single term. So that's exactly what we have done here. Let's do another question, students. We are expressing the given terms as a single term, so we will be continuing to answer questions in that similar fashion. So this is question number 3. So we're given that cos squared 5x negative sine squared 5x. We are asked to express this as a single term. Now we know that cos 2 theta is equal to cos squared theta negative sine squared theta. So hence cos squared 5x negative sine squared 5x can be rewritten as, if I were to take theta to be equal to 5x, then this is going to be cos squared theta negative sine squared theta, which is going to be cos 2 theta. But since theta is equal to 5x, this is going to be equal to cos of, or in other words cos followed by 2 of, in place of theta you replace 5x. So this is going to be cos 10x. So that is going to be the solution for this particular question. Now question 4, we've been asked to write 3 negative 6 times cos squared 8x as a single term. So foremost, what I wish to do is I would like to rewrite this by taking 3 out. If I were to take 3 out, this is going to give me 3 of 1 negative 2 times cos squared 8x. Now let me take theta to be equal to 8x, and hence this can be rewritten as 3 times of 1 negative 2 times cos squared theta. Now if I were to take the negative sign out, then this is going to be negative 3 of negative 1 positive 2 times cos squared theta, which can however be rewritten as negative 3 times of 2 times cos squared theta negative 1, right? But this is nothing but cos 2 theta. So this is equal to negative 3 times of cos 2 theta. But what is theta? Is equal to 8x. So it's going to be negative 3 times cos of 2 times of 8x, which can be rewritten as negative 3 times cos 16x. So that is going to be the solution for this question. So let us move on to do question number 5. We've been given 6 times tan 5x divided by tan squared 5x negative 1. Now we will be using the following formula. We know that tan 2 theta is equal to 2 times tan theta divided by 1 negative tan square theta. Now if there is theta here, theta should occur here. So do not change the variables. For example, if you were to write theta here, you cannot write x here. That is totally incorrect. So please be aware of that particular fact. So we are going to use this formula and we are going to completely represent this quantity as a single term. So foremost, what I wish to do is I would like to place 2 there and take 3 out. So this is going to be 3 of 2 times tan 5x divided by, I would like to take negative sign out. So this is going to be 1, because 1 times negative gives me negative 1, followed by, there should be a positive sign for tan squared x. So I need to place a negative sign here. So this is negative tan squared of 5x. Now if I were to take theta to be equal to 5x, then I can rewrite this as 3 times of 2 times tan theta divided by, a negative sign is here, so let me place a negative sign there. So this is going to be 1 negative tan squared theta, which is nothing but negative 3 times of, as I mentioned to you, 2 tan theta divided by 1 negative tan square theta is tan 2 theta. So this is going to be tan 2 theta, which can either be represented also as negative 3 times tan 2. My theta is 5x, so place that 5x there, which is equal to negative 3 times tan 10x. So that is the solution for this question. Now having got this, let us head on to prove some identities. Students, we are going to be using the double angle to prove some important identities. Now the first question is, we are asked to prove sine 6x over 1 positive cos 6x is equal to tan 3x. Now what I wish to do is, I would like to write this. Foremost, let me just consider the left hand side. So that's going to be sine 6x divided by 1 positive cos 6x. Now I wish to write sine 6x as sine 2 times of 3x divided by 1 positive cos 2 times of 3x, right? So clearly you can see that we can easily apply sine 2 theta formula and cos 2 theta formula. Let me write that down. Since sine 2 theta is 2 times sine theta cos theta, and cos 2 theta is equal to 2 times cos squared theta negative 1. I'm specifically using this formula for cos 2 theta. So if I were to substitute them, this is going to give me, assume that theta is taken to be as 3x, right? So visualizing that, write the formula. So this is going to be 2 times of sine theta, so sine 3x times cos theta, so cos 3x, divided by 1 positive of cos 2 theta is 2 times cos squared 3x negative 1. So removing the parenthesis, this is going to be equal to 2 times of sine 3x times cos 3x divided by 1 positive 2 times of cos squared 3x negative 1. Positive 1, negative 1 gets cancelled, and that would give me 2 times of sine 3x times cos 3x divided by 2 times of cos squared 3x. 2 can be cancelled. A cos and a cos 3x can be cancelled, giving me sine 3x divided by cos 3x, which is tan 3x, which is right hand side, hence proved. Right? You see that? And that is the end for this particular question. We are asked to prove this question, students. Cot x negative tan x is equal to 4 times cos squared x negative 2 divided by sine 2x. Now in this case you can either use the left hand side or you can use the right hand side, so depending upon your choice. So what I wish to do is I would start with the left hand side. So consider the left hand side. It's going to be a little bit lengthier if we use the left hand side, but if we were to use the right hand side, the solution would be quicker. Probably, let me just try both sides. So consider the right hand side. Right hand side is 4 times cos squared x negative 2 divided by sine 2x. So if I were to take 2 out, this is going to be 2 times cos squared x negative 1 divided by sine 2x. Now 2 times cos squared x negative 1, that's going to be cos 2x, and you have a 2 there, and you got sine 2x here, right? Cos 2x, if I were to write it as cos squared x negative sine squared x divided by sine 2x. So I'm just moving on right from here, right? So assume that there isn't any strike. So this is equal to 2 times of cos squared x negative sine squared x divided by sine 2x is going to be 2 times sine x cos x. So 2 gets cancelled. Now you got a negative b divided by c. I can rewrite this as a over c negative b over c, right? The algebraic property. So from that, this is going to be cos squared x divided by sine x cos x. So a cos and a cos gets cancelled, followed by sine squared x divided by sine x cos x. Sine gets cancelled. So this is giving me cos x divided by sine x negative sine x divided by cos x. Cos x over sine x is cot x. Sine x over cos x is tan x, which is nothing but the left hand side, hence proved. Right? So that is actually taking the right hand side. Now let us consider the left hand side, okay, which is, this is cot actually, right? This is cot. So cot x negative tan x, this is what has been given. So let me take this as cos x over sin x and tan x as sin x over cos x. Now if I were to take the LCM as sin x cos x, this is going to give me cos squared x, this is going to give me sin squared x. Cos squared x negative sin squared x is cos 2x divided by sin x over cos x. Now what I wish to do is I would like to multiply the numerator by 2 and divide by 2. So 2 times cos 2x, I'm just retaining it as it is. So cos 2x, now I would like to write cos 2x as 2 times of cos squared x negative 1, and I have 2 times sin x cos x. So 2 times sin x cos x is nothing but sin 2x. So this is equal to 2 into 2 gives me 4 times cos square x negative 2 divided by sine 2x, which is equal to right hand side, hence proved. Right, so I have actually taken two sides, both the sides, and I've shown you the proof. It's up to you. You don't have to use both the sides. It's just sufficient enough that you focus on one side and extract the solution to the question. So this is all about using double angle identity. Let's do this question, students. This is a bit different. We are expected to find the double angles given the following. So given tan A is negative 2 and that A is lying between 2 pi and 3 pi over 2. So with this information, we are expected to find the exact value of sine 2A secant 2A, and the third one is tan 2A. Now let me draw the quadrant. So this is going to be 0, pi over 2, this is pi, this is 3 pi over 2, and this is going to be 2 pi. And we are asked to extract these values given that A lying between 3 pi over 2 and 2 pi. So this is the quadrant that the angle is lying. So this is the fourth quadrant. In fourth quadrant, tan is negative, sine is negative, and only cos is positive in fourth quadrant. So let me draw this triangle, right triangle. So you got the complete right triangle to work with. Now we are being given, so if I were to take this as A, this is opposite side, and this is adjacent side, and this is hypotenuse side, right? Now tan A is opposite side divided by adjacent side, so which is given to be as negative 2. I can rewrite this as negative 2 over 1. So you don't have to take the negative sign when you are placing the value. So opposite side is 2, adjacent side is 1. Now to get the hypotenuse, we take the square of this, add it with square of this, and take the entire square root. So if I were to take this as O, A and B, so this is going to be OB squared plus AB squared is equal to OA squared. My OB squared is 1 squared, my AB squared is 2 squared, so 1 added with 4 would give me 5, so this is my OA squared. So therefore OA is root of 5 units. So this is the hypotenuse. But given the value for hypotenuse, I can take the value for sine. So sine A is nothing but opposite side by hypotenuse side. My opposite side is 2, my hypotenuse side is 5, root 5. Now a very important observation we need to make here, sine is negative, so you need to place that negative sign there because of the quadrant. Next is cos A. Cos A is adjacent side divided by hypotenuse. My adjacent side is 1 and my hypotenuse is root 5, so this is positive. It is highly imperative that these signs are mentioned, right? You exclusively make it a habit to place the sign because of the information given to us. Now having got this information, let me solve the first question. First question says sine 2A. Now we know the formula, double angle for sine 2A, which is nothing but 2 times sine A, cos A, which is nothing but 2 times sine A is negative 2 over root 5, cos A is 1 over root 5, 2 times 2, 4 with a negative sign, root of 5 times root of 5 gives me 5. So the value is negative 4 over 5. So that is for sine 2a. Now let me go for secant 2a. Secant 2a is nothing but, secant theta is nothing but 1 over cos. So this is going to be 1 over cos 2a. I'm going to use the formula for cos 2a as cos squared a negative sine squared a, which is equal to, my cos is 1 over root 5 raised to the power of 2, negative, my sine is negative 2 root 5 raised to the power of 2, which is equal to 1 over root 5 raised to the power of 2 gives me 1 over 5. Negative 2 raised to the power of 2 is positive 4 divided by 5, right? So this is going to be 1 over, so this is equal to 1 over 1 negative 4 would give me negative 3 over 5. If you were to flip it, you get 5 over 3 with a negative sign. So this is the value for secant 2a. Now tan 2a is also asked. We are expected to find the value of tan 2a. Now tan 2a is nothing but 2 times tan a over 1 negative tan squared a. Now we got the value for tan a. It's already given in the question. Tan a is negative 2. So place the value negative 2 divided by 1 negative 2 square. This is going to give me negative 4 divided by 1 negative 2 squared is going to be negative 4, which is nothing but negative 4 over 1 negative 4 would give me negative 3. These two negatives gets cancelled, giving me the solution as 4 over 3. Students, now we are going to be using half angle identities, right? And we would see how exactly to apply them. So this is more to do with the application part of this concept. I've already given you the formulae for half angle, and yet so whenever there is a question coming up using half angle, I will suggest or I will state the relevant half angle formula that is going to be applied. So foremost, we are expected to solve this question. So the question is, determine the exact value sine pi over 12 using half angle identity, right? This is the question that's being asked. Now foremost, I would have to determine the formula. Now let me state the half angle formula. Sine alpha over 2 is equal to root of 1 negative cos alpha over 2 if alpha over 2 is located in the first or second quadrant. Otherwise, sine alpha over 2 is equal to negative square root of 1 negative cos alpha over 2 if alpha over 2 is located either in the third or fourth quadrant. So having mentioned this, it becomes imperative that we find out in which quadrant pi over 12 is. Now pi over 12 is given as a radiant measure, so I want to convert it into degrees. Hence you multiply by 180 over pi. So pi gets cancelled, giving me 180 divided by 12. If you were to divide 180 by 12, you will get 15 degrees. So this would mean pi over 12 lies in the first quadrant. So that would mean all ratios are positive. All ratios are positive in the first quadrant. So that's the first thing that we need to do. So after we have done that, we would be now utilizing this formula. Hence, the required formula is sine alpha over 2 is equal to square root of 1 negative cos alpha over 2. Now, but we are given, what are we given? We are given sine pi over 12. So that would mean in place of alpha over 2, we got pi over 12. So that means we need to know what is alpha. So this means alpha is equal to 2 times, I'm just cross multiplying, so it's going to be 2 times pi over 12, which is nothing but pi over 6, which implies the value of alpha is pi over 6. So take the value of alpha and substitute it here. So therefore sine pi over 12 is rewritten as sine, in place of alpha we got pi over 6 divided by 2, right, which is equal to square root of 1 negative cos alpha is pi over 6 divided by 2, which is equal to root of 1 negative cos pi over 6, that's nothing but cos 30 degrees. Cos 30 divided by 2. Now what is cos 30? Cos 30 is root 3 over 2. So I need to substitute that. So it's going to be 1 negative root of 3 divided by 2 divided by 2, which is nothing but 2 negative root of 3 divided by 2, and you got a divided by 2 and you got a square root, which is equal to 2 negative, in fact let me write it like this, 2 negative root 3. If I were to flip this denominator, it's actually 2 over 1. So if I were to flip it, I would be having something like this, 1 over 2 with the square root, which is nothing but root of 2 negative root 3 divided by 2 times of 2 into 2 gives me 4. So this is the exact value of what? Therefore sine pi over 12 is equal to square root of 2 negative root of 3 divided by 4. Of course you can rewrite this further as 2 negative root of 3 divided by root of 4 will give you 2. So this is a positive value, so positive, so that's going to be the solution. Students, we are expected to solve the trigonometric equation of this form: sine squared theta is equal to 2 times sine squared theta over 2, where theta lying in the interval 0, 2 pi. So foremost what I would do is I would use this formula. We know that because we need to consider this entire system as a single equation, and then we need to proceed. So we are going to use the half angle formula. So we know that sine alpha over 2 is equal to root of 1 negative cos alpha divided by 2. So we will be using this formula. So if I were to take this as 1, therefore I can rewrite 1 to be as sine squared theta is equal to 2 times of root of 1 negative cos theta divided by 2 raised to the power of 2. So this would mean I now have sine squared theta is equal to 2 times of the square and the square root, they get neutralized, giving me 1 negative cos theta divided by 2, right? Because the entire quantity is within the square root. So the 2 and the 2 can be cancelled, giving me sine square theta is equal to 1 negative cos theta. I want to take everything to the left side. So if I were to take everything to the left side, I would get sine square theta negative 1, this becomes positive cos theta is equal to 0. Now if I were to write sine square theta as 1 negative cos square theta, then I've got 1 negative cos square theta, negative 1 positive cos theta is equal to 0. Negative 1 positive 1 gets cancelled. So now I got cos theta negative cos square theta is equal to 0. From here I can take cos theta out, so that's going to give me 1 negative cos theta is equal to 0. From here I got cos theta is equal to 0 or 1 negative cos theta is equal to 0, from which I got cos theta is equal to 1. Half of cos, so When theta is equal to 0, cos it's 1. So the graph will start to look like this, right? And at pi over 2, cos pi over 2 it's 0, and at pi it will hit negative 1, and at 3 pi over 2 it hits 0, and at 2 pi it hits 1, right? So if you were to examine cos theta is equal to 0, in other words, the values for which cos theta will be equal to 0 would be the following. When theta is equal to pi over 2, it's going to be 0, and 3 pi over 2, and so on it goes. But apparently our restrictive interval is 0 to 2 pi. Now next is cos theta is equal to 1. So we need to study this also. Now cos theta is equal to 1 for what values? Clearly theta should be equal to 0, and at pi it's negative 1, we can't take that, and at 2 pi it is hitting 1. So if you were to sum up all these things, so therefore the possible values of theta given the interval 0, 2 pi is going to be 0, pi over 2, 3 pi over 2, and 2 pi. So this is the solution. Students, we got a good question. We are expected to find the value of cos 112.5 degrees, right? So how are we going to do this? Now what I wish to do is I would like to rewrite this degree cos 112.5 degrees. This is what has been given. So I would like to rewrite this as multiplied by 2 and divided by 2. So what happens here? This is going to be equal to cos 225. When you multiply 112.5 by 2, you get 225 degrees, right? So degree, that symbol is there, divided by 2. So what are we going to do is we are going to find the value for this. Now this is nothing but this is likened to the value of cos alpha over 2, where I can state alpha being equal to 225 degrees. So that is the initial adjustments that we have to do. Now this is going to be our half angle. Now we know that cos alpha over 2 is equal to root of 1 positive cos alpha divided by 2. So alpha is 225, so we will have to place 225 there. So therefore cos of 225 over 2 is going to be equal to root of 1 positive cos 225 divided by 2. Now if we know the value of 225, this question is completed, it's finished. So the value of 225, how are we going to get the value of 225? Now 225 can be written as cos of 180 positive 45, right? Now this is similar to our cos of a positive b. So what is that? That's nothing but cos of 180 times cos 45 negative sine of 180 times sine 45. Now sine 180, that leads us to 0, so there's no point in keeping that. So all we got is cos 180. Cos 180 we know it's negative 1, and cos 45 is nothing but 1 over root 2. So we got a value of negative 1 over root 2 for our 225. And what we can do is just to have the calculation, right, simplified. I'm going to multiply this by root 2, divide by root 2. So this is going to be negative root 2 divided by root 2 multiplied with root 2 would give me 2. So this value I can always use. So if I were to take this as 2, I can state here, therefore 2 is rewritten as root of 1 negative root 2 over 2 divided by 2. So the root actually flows. This is equal to root of 2 negative root 2 divided by 2. I already have 2 here, so that would come over to the denominator, thereby giving me 2 times 2 4, but I can in turn rewrite that as square root of 2 negative root of 2 divided by 2, right? So this is what we have got. Now there is one important thing that we need to know. Now you need to get hold of the sign. So how are we going to handle that sign? Now if you were to draw the quadrants, this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Now if you would remember, I had made the rule for taking the value of root of 1 positive cos alpha divided by 2, the half angle rule. In fact, that rule is the universal rule, and it states that this can be positive if the value of alpha over 2, if this value lies either in quadrant 1 or in quadrant 4. Apparently 112, the value 112.5 degrees is present in quadrant 2, where sine alone is positive. In this quadrant, cosine value is negative, right? So what we got to do is we will have to now place the sign, because cosine of 112.5 degrees is going to give us a negative value because of the fact it is present in quadrant 2. So place the sign. Of course, I have not placed the sign initially to avoid any confusions, because we are actually performing two different operations using a different identity. This is the compound angle identity. So it's always better to solve it, get the extraction, and then talk about the sign, decide on the sign. Now if you were to come across here, the sign is going to be negative, the sign is going to be negative, the sign is going to be negative. So this is the final solution. So you can simply state here, so hence cos of 112.5 degrees is equal to negative root of 2 negative root of 2 divided by 2. So this is the solution, and it is only valid when you place a negative sign. So don't forget the negative sign. So having mentioned that, this is a lovely question to experience half angle trigonometry. Let's do another question, students. We've been asked to find the exact value of sine 105 degrees. Now the power of the half angle is that without even using any calculating devices, we will be able to extract this value. Now, let me show you that. Now what I would like to do is I would like to rewrite sine 105 degrees by multiplying it with 2 and dividing it by 2. So this is going to give me sine of 210 degrees divided by 2, which I'm going to write it as sine alpha over 2, where the alpha value is equal to 210 degrees. Now we know this formula. We know that sine of alpha over 2 is equal to root of 1 negative cos alpha divided by 2, of course depending upon where the value of alpha over 2 lies. In this case it's going to be positive for the very fact it's 105, and that is present in quadrant number 2 where sine is positive. Now this in turn can be applied. So therefore sine of 210 degrees divided by 2 is going to be equal to root of 1 negative cos 210 degrees divided by 2. Now the question comes here is, what is cos 210 degrees? Now that's nothing but cos of 180 degrees positive 30. Now I'm going to apply cos of A positive B formula. So that would give me cos 180 times cos 30 negative. When you got a positive sign, the formula takes a negative sign when you place the expression on the right side, followed by sine 180 times sine 30. Sine 180 is going to produce 0, so there's no point in retaining it. So all we got is cos 180, which would give us a negative 1, and you got cos 30. Cos 30 is root of 3 over 2. So you got a value in this fashion, negative root 3 over 2 for cos 210 degrees. So if you were to take this as 2, I can now rewrite, therefore 2 is equal to root of 1 negative. Now there is a presence of a negative sign, so we need to take hold of that. So we take this and we substitute it right into 2. So this is going to be 1 negative of negative root of 3 over 2, and you got a 2 there in the denominator, so I would place it in this fashion. Now this can be further rewritten as square root of negative will become positive, 1 positive root of 3 over 2 divided by 2, which is equal to root of, I'm going to take 2 as the LCM here, so this is going to give me 2 positive root of 3 divided by 2. There is a 2 here, so that's going to become 2 squared. Now if I were to apply the square root for the numerator and the denominator, I would get root of 2 positive root of 3 divided by 2. Now as I mentioned to you, 105 degree which we are talking about lies between the angles 90 and 180. In fact, this is quadrant 2 where sine is positive, right? So this is going to be producing a positive value, and on the left you got sine 105 degree. So this is the solution for the question. So a point of observation is that though we have a negative sign here, cos of 210 degree which we are calculating is producing us a negative root of 3 over 2. And that is the reason when I place the value negative root of 3 over 2, it becomes positive here. So that is a very important observation that you will have. Students, now it's time for us to understand polar coordinates. Now all these times we are dealing with what is called as Cartesian coordinate system. Now in this coordinate system we deal only with x and y. So suppose you are looking to plot a point, say 2, 3. If I were to plot this point 2, 3, the system that I am using here is called the Cartesian system. So when I say x is equal to 2 and y is equal to 3, the understanding is from the y-axis the point is located 2 units away, and from the x-axis the point is away by 3 units. So that is the understanding that we need to have when we are talking about Cartesian coordinates. Now coming to the point of polar coordinates, if each point of course we are talking about two-dimensional system, of a two-dimensional coordinate system, is identified based on the distance from a reference point I'll explain to you what exactly the term reference point is. And an angle taken from a reference direction then such a system is known as polar coordinate system. So the same x and y which I've just shown you here, it can be represented in this fashion. So I got the point there and the line is drawn. This is the origin. We call this point as the pole. And this distance is r and this angle is theta. So this point is going to be r comma theta. Now if you were to drop a perpendicular, this point is away from the so-called, I can't mention here as x-axis here, I shouldn't do that, just for the sake of understanding. This is away from the x-axis y units. You don't have to mention it here, just for your understanding, and it is away from the y-axis x units. So this is what I've just explained to you here, but in this case it is more graphically represented. So having got that, there are a few things we will have to know when we are talking about the polar coordinate system. So as I mentioned to you, pole, okay, when we talk about pole, it means the reference point. You got to know this. And then polar axis. So this is nothing but the line segment from the pole in the reference direction. So in this case, when you talk about polar axis, we are talking about this line, right? And as I mentioned to you, the origin is called as the pole. So this is the starting point. And x comma y is represented as r comma theta. Now when we mention the letter r, we are obviously talking about the unit circle, and this is the radius, right? So that has to be taken into account. You need to know what is called as a polar grid. So let me write that down, polar grid. And how does it look? So it starts with 0 over here. So I will try to draw a miniature version. So 30 degrees is over here. This is 30 and this is going to be 60, and you got 90 over here, and then over here it's 120, and over here it is 150, and you got 180 here. So this is 90, 30, 60, 120, 150, and then over here you got 210, over here you got 240, and over here it's 270. Right over here you got 300, and over here you got 330 and 360. So if you were to connect them all, I'm trying to get a circle. Okay, that's fine. So let me write these points down. 210, 240, 270. This point is 270. This is 300, 330, and you got 360. Right, so this point is 0, 360. So that's nice. So probably you can draw the poles, I should say the polar axis. Now in between you can have infinite number of polar axes, and it is imperative to understand that one particular point has got infinite number of polar representation. That is a noteworthy point you need to know. And given R, you can always extract the negative part. Say for example you are given R, theta positive 2 and pi. You can always find a negative R located at theta positive 2 and positive 1 times pi. So this formula will come in very much handy when we are dealing with polar coordinates. Now theta is positive if measured in anti-clockwise direction. Anti-clockwise. So anti-clockwise means in this direction. Okay. Let me show you. If you are moving up like that, and if you are moving in clockwise direction, theta is negative if you are moving in clockwise direction. So clockwise direction means like this. Right? This is the way clockwise, and anti-clockwise means like this. So from here, this is positive, 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 positive. And if you were to move counter in the sense, counter the direction which I just mentioned, the negative, 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 right? So have that in mind. So that's the basic thing. Now, having given you that, let's move on. Next comes the relationship between Cartesian and polar coordinates. Now we know x and y are Cartesian, and the formula connecting them is x is equal to r cos theta and y is equal to r sin theta, and r squared is given to be as x squared positive y squared, which can easily be obtained, and r from here is equal to root of x squared positive y squared. And if you want to get the value of theta, you have to calculate the y over x value. So y over x will be equal to tan theta, and from here theta is equal to tan inverse of y over x. So this gives the argument, this gives the magnitude. So it's a very important concept that you will have to know. So we are dealing only with two-dimensional trigonometry. In other words, the r and theta value alone we are associating with. Probably when we move up, we can bring in three-dimensional geometry also. But for now, we will just restrict ourselves to two-dimensional geometry. So having mentioned this, let me just give you a simple question. The question is, convert Cartesian to polar form, right? We have been given 2, 2. So we have to convert this into polar coordinates. So this is my x and this is my y. Now r is equal to root of x squared positive y squared. so which is nothing but root of 4 positive 4, which is nothing but root of 8. So that is going to give me 2 times root 2. And theta is nothing but tan inverse of y over x, which is going to be equal to tan inverse of 2 over 2, right? And that is going to be equal to tan inverse of 1, which is nothing but pi over 4. So therefore my r comma theta is equal to 2 times root 2 comma pi over 4. So this is interesting question. So students, let's do this question. We are expected to plot this polar coordinate m of 2 comma pi over 2 and followed by n of 3 comma 3 pi over 4. Now foremost, let me draw the circle. Now this is 2 units and this is 3 units. So let me start off with 1 unit. So this is r is equal to 1, and moving up, this is r is equal to 2, and moving still further up, this is r is equal to 3. Now you don't have to be really precise, but just a close approximation is sufficient enough. Now having got that, r is equal to 2 is over here, but it's pi over 2. As I mentioned to you in the earlier classes, I have clearly drawn the circle with all the degrees. So we start here with 0, and then this is going to be pi over 2, this is pi, and this is 270, 3 pi over 2, and this is going to be 2 pi, this is 360. Now they are asking us to find m of 2 comma pi over 2. So that point is going to be over here, right? So that is the solution for this part of the question. Now we need to move up for n of 3 comma 3 pi over 4. Now what is 3 pi over 4? Let me calculate. Pi over 4 will give me 45 degrees. So 3 times 45, 3 5s are 15, 1, 3 4s are 12, 13. 135 degrees. This is 180 degrees. So clearly, if you remember, I have plotted 130 degrees in the previous question, and we have 135. So 135 would be somewhere over here. So this is the point that we are looking for. So you can simply circle that point, and what you can do is you can connect it to the pole. This is the pole. I mentioned to you 0 is the pole. So this is going to be my n of 3 comma 3 pi over 4. So these 2 points we have plotted. Of course, if you want, you can just have a blue lining over there just to indicate that you have plotted the point. So that is for it. Now let me ask you this question. Imagine this line is stretched from here onwards to this particular point. This is a straight line, right? And you are expected to find the coordinate of this particular point. So what would your answer be? I know the angle for this. I know the theta value, that is 3 pi over 4, but I do not know the theta value for this. Imagine this point is C, and you are expected to find the coordinates for this particular point. Now r is not going to be changing, right? Because I already mentioned to you when I started, this is r is equal to 1, r is equal to 2, and r is equal to 3. So if the point is present on the last ring, r value is 3, and if the point is present on the second ring, r value is equal to 2. So that's a simple thing. So r is equal to 2 is found out. But the question now is, what is the value of theta? We know the value of theta over here is 3 pi over 4. Now if you want to get this value of theta, you can clearly see here, theta is actually making pi turns. From over here, it has to move all the way to reach this particular point, right? The only thing is that it is on r is equal to 2. So to get that value of theta, all you need to do is add pi. So that is going to give me 3 pi positive 4 pi divided by 4, which is equal to 7 pi divided by 4. So the theta value here is 7 pi divided by 4. So what would that be? This is going to be 7 times 45, which is nothing but 7 5s are 35, 3, 7 4s are 28, 29, 30, 31, 315 degrees. So this is 135 degrees, and if you want to come over here, this is actually 315 degrees. So I can write that down, 315 degrees, and this is actually 135 degrees, just for your understanding. Okay, now having got that, let me move up a little bit further, say over here, right? Now let me give you a value of r comma theta, say some point d. Okay, I'm taking some point d over here, and they are giving you the r value. That's clearly obvious. That's going to be 2, comma, and the theta value, say pi over 4, and they are actually expecting you to find this point f. What is the r value for this and the theta value for this? This is what is expected from you. Now clearly, if you were to draw the line connecting this and this, it's actually a straight line. So as I mentioned to you, theta is actually, now we are moving with the anti-clockwise, so theta is actually traveling 180 degrees, right? So in this case we are adding pi. So if we were to add pi, I got pi over 4 positive pi. This is going to be pi plus 4 pi divided by 4, which is going to be 5 pi divided by 4. Now what is this 5 pi divided by 4? That's going to be 225 degrees. Now this is 270 degrees, right? And clearly this is going to be 225 degrees. So this is 225 degrees, this is 270 degrees. So the value of f, so therefore the coordinate system for f is going to be r is 3 units, comma 225 degrees. So we don't write it as 225 degrees, we give a radian measure. So the radian measure has to be placed. So let me change this. Okay, 5 times pi over 4. So that is the solution. So I hope you got an idea as to how you can get the values for theta. And you have to understand that one particular coordinate in a polar system can have infinite number of representation. So that is the beauty of it, for the very fact that we are dealing with circles. Let's do this question, students. We are expected to convert 10, 30 degrees, this is actually r comma theta, into Cartesian coordinates. Cartesian coordinate system x comma y. Now I've already given you the representation connecting Cartesian and polar coordinates. So let me write that down. Convert polar to Cartesian. And that relationship between Cartesian and polar coordinate is as follows. X is equal to r times cos theta. This is one representation, and for y, y is equal to r times sine theta. Now clearly from the given question, we know that the value of r is equal to 10 and the value of theta is equal to 30 degrees. So therefore x is equal to 10 times cos of 30 degrees. Now cos 30 is root of 3 divided by 2. So this can be written as 2 divides 10 5 times. So this is going to be 5 times root 3. So this is my value of x. So x is equal to 5 times of root 3. Now coming to y, the value of r is 10 and this is sine 30, and we know that sine 30 is 1 over 2. So this is going to give me 5. So y is equal to 5. Now we got x value and we have got y value. Of course, if you are interested, you can use the value of root 3 as 1.7321 and multiply it with 5 if you want. So that's going to be 1.7321. I multiplied with 5. 5 ones are 5, 5 twos are 10, 1, 5 threes are 15, 16, 1, 35, 36, 3. So it's going to be 8.6601. I can take it as 8.661. So therefore the Cartesian coordinate, Cartesian is x comma y is equal to, I got 8.661 comma 5. So this is the final solution for this particular question. So that's a very interesting question which talks about conversion, and we can also simultaneously do the vice versa part, that is converting the given Cartesian to polar coordinate. So convert I've already done a question on this, but let's do one more question. Convert Cartesian to polar. So you've been given this question 15, 8, and you need r, theta. Now, as I mentioned to you, x is equal to r times cos theta and y is equal to r times sin theta, and we know that r is equal to square root of x squared positive y squared, so that's going to be root of 15 squared positive 8 squared. So 15 squared is 225, 8 squared is 64, this is going to be square root of 289. You take the square of this, you get 17. So therefore r is equal to 17. You can have a box of this. And theta, also we know that theta is equal to tan inverse of y over x, which is nothing but tan inverse of my y value is 8, my x value is 15. So this is what we have got. Now, of course, you can use a calculator. If you were to use a calculator, this would be approximately 28.07 degrees, approximate value. So therefore r, theta is going to be equal to 17, 28.07 degrees. So this is the solution that we have got. Of course, you can convert it into radians, it's up to you. And this is in polar coordinates, in polar form. So that's a nice question. So we'll move on to the next one. Now let's do this question. We are expected to find the polar coordinates for -4, -5. So that's the question. So it's a very interesting question, and it will feature in a lot of competitive exams as well as in examinations conducted by various boards. Now draw the quadrants and identify the points. So it's negative for x-axis and negative for y-axis is -5. So if this happens to be -4 and this happens to be, say, -5, you are looking at a point, right? This is 0 over here. And if you were to draw and connect this, so this is what you are looking at, -4, -5. So we want to get the polar representation for this. So we know that x is equal to -4 from the given question, y is equal to -5. So r is going to be root of x squared positive y squared, which is nothing but square root of -4 squared added with -5 squared. So this is square root of 16 positive 25, which is 1 and 4 root of 41. So if you were to take the square root of this value, which is approximately will be equal to probably 6.41. Right, so I'm taking it as r is equal to, I'm not taking any approximation here, I'm just directly taking the value of r to be as 6.4. That's fine. Now theta is given to be as tan inverse of y over x, which is nothing but tan inverse of my y is -5, my x is -4, so that's going to be tan inverse of 5 divided by 4. If you were to look up or use your calculator, you will get the theta value as tan inverse of, this is going to be 1.25, and upon calculating this, theta value will be 51.34 degrees. It's an approximation. Now you have to understand that this is not what we want, right? Because 51.34 will be over here, right? But we want theta to be over here. So we are looking for this point on the third quadrant. So to get the value for the third quadrant, as I mentioned to you, we are not interested in the first quadrant value, we are interested in the third quadrant value. So to get the third quadrant value, we have to take the value 51.34 degrees, and to it you got to add pi, that's 180 degrees. So if I were to add 180 degrees, then this value is going to be 231.34 degrees. That's what we really want. that's is the value, because this is going to be 270 and we are looking at a point which is to the left of 270, so that's going to be 231.34 degrees. So clearly, so therefore you can conclude -4, -5 in Cartesian coordinate system as a polar representation being root of 41, which is 6.4, and comma 231.34 degrees, right? So this is the solution. Welcome students, we've been looking into the polar forms, and exclusively we are now going to be looking into the polar form of complex number. Now, before I could start off in giving you questions and related solutions with regard to the polar form of complex number, first it is imperative that you know what is the complex number. So let me write that statement down. A number of the form z is equal to a positive ib, where a is called the real part and b, the imaginary part, is called a complex number. Now this is the required definition for a complex number. Now you might be asking me, why do we need a complex number? For the simple reason, complex numbers are present mainly to handle negative numbers inside the radical sign. So what is the meaning of this? Suppose you have, say, x squared positive 16 is equal to 0, and you are expected to find the value of x. Now from here you can write x squared is equal to negative 16, and which can be again rewritten as x is equal to root of negative 16. Now this is a radical sign and you got a negative number present inside. Clearly you would say that there exists no real roots, right? Of course this is a right answer if you are not aware of the concept of complex numbers. Now because you are aware of the complex numbers, you can rewrite this value as square root of 16 times I squared, right? Because according to the definition of complex number, I squared carries a value as -1, and because of this fact I can write root of negative 16 as root of 16 I squared, and subsequently you can go on to solve it and extract the value for x. Okay, so we are not going into the details of a complex number. We will only be confining our study into the polar representation of any given complex number. So having mentioned that, let me just give you this question. Say this is a question that wants us to obtain the polar form of, say, a complex number of the form z is equal to -1 negative I times root 3. As I mentioned to you, the form of the complex number is actually in this way, a positive ib. In this case, clearly a is equal to -1, and so this is indeed a complex number. Now, how are we going to represent this complex number in polar form? Let me write that statement down. Any complex number as a polar form in the following manner. So I can always write z, so we got z is equal to r times of cos theta positive I sin theta. Now remember this is how we represent a complex number in polar form. Now concurrently we can also represent z to be as r cis theta. So in some of the textbooks you will get to see a representation like that, so you don't have to worry, this is nothing but this. But we will be using this because this comes very much handy in problem solving. So having got this can be further rewritten as r times cos theta positive I times r sin theta is equal to z. Now remember always, any z has a representation x positive iy or a positive ib, but in this case I'm just taking it as x positive iy. So if I were to place here x positive iy and write the right hand side term r times cos theta positive I times r sin theta, then equating the real part and the imaginary part we get. So what do we get from here? Clearly we get x is equal to r cos theta and y is equal to r sin theta. Now this is what I have given you when we started the polar coordinates in the last class. So this is exactly what we are getting, right? So having obtained this, we were going to be solving this particular question. So foremost, clearly from this question you got a quantity here, a real quantity and an imaginary quantity. Now anything with I as a prefix is mentioned as an imaginary quantity. Any quantity without I is mentioned to be as a real quantity. So I have that in mind. So having got this, we would also need the value of r. Now remember that the value of r in the last class, I gave you this formula, r is equal to root of x squared positive y squared. So this is all we need to solve questions in polar coordinates, at least for problems connecting or problems concerning forms of this nature. So what I'm going to do is I'm going to solve this question. So we are given, what are we given? We are given z is equal to negative 1 negative I times root 3, and we know that z is equal to x positive iy. So this means x positive iy is equal to negative 1 negative I times root 3. Now from here, equating, as I mentioned to you, the real part, we get x is equal to negative 1 and y is equal to negative. You don't need to place I, just place the quantity negative root of 3. You got the value for x, you got the value for y. Now you find r. The formula for r is root of x squared positive y squared, which is nothing but square root of negative 1 raised to the power of 2 positive root of 3 raised to the power of 2. This is going to give me 1. Root of 3 square will give me 3. So you got root of 4, which is nothing but 2. I'm going to be taking only positive value over here. So this is going to be my r. Okay, we have got r. Now concurrently we got this representation to find theta. Now tan theta is equal to y over x. So this means if I were to substitute the value of y, which is negative root 3, and x, which is negative 1, we are actually getting tan theta to be as root of 3 over 1. So this means tan theta is positive. So go back to the quadrant. You got alpha, pi minus alpha, and then pi positive alpha, and tan is positive over here and positive over here. So if you were to take the value of theta from here, theta is equal to tan inverse of root of 3. Now what is root of 3? This is going to be pi over 3, right? Tan 60. Tan 60 will give me root 3. You can substitute the value of alpha. Alpha is pi over 3. Substitute it there. And then this is going to be 3 pi positive pi divided by 3, which is nothing but 4 pi over 3. Right? So you got 4 pi over 3. So I'm going to use this value. So therefore, the complex number, which is of the form r times cos theta positive I times sin theta, is equal to, in place of r, substitute 2 times, in place of theta, you substitute 4 pi divided by 3 followed by positive I times sine 4 pi divided by 3. So this is the complex number in polar form. So that is the solution for this question. Now you might be wondering, why did I take 4 pi over 3? For the simple fact, just make this observation: x is equal to -1 and y is equal to -√3. So if you were to go and plot the points, this is -1 and -√3 would be somewhere over here, because √3 is 1.7321. So if I were to take this as -1, so 1.73, and this is -2, this is going to be somewhere over here. So the angle is actually present in this quadrant, right? -1, negative. So because of that fact, so let's do this question. Students, you got question number 2. Represent z is equal to 3 times √3. Of course, you got the imaginary value I there in polar form, right? So solution, so we can start the solution in the following way. We know that any complex number is of the form x positive iy. We will be taking x positive iy instead of a positive ib or c positive id, because it's always better when we are associating with x and y. No, it's more to do with the coordinate system that we are happy with. So because of this fact, I can now rewrite x positive. This means x positive iy is equal to 3 negative I times 3 times √3. Equating, we get x is equal to 3 and y is equal to -3 times √3. Now we need to get the value of r. So r is equal to root of x squared positive y squared, which is equal to root of 3 squared positive of -3 root of 3 raised to the power of 2, which is equal to root of 3 squared is 9. This 3 squared is 9 times 3, that's going to be 27. This is equal to root of 36, which is equal to 6. So my r value has already been obtained, is equal to 6. Now to get the value of theta, tan theta is equal to y over x, which is nothing but -3 times √3 divided by 3, which is equal to -√3. So we got tan theta is equal to -√3. Now let me just go and plot the point. We got 3, -3 times √3. Now if this is going to be 1, 2 and 3, let me calculate the value of 3 times √3 with a negative sign. Now root of 3 is 1.732. Let me just take it as 1.7. If I were to multiply by 3, 7 3s are 21, 2 3 1s are 3, 4, 5. So approximately you have a value of -5.1. So if I were to take this as 3, this as 4 and this as 5, -5, the point is going to be somewhere over here, right? 5.1. So this is present in the fourth quadrant. And another important observation is the value of tan theta is -√3. Now of course we have known the value -√3 have to be placed into the modular sign, and then subsequently we extract the value as +√3, and then we get the value for theta pi divided by 3, because tan 60, let me just take the value of tan 60. Tan 60 will be sine 60 divided by cos 60. Sine 60 is √3 over 2 and cos 60 is 1 over 2. So subsequently we will get √3, but we don't need √3, we need -√3 is actually present on this end, right? So we need to get the theta value for that. So we can't just place theta to be as pi over 3, right? For the simple fact, there are two things that are actually opposing it. One, the coordinates 3 and -3 root of 3, right? Though I've taken it as a positive sign, I cannot just use pi over 3. Actually, applying the modulus mainly to get the value, because after getting the value, what we need to do, we need to go back and use this popular tool. So what is the tool? Alpha pi negative alpha, pi positive alpha, and 2 pi negative alpha. This is the popular tool we should use. So if I were to use this tool, what will be the value of theta? So this is nothing but 2 pi negative pi over 3. Let me draw the line here. 3 2s are 6, 6 minus pi. This is going to give me 5 pi over 3. So this is the required value of theta. So I have this in mind. Of course, I just placed in all these things in a small space because of space constraint, and I didn't want to break the momentum, and that's the reason. So I hope you got this idea. Even though you're applying modulus sine and extracting the value, that is basically to obtain the value of theta, but not the final value of theta, which will go into the polar form, right? No, to get that value, we need to study the coordinates. I can clearly see it is present in the fourth quadrant, and to get a value in the fourth quadrant, we need to use this formula, 2 pi negative alpha. What we can do is we can just apply it in the formula and get the final result. Let me go to the new space. So the final solution is going to be z is equal to r times cos of 5 pi divided by 3 positive I times sine 5 pi over 3. So this is the polar representation and our solution. Students, now we are going to be using the theorem from De Moivre's, and it's a very important concept that you will have to know, because using this concept we would have to solve many questions, not only in trigonometry but also in complex numbers. So this is called as De Moivre's theorem. Okay, now what does the theorem states? If z is equal to r times, in fact I need to represent it in this fashion to avoid confusion. So it's going to be r of cos theta positive I sin theta. If there is a representation for a complex number in polar form, then z raised to the power of n is nothing but r times cos theta positive I sin theta. This entire thing is raised to the power of n, and this can be rewritten by De Moivre's theorem as r raised to the power of n times cos n theta positive I times sin n theta. This is the all important formula given by De Moivre, right? So he's a great man to have extracted this beautiful way of simplifying indices, right? Suppose the quantity is raised to the power of this index, and say it is n is equal to 10. With this application, the result can easily be obtained. So let's start our problem solving session with this particular question. Evaluate, say, 2 times of cos 120 degrees positive I times of sine 120 degrees, and this is raised to the power of 5. Now by De Moivre's, I can actually rewrite this in this fashion. So this is going to be 2 to the power of n times, now let me write 120 in radian measure. Now 120 degrees, you want to convert it into radian, you multiply by pi divided by 180. So 0 gets cancelled. We got 3 dividing 12, 4 times 3 dividing 6 times 2 dividing 2 times 2 dividing 3 times. So this is 2 pi over 3. Radians, RAD stands for radian. So you can use this. So this is going to be cos of 2 pi divided by 3 positive I times sine of 2 pi divided by 3 raised to the power of 5. So if I were to apply De Moivre's, now this I have already placed n there. In fact, assume that there is no n. Okay, now I'm going to apply. If I were to apply De Moivre's theorem, this is going to be 2 raised to the power of 5 times, as I have shown you here, it's going to be cos n times theta. So cos of 5 times of 2 pi times over 3 positive I times sine of 5 times of 2 pi over 3. So this is what we have got. Now this is equal to 2 raised to the power of 5 cos of 5 times 2 pi, that's going to be 10, right? So 10 pi divided by 3 positive I times sine 10 pi divided by 3. Now 3 and pi is 180, so it's going to be 60, and cos 600. Now this can be easily evaluated. 2 raised to the power of 5 is nothing but 32, and this one would give me negative 1 over 2 followed by negative root 3 over 2. You can watch my videos where I have clearly shown how to obtain the value of cos 10 pi over 3 and sin 10 pi over 3. I will put the link and you can use it as a supportive material. So this is going to be, if I were to distribute 32 inside, I would get negative 16 followed by negative I times 16 into root 3. So this is the solution that we have extracted, and we can move on to the next question. So the next question is also evaluate, and you have got negative 1 over 2 positive I times root 3 over 2 raised to the power of 10. Now this is a Cartesian coordinate system. So if you were to look for the point negative 1 over 2, that's going to be, if this point is going to be negative 1, negative 1 over 2 will be in the center, and root 3 over 2, root 3 is 1.732 divided by 2. So if this point is going to be 1, and we are actually looking for a point which is closer to 1, 0.8, right? So this would be the quadrant. So this is quadrant 2 where our theta is present, and we have been given this quantity. So from here I can clearly write x is equal to negative 1 over 2 and y is equal to root of 3 over 2. This is what we have got, and my r, I can extract the value of r from here, which is from formula x squared positive y squared, which is equal to root of 1 over 2 squared positive root of 3 over 2 squared, which is equal to root of 1 over 4 positive root of 3 squared will become 3 divided by 4, which is nothing but root of 1 positive 3 divided by 4, which is going to be 1 unit. R is equal to 1. Now I got the value of R. Now let me get the value of tan theta. Tan theta is equal to this quantity, root 3 over 2 divided by 1 over 2 with a negative sign. This is going to give me negative root of 3. Now as usual, you take the modulus of this and you are getting root 3. So this will mean we are looking at a value, theta is 60 degrees, right? Pi divided by 3. But we are not looking for theta being equal to pi over 3. We want theta to be present in the second quadrant. So over here it's going to be pi negative alpha. So this would mean pi negative pi over 3 is going to be 3 pi minus pi divided by 3, which is equal to 2 pi over 3. So this is the theta that we want, right? So having got this theta, what can we do? We can place it back in the representation, okay? Therefore this means if z is equal to negative 1 over 2 positive I times root of 3 over 2, if this is the complex number, then this is equal to r times of cos theta positive I times sin theta. My r is 1, my theta is 2 pi divided by 3, I can write the same thing, right? 2 pi divided by 3. This is what I've got, but we need to get raised to the power of 10. So this is going to be raised to the power of 10. So therefore z raised to the power of 10 is equal to negative 1 positive I times root of 3 over 2 raised to the power of 10, which is nothing but this entire component raised to the power of 10. By De Moivre's, this is going to be 1 raised to the power of 10 times cos 10 times of 2 pi over 3 positive I times sine. That's going to be, this is going to be 10 times of 2 pi over 3. This is also going to be 10 times of 2 pi over 3. This is what I've got. Now this is rewritten, 2 into 10 gives me 20, right? So 20 pi over 3 with the cos value positive I times sine of 20 pi over 3. The theta will remain the same here also. We don't have to do anything. So this is the polar form. This is actually square root of 2 times I, and we are expected to evaluate this. So what I wish to do is let z be equal to 2 times I. Now this would mean we know that z is of the form x positive iy is equal to 2 times I. So this means x is equal to 0 and y is equal to 2. Okay. Now any complex number can be written in polar form as z is equal to r times of cos theta positive I times sin theta. Right, this is the polar form where r is equal to root of x squared positive y squared. So I'm calculating r, this is 0 squared positive y 2 raised to the power of 2, which is nothing but 2. So my value of r is obtained. So also if I were to get the value for tan theta, my tan theta is going to be equal to y divided by x. Now there is something that we need to look into this part. Now to get the value of theta, we cannot use this for the simple fact that y is 2 and x is 0. So we are basically hitting the wall. But what we can do is we can actually use the definition of polar coordinates. When we started with, we had x to be equal to r times cos theta and y to be equal to r times sin theta. Now we will be using this one. Since r, or I should write it like this, since r is equal to 2, I can rewrite this as x is equal to 2 times cos theta. But x is equal to 0, right? So this would mean 2 times cos theta is equal to 0, which in turn means cos theta is equal to 0, right? Now when is cos theta is equal to 0? When theta is equal to 90 degrees, or when theta is equal to pi over 2, right? Pi over 2 or theta is equal to 90 degrees. So clearly we have obtained the value of theta. So therefore the complex number z is equal to r times 2 times cos of 90 degrees positive I times sine of 90 degrees. So this is what we have got. But this is not what we want. We are asked to find the root of 2 times I. So how are you going to do that? So therefore square root, because z is equal to 2i, z is equal to 2i, so square root of z is nothing but square root of 2i, which is nothing but my z is this, right? So square root of 2 times of cos 90 positive I times of sine 90. So what is this? This is nothing but 2 times cos 90 positive I times sine 90. This 2 is over here and it is raised to the power of 1 over 2. By De Moivre's theorem, this is nothing but 2 raised to the power of 1 over 2 times cos of 1 over 2 times 90 positive I times sine of 1 over 2 times 90, which is nothing but 2 raised to the power of 1 over 2 of cos 45 degrees positive I times sine 45 degrees. So what is cos 45? Cos 45 is 1 over root 2. And what is sine 45? 1 over root 2. So I can take root 2 as the LCM. If I were to take root 2 as the LCM, of course there is a 2 raised to the power 1 over 2, which is nothing but root 2. If I were to take root 2 as the LCM, I will get 1 positive I. Now root 2 gets cancelled. So what do I have? I got 1 positive I. Now what is this? This is nothing but root of 2 times I. And that is the solution for this question. It's a lovely question, students, and this is a good place for us to stop. Thank you.
Welcome everybody. In this class we will be learning about inverse trigonometric functions. So the first and foremost question that we would have to ask and understand is, when can a function have
an inverse? This is a very important question. When can a function have an inverse? The necessary condition, or I should say the necessary and sufficient condition for a function to have an inverse is that the function should be bijective. This is the necessary and sufficient condition. So once you check this condition, and if it is true, then the function is said to have an inverse. So next question comes is, what exactly is the meaning of bijective? So that's exactly what I'm going to define here. So let me write that down. A function is said to be bijective. A function is said to be bijective if it is both injective and surjective. Very important keywords: injective, surjective. Now, what is the meaning of being injective? When is a function said to be injective? This is a question. Answer: a function is said to be injective if it is 1 to 1. So we either write it like this or we write it like this: 1 to 1. So what is the meaning of 1 to 1? Now suppose you have a function, say f of a going on to b. We call this as domain. A is said to be domain and b is called the codomain. Now let me give you this illustration for injective. Now in A, this is set A and this is set B. So you got elements like A, B and C. And in set B, you got elements like D, E, F and G. Now if every element in A has a unique element in B, say A goes to B, A goes to D, B goes to E and C goes to G. It doesn't matter, C goes to F. It doesn't matter if G is left out, right? But the condition is every X element of A should be mapped to a unique element in B. Okay, so this is the meaning of 1 to 1. So that is the important understanding that you should have with regard to the concept of injective. So having given you that injective concept, let's move on. Now let me give an illustration to reinforce the concept of injective. Now let me have a mapping of a function from A to B such that A and B are set of real numbers. And let me ask you this question. Say f of x is equal to 3x squared positive 2. The question is this function injective? Okay, that's the question I wanted to ask. So what are the definition for injective? For every x element of A, there should exist some y element of B such that f of x is equal to that y. So this understanding should be present in the definition. Now, what is the exact meaning of this? It means, suppose you got x1 and x2 element of A. Now, if you are checking for the function to be injective, f of x1 cannot be mapped to y with f of x2 also being mapped to y. This is a clearly no, right? So in this case, what are we trying to show here? We are trying to show here that two elements from A, this is A, x1 and x2, this is B, is mapped to a single element, or I should say to the same element y in B. So this is not injective. The condition fails. So as I mentioned to you, if I were to take this f of x is equal to 3x squared positive 2, is this, I asked you this question, is this function injective? So if I were to take x being equal to positive 2 and x being equal to negative 2, okay, f of x, in this case f of 2 will be 3 of 2 squared positive 2. This is 4, 3, 12 positive 2 gives me 14, and f of negative 2 is 3 of negative 2 squared positive 2, which is also going to be equal to 14. So two elements from A, 2 and minus 2, is being mapped to a single element, the same element 14 in B. So this would mean f of x is equal to 3x squared positive 2 is not injective. So once this condition fails, f of x is not bijective. So what does it mean? This means f of x cannot have an inverse. Cannot have an inverse. So mathematically we can say function, you can state it like this: inverse does not exist for the function. Okay, that's a better way to say inverse does not exist for the function. So the first condition fails, right? So having given you the definition of injective, let us move on to understanding surjective. So let me just reiterate one more time. If you want to check the function for injective, simple concept is it should be 1 to 1. That's it. So you look for this in the function. And having mentioned this, let us understand what is surjective. So when is a function said to be surjective? That's a question. When is a function said to be surjective? Now what is the meaning of surjective? Surjective means onto. So what is the understanding of onto? Let me state it here. If every element present in the codomain is mapped to by at least one element in the domain, then the function is said to be surjective. It's also called as surjection, and we can also call it to be as onto. So example, I got A, I got B, and we have a mapping going on from A to B. Elements in A are A, B, C, D. elements in B are 1, 2, 3, 4. A goes to 1, B goes to 2, 3 and 4. Now every element, this is the codomain. Every element in the codomain is being mapped by at least one element in the domain. Now you have to understand, just because a function is surjective, it doesn't mean it's going to be injective. So that is an important note. Function being surjective does not imply that the function is also, in fact, will be also, you can substitute, injective, right? So don't assume that. So this assumption is dangerous, okay? So make a point of it. And on the contrary, vice versa also is true. So just because the function is injective, it will not automatically qualify to be surjective. So those are important points. Now, to briefly state is, this line of statement would be sufficient. So if you want to check for onto, the codomain should be equal to the range of the function. So you will have to understand one important concept. Say for example, the concept of codomain and range. Now if you have a function, say r going on to r, and you have f of x to be equal to, say, sin x, right? The range of this function lying between -1 less than equal to x less than equal to +1. So this is the range of the function. Now this range and this functional mapping r to r is totally different. So this one is the reach of the function, whereas this one is called the codomain of the function. So the function can take any values in R. So there is a saying in the English language, the sky is the limit. Sky is the limit. The sky is the limit, but every individual has a limit. So what is the limit of an individual? That is what we call it as range. But sky is the limit, right? So you have to have those two things in perspective. So having given you this illustration for surjective, let me concurrently give you an example for a function which isn't surjective. Say for example you got a, b and c, and you got 1, 2, 3, 4. Say you got a going on to 1 and b going on to 2 and c going on to, say, 3. In this case 4 is left out. So this is not surjective. So you cannot leave any element on the codomain. Even one element is left out, the condition fails. Now, having mentioned all of this, let us come to inverse trigonometry functions. So far we have just discussed when a function can have inverse. So there is another word for inverse. We use it as invertible. So once the function is bijective, we call the function to be invertible. So the meaning is the function can have an inverse. Is it necessary that all functions should have an inverse? No. All function cannot, as you have just seen, have an inverse. Two conditions are imperative: surjective and injective. So both these conditions, in fact I should start with injective and surjective. The function has to be 1 to 1 and then on 2. So both these conditions have to be satisfied. So this is injective and this is surjective. Only then the function qualifies to have an inverse. Now how do we find an inverse? Simple. I can show you how exactly to find an inverse. Okay. So before I could go on to show you how to find an inverse, we are so far dealing only algebraically. We have not gone into the trigonometric part. So I will slowly head on to the trigonometric part. As I mentioned to you, I've just asked you a question, is f of x equal to sine x, is it bijective? So I'm asking you, is it 1 to 1 onto? So I will answer the question within a minute. So what I'm going to show you is, I'm going to show you how exactly to find an inverse for this function. F of x is equal to 2x positive 1. Now this is the function that is given. Now if I were to take, if the function is defined from R to R, now clearly just by observation you can see that this function is bijective. So once it's bijective, it will have an inverse. So what I wish to do is, I would like to start off by writing like this: y is equal to 2x positive 1. Then what do you have to do is replace all x by y and vice versa. So if you see an x, you replace it by y. If you see a y, you replace it by x. So in this case, it's going to be x is equal to 2 times y positive 1. Then step 2, you rewrite the equation for y. So in other words, what I'm trying to tell you here is, y should be on the left hand side. So for that, move 1 to the other side, you get 2y. So from here, therefore 2y is equal to x negative 1. This implies y is equal to x negative 1 over 2. So this is the inverse. So this means when you're writing, you write it like this: f inverse of x is equal to x negative 1 over 2. So I've got this. Now how do you check if this is the inverse? F composition f inverse of x should be equal to f inverse composition f of x should give you x. So let's check this out. So we have f of x. This is given. F of x is equal to 2x positive 1. F inverse of x is x negative 1 over 2. So consider f composition f inverse of x is nothing but f of f inverse of x, right? Which is nothing but, you have to substitute f inverse of x into the function. So what is f of x? F of x is this. So 2 times of, in place of x I substitute x negative 1 over 2, right, followed by positive 1. So this is going to be x negative 1 positive 1, which is equal to x. So we got this x, you see that? So also consider f inverse composition f of x. Now what is this is equal to? This is equal to f inverse of f of x, which is nothing but, you'll have to substitute f of x inside x minus 1, so over 2. That is going to be 2x positive 1 negative 1 divided by 2. Positive 1 negative 1 gets cancelled, giving you 2x over 2 is equal to x. So this means f composition f inverse of x is equal to f inverse composition f of x is equal to x. So this means f and f inverse are inverses to each other. You don't have to state it, it's understood, right? So we have proved it that f inverse is indeed the inverse, or you can say that this means f inverse of x is indeed the inverse of f of x. So that is all about the algebraic part of it. So now the question comes is, what would be the situation if the function doesn't have an inverse? If the inverse does not exist for a function. Now there is a technique. That is exactly what we are going to apply for trigonometric functions. So having mentioned this, let us go on to understand the inverse functions from trigonometric point of view. So as I mentioned to you, the very first question is sin x bijective? That's the simple question I'm asking. Is sin x bijective? So make your choices. Is it bijective or is it not a bijective function? Can I say sin x is a bijective function, or can I say inverse exists for sin x? So if you would have made your decision, is it a yes or no, then we can move on in understanding the concepts in trigonometric perspective. So question, let me state it here. Is f of x is equal to sine x, bijective. Now how are we to check for this? Let me draw the graph of sine x. So the graph is like this, it's in waveform. Now there is something called as the horizontal line test. Horizontal line test. So what exactly does it mean? Just draw an horizontal line. Now if this line cuts the curve at exactly at one point, then the function is bijective. Now if you were to see this, if you take this particular point and you're drawing a line, the horizontal line cutting the curve at this point, this point, this point, this point, this point, and this point, and so on. Infinite number of places the line is cutting the curve. But according to the definition, a function is bijective if it has to be, if it is injective and subsequently surjective. But in this case, the test for injection fails. The function isn't injective. You see that you take one particular point and you're drawing a line. That one particular point is cutting the curve at infinitely many points. So the horizontal line test fails. So the conclusion here is, if the horizontal line test fails, that would mean f of x is equal to sine x is not bijective. If a function is not bijective, then inverse doesn't exist. Now, when a function is not having an inverse, but we got an entire topic called as inverse trigonometry function, because if it's going to be failing for sine x, naturally none of the trigonometrical ratios will satisfy, because sine x is the parent, almost like a bulwark in trigonometric identities and trigonometry ratios, because everything starts with sine. And if the test is failing for sine x, then undoubtedly an element of evidence for us to state that the test would not be satisfied by other trigonometric ratios. So that's the entire idea I'm trying to infer here. If that be the state here, then what are we doing with this particular topic? Well, the answer lies in this particular unique concept called as restriction of the domain. See, in this case, there is no restriction, okay? The sine x is heading from point 0, it moves up to the right side. It will also do the same thing on the left hand side. And in this case, say for example, the wave, this is going to be hitting the point at 2 pi and so on and so forth. It is going to be the same. The pattern is going to be repeating infinite number of times, and this line is going to be hitting the curve at infinite many points. So what is the only probability or the only opportunity we got in showing that f of x is equal to sine x as an inverse, or f of x is equal to sine x is bijective, is by the concept of what is called as restriction of the domain. So what am I talking about? So I'm talking here about, let us restrict the domain, okay, to negative pi over 2 to positive pi over 2. That is the secret. So how am I going to do that? Because in this case there is no restriction. But if I were to place a restriction, let me show you that restriction. So the curve, see that? I'm just going to, this point is positive 1, this point is negative 1. The sine x curve hits the point, it's the maximum here at 1. And it's the lowest point at negative 1. So instead of moving up to 2 pi and 4 pi and 6 pi and 8 pi and so on and so forth, I want to put an end. At pi over 2, the function hits 1. So this is the point the function hits. And similarly at negative pi over 2, the function hits negative 1. So this is the point. So let me just draw this. So this is what we are going to do. And what you call such a function, this is sine function, right? But this is called as the principal sine function. So that's a technical term. So what exactly happens in the principal sine function? The domain is restricted between negative pi over 2 to positive pi over 2. So in this case, if you were to draw the horizontal line, if you were to perform the horizontal line test, right? So I take this horizontal line and I hit it. There will be just one point of intersection. This is exactly what we want. No matter where you draw this horizontal line, it will cut the curve at exactly one point. And that is what is required in proving that the function is bijective. So in general, to sum up, f of x is equal to sine x. Okay, let me write that. In general, sine x, let me write it like this, f of x is equal to sine x is not bijective. But with the restriction of domain, principal sine function is bijective. So that is the important part you will have to know. So in this case, I think we can now head on in understanding the inverse trigonometric functions. So that would be a good place for us to stop and wrap up this fundamental discussions about function being invertible. Now the next important concept is, how do we represent these functions? How do we represent the function? Right? So f of x is equal to sine x with restrictive domain. So we are talking about the principal sine function. In this case, f is heading from negative pi over 2 to positive pi over 2, right? And the maximum value is positive 1, minimum value is negative 1. So we always start with the minimum value and place the maximum value. So this is the representation for the principal sine function. Now, having got this, let us give the representation for the inverse function. So f inverse of x, we have already found that is represented as sine inverse of x. Now when I say we have already found that, so in this case we already know that principal sine function as an inverse, and this is how we make the representation. F inverse of x is equal to sine inverse of x. And how do we give the mapping? It is given as follows: f inverse. Now over here, f is actually heading from negative pi over 2 comma pi over 2 to negative 1 comma 1. So for f inverse, it would be the exact reverse. So it will start with negative 1 comma 1 and it will head on to negative pi over 2 to pi over 2. Now one important part, whenever we are talking about inverses, we do not use the term codomain, because for the function, in particular inverse functions, a function can only have an inverse if the codomain is equal to range. So whenever we are talking about the codomain, we mean that the codomain is equal to the range, and only then the function can become onto. So that is an important part or important point you will have to know. So when we are usually referring to inverse functions, we will only talk about domain and range. We will not use this term codomain, because codomain required to be equal to the range. Only then we can clearly say that the function has an inverse. So since we have already shown that, so there is no reason for us to be utilizing or using the term codomain. Right? So from here onwards, we will only be referring to the right side as range. Right? So having made that clear, let us move on. Now let us write down the properties of sine inverse of x. Right? Now foremost, we need to draw the graph of sine inverse of x. Now clearly you can see the sin x graph is actually moving up like this. Now to get the sin inverse x graph, you will have to reflect this onto the line y is equal to x. If you were to do that, you will be able to obtain the sin inverse x graph. So how does the graph look? Now instead of opening down, the graph is going to be opening up, and it will be flowing like this. So this is going to be the sin inverse of x graph. So what would be the domain? So the domain in this case, so let me write that down. The domain for sin inverse of x is going to be from -1 to +1. And next is range. The range is, so this is going to be -1 and this is going to be +1. That's important, right? So the range is going to be -π/2 to π/2. So as I mentioned to you, range is indeed the codomain here. And clearly you can see the graph is continuous. It is continuous. And it is also differentiable. And it is periodic. And it is 1 to 1. And it is onto. So I have listed 1, 2, 3, 4, 5, 6 and 7 points. So this is in connection with sin inverse of x. So you have to remember all of these things. Now the next important question is f inverse of x is equal to sin inverse of x? Is the function symmetric? Answer this. Is it symmetric or not? Now how are you going to find if a function is symmetric or not? Now the simplest way is go to the origin. From the origin you draw a line. You get a point. Now from the same origin, subsequently to the same distance, you draw another line and you get another point. Now if you're able to do this from the origin, you can clearly say the function is symmetric. This implies the function is symmetric about the origin, right? Because from the origin you're moving up, you're getting a point. From the same origin you're moving down, you're getting another point. So if you were able to connect this, clearly you can, with concrete definiteness, you can say that the function is symmetric about the origin. Now subsequently, so let me write that down. Point number 8, the function is symmetric about origin. And point number 9, once the function is symmetric about the origin, the function is called as an odd function. So the requirement for a function to be odd is the function has to be symmetric about the origin. And once it is symmetric about the origin, the function is an odd function. So those are some of the important critical informations that we will have to know with regard to sin inverse of x. Now, since I've given you 9 points, let me also give the 10th one. The question is the function increasing and is the function bounded? Now clearly if you were to be heading from the origin up, if the function is indeed increasing, and you can clearly see the range is actually -π/2, π/2. So the 10th point is the function is increasing and it is bounded. And it is bounded. Okay, so 10 important points we have given for sin inverse of x. Now likewise we can also give these important points for other inverse functions like secant inverse of x, cosecant inverse of x, cos inverse of x, tan inverse of x, cotan inverse of x. Now it becomes necessary that we know all of these graphs. Now foremost, I'm going to teach you a technique by which you can with ease draw all of these inverse trigonometric functions graphs. Now foremost, let us start with cosecant inverse of x. Now what is cosecant x? Cosecant x is the reciprocal of sine x. Now just make the observation for sine x graph. Now the graph is in this fashion. How are we going to draw the cosecant x inverse graph? Now wherever the function ends, the cosecant x inverse starts. So in this case it ends here. So if you were to draw the graph, let me show you over here how to draw this graph. Right. So clearly you can see the sine x graph ends at this point. So wherever it is ending, you start the cosecant x graph from there. So this is ending here. So from here I am starting cosecant x, and you move up like that. That's it. Now it ends here. So from here you move out like that. So what is this? With ease we have got cosecant inverse of x graph with ease, right? Of course these points would be 2 and 4 and so on and so forth, so it will be moving up to plus infinity on the right side, and this is going to be negative 2, negative 4, moving all the way to negative infinity, right? And this point is 0. So on the right side cosecant inverse of x is heading towards positive infinity, on the left side it's heading towards negative infinity. So this is the method for drawing cosecant inverse of x. So let's also see how to draw cos inverse of x and secant inverse of x. Now let's look into the graph of cos inverse. So the graph of cos inverse of x looks in this fashion. So let me draw that. So the graph is going to be heading down. If this point is 1 and this is 2, it will move up and down like this, and this is going to be 1. So this is the graph of cos inverse of x. Now having drawn the graph of cos inverse of x, we will have to draw the graph of y is equal to secant inverse of x. Now how do we draw that? Let me show you that. Now wherever the graph ends for cos inverse of x, secant inverse of x begins. So it is ending over here. So what you do is start from here and move down. Now similarly it is ending over here. This point is 1, right? Now from here you move up. So there is actually an asymptote here. So this is going to be the graph of secant inverse of x, and it looks really beautiful. So we've got the graph for cos inverse of x, secant inverse of x, cosecant inverse of x, sine inverse of x, and all it remains is tan inverse of x and cot tan inverse of x. The last two remaining graphs are y is equal to tan inverse of x. So let me draw this graph. Y is equal to tan inverse of x. The graph will look something of this fashion. And it will actually go down like this. So this point which you see here and this point it doesn't touch here, right? It's an asymptote. This is going to be plus pi over 2 and this This is negative pi over 2. So this is for tan inverse of x. Now let me show you cot inverse of x. How does that look? Now tan inverse of x goes like this. Cot inverse of x will go like the exact opposite side. So let me draw that. So the graph would be hitting the point like that and moving down like this. So we will have to draw the asymptotes. Okay, so this point is going to be pi. Now one important observation is that it doesn't come to the negative side. So this is 4 and this is 5. The graph will never come to the negative end. So that would mean cot inverse of x is always positive. So it's always on the upper half. So that's an observation. But in this case it's not so. It comes down, right? So have that in mind. So having given these graphs, it's time for us to start problem solving. Now the very next important concepts that we have to look in with regard to inverse functions is the concept of domain and range. Now many of the questions are focused on this particular concept, domain and range. So foremost, let me just write down the heading, the function and its domain and its range. So to start off with, the function is y is equal to sine inverse of x, function 1. Its domain is between negative 1 less than equal to x less than equal to 1, and its range is negative pi over 2 less than equal to y less than equal to positive pi over 2. That's the first thing. So next is obviously y is equal to cos inverse of x, and its domain is negative 1 less than equal to x less than equal to 1, and the range is 0 less than equal to y less than equal to pi. So it's a positive function. So when I say positive, it doesn't come down to the other half, the negative end, right? So moving on, y is equal to tan inverse of x. The domain is all x element of real number, and the range is pi over 2 strictly less than y, strictly less than pi over 2. So this negative pi over 2 strictly less than y less than pi over 2. So you can clearly see that from the graph. So all of these concepts which I am just placing here are clearly observant from the very graph which I have just shown you a few minutes ago. So moving on, for y is equal to cot inverse of x. In cot inverse of x, it's all x element of real number, and it is strictly on the positive side. As I mentioned to you from the graph, it doesn't come down at all. So that's the graph for cot inverse, or I should say the range for cot inverse of x. So 5, y is equal to cosecant inverse of x. This is all x less than equal to negative 1 or all x greater than equal to positive 1. This is clearly observant from the graph. And the range is going to be negative pi over 2 less than equal to y less than equal to pi over 2, and y is never equal to 0. Number 6, y is equal to secant inverse of x. This is x less than equal to negative 1 or x greater than equal to 1, and the value is 0 less than equal to y less than equal to pi, and y is never equal to pi over 2. So that's for secant inverse of x. So clearly from the range you can clearly find out if the function is increasing or decreasing. So having given you all this, we will head on. Now when it comes to remembering the range for these functions, it is sufficient that you remember the following groups. So sine inverse of x, tan inverse of x, and cosecant inverse of x, they all are present in one group. So how am I going to remember it? Now sine inverse of x, it's well known fact that the range is between negative pi over 2 and pi over 2, right? Now for tan inverse of x, now this is closed interval, right? For tan inverse of x, the interval becomes open. So this is completely closed, this is open. Now when you come to cosecant inverse of x is nothing but the reciprocal for sine. Cosecant is the reciprocal for sine, right? So cosecant inverse of x will have something similar to the sine inverse of x. So that is the reason that the range is between negative pi over 2 and pi over 2. But apparently y is not equal to 0 here. So have that in mind. So sine inverse of x, tan inverse of x, and cosecant inverse of x, they all fall in one group. And we start with closed interval, and then an open interval, and then again a closed interval, with one exception that y is not equal to 0. Now coming to the cos inverse of x. Now as I mentioned to you, the only other remaining group is cos inverse of x, cot inverse of x, and secant inverse of x. Secant inverse of x is the reciprocal for cos inverse of x. So there will be a similarity. Now cos inverse of x, in this case it starts with negative pi over 2 and pi over 2. But cos inverse of x is between 0 and pi, and it is closed interval. So cot inverse of x is going to be open. You follow me? This is 0 less than equal to y less than equal to pi. This is going to be 0 strictly less than y strictly less than pi. And the secant inverse of x is exactly going to be what you got for cos inverse, with one exception, that y cannot be equal to pi over 2. That is the only exception that is placed in secant inverse of x. So this is a good technique, and you will never forget this if you are going to be using the strategies that I'm just showing you here. You will never forget the range of these inverse trigonometric functions at all. Let's do this question, students. The question is as follows. Let f of x be equal to cos of 2 times tan inverse of sine of cot inverse of square root of 1 negative x divided by x. There is a parenthesis here. And so this is for this, and you got a parenthesis here, and then you got another parenthesis. So this is given, and you're also given that x is lying between 0 and 1. Then the choice are, is it 1 negative x raised to the power of 2 times f dash of x negative 2 times f of x raised to the power of 2 is equal to 0. Which of these equations will be true? That's the requirement for this question. So 1 positive x raised to the power of 2 f dash of x positive 2 times of f of x raised to the power of 2 is equal to 0. And then C is 1 negative x raised to the power of 2 f dash of x positive 2 times f of x raised to the power of 2 is equal to 0. Or D, 1 positive x raised to the power of 2 f dash of x negative 2 times f of x raised to the power of 2 is equal to 0. So which of these equations is said to be true if the function is given in this fashion? So having given you this question, let's move on to the next page and work out the solution. So foremost, let us consider the given question. So let me write that down here. Consider f of x being equal to cos of 2 times tan inverse of sine of cot inverse of root of 1 negative x over x. Right, this is given. So what I wish to do is I would like to now take cot inverse of root of 1 negative x over x to be equal to some theta. So this would mean cot theta is equal to root of 1 negative x divided by root of x. So if I were to use the trigonometric laws, this is my theta, this is cot theta. Cot theta is adjacent over opposite. So this is going to be root of 1 negative x and this is going to be root of x. Right, now if you want to get the hypotenuse, you can very well do that. So hypotenuse is equal to, if I were to take this as a, b and c, ab squared positive bc squared is ac squared. You square it, you get 1 negative x. You square it, you get x, and this is ac squared, so therefore ac is equal to 1. So this is going to be 1. Now if you were to find sine theta is equal to root of x divided by 1, which is nothing but root of x. So this is my sine theta. Now you might be wondering, why did I take sine theta? Now if you were to take this as 1, therefore 1 can be rewritten as f of x is equal to cos of 2 times tan inverse of sine of, now cot inverse of this entire quantity is taken to be as sine theta. So this is my, right, it's taken as theta. So this is going to be producing theta. So this is sine theta, and I've got a parenthesis. You don't have to place parenthesis, just for the sake of some level of identification. So this is equal to cos of 2 times of tan inverse of, now what is sine theta? Sine theta is going to be root x. So this is root x. So now what I've got cos of 2 times of tan inverse of root x. Right, this is my f of x. So now what I'm going to do is I want to take, let tan inverse of root x be equal to some phi. So this would mean tan phi is equal to root x. Right, so if I were to substitute this, this is going to be equal to cot 2 times of tan inverse of root x is equal to phi. So this is going to be phi. So I have f of x to be equal to cos 2 phi. Now if I were to rewrite this in terms of tan, this is going to be 1 negative, we know we have already seen this formula, 1 negative tan squared phi divided by 1 positive tan squared phi. But what is tan phi? Tan phi is nothing but root x. So 1 negative root x raised to the power of 2 divided by 1 positive root x raised to the power of 2, which is nothing but 1 negative x divided by 1 positive x, which is my f of x. So therefore f of x is equal to 1 negative x divided by 1 positive x. This is my f of x. Now I need to find out f dash of x. Why? Because the choice involves f dash of x. So f dash of x is equal to u over v differentiation. So 1 positive x times the differential of 1 negative x is negative 1. Negative 1 negative x times differential of 1 positive x is 1. divided by 1 positive x raised to the power of 2. This is going to be negative 1 negative x negative 1 positive x divided by 1 positive x raised to the power of 2. Positive x, negative x gets cancelled, giving me negative 2 over 1 positive x raised to the power of 2. So this is my f dash of x. Now what I wish to do is, I will have to get a f of x square, because in the output, in the choices, every quantity has got an f of x. But f of x, what is f of x? F of x is 1 negative x divided by 1 positive x. But as I mentioned to you, all of the choices have got f of x raised to the power of 2. So what I would like to do, I would like to rewrite this as negative 2 divided by 1 positive x, right? So there is already a square there, so I don't have to do anything for the denominator, but I will have to bring this term here. So I'm multiplying it by 1 negative x raised to the power of 2. If I were to do that, subsequently I will have to multiply the left hand side by 1 negative x raised to the power of 2, right? So rewriting, if I were to rewrite this, this is going to be equal to negative 2 times, I can write this as 1 negative x divided by 1 positive x raised to the power of 2. But what is this? This is nothing but f of x. So this is equal to negative 2 times f of x raised to the power of 2. And on the left side I get 1 negative x raised to the power of 2 into f dash of x. Now I move this to the left hand side, I get 1 negative x raised to the power of 2 times f dash of x positive 2 times f of x raised to the power of 2 is equal to 0. So this is what I've got. Now you have to go and check back the choices. So let me show you this choice. So before I could flip the page and move to the previous page, just make sure that this is written at the corner of your mind. 1 negative x raised to the power of 2 f dash of x positive 2 times f of x raised to the power of 2 is equal to 0. So this is the choice we are looking for. So now clearly you can see that 1 negative x raised to the power of 2 times f dash of x positive 2 times f of x raised to the power of 2. This is the only thing that is available, which corresponds to our required output that we just received. So C is the answer. A cannot be the answer because it's negative here. But this is our solution. So having got that, we'll move on to the next question. The question is a possible value of tan of 1 over 4 sine inverse of root of 63 over 8 is, this is what is asked. Right now you've been given list of choices. One is 1 over 2 times root 2, 1 over root 7, root 7 negative 1, and 2 times root 2 negative 1. So these are the choices that have been given. So how are we going to do this question? So foremost, let me just take sine inverse of root of 63 over 8 to be equal to theta. So this would mean my sine theta is root of 63 divided by 8. So if I were to draw the right triangle, this is theta, opposite side is 63 with the square root, hypotenuse is 8. If I were to take this as ABC, AB squared positive BC squared is AC squared. AB squared I don't know. BC squared is 63, AC squared is 64. So AB squared is 64 negative 63, which is 1. So AB is equal to 1. So this is 1 unit. So sine theta is 1 unit. So therefore, let me write down cos. Cos theta is going to be 1 over 8. This is a beautiful value. So if I were to take this as 1, therefore I can rewrite 1 as tan of 1 over 4. Now sine inverse of this quantity, that's going to be equal to theta. So this is going to be 1 over 4 theta. So we are actually trying to get tan of theta over 4. A very unique result that is required for this question. Now what I wish to do is I would like to connect a formula. What is the formula? Square root of 1 negative cos x divided by 1 positive cos x. What is this equal to? This is equal to root of 2 times sine squared x over 2 divided by root of cos squared x over 2, which is nothing but sin x over 2 divided by cos x over 2, which is nothing but tan x over 2. So this is the formula we have. Tan x over 2 is root of 1 negative cos x divided by 1 positive cos x. Right? But we wanted tan theta over 4. So clearly if you were to compare this with this, over here you got x over 2, over here we got x, so that means the angle gets doubled. So therefore I wish to write tan theta over 4 to be equal to root of 1 negative cos theta over 2 divided by 1 positive cos theta over 2, right? Now we got cos theta is equal to 1 over 8, so we will have to extract cos theta over 2. So let me give you this formula. Now we know that I'm using the variable t because I don't want to use theta. Now cos 2 theta is nothing but 2 times cos square theta negative 1, right? Now if I were to take 2 theta to be equal to 2t to be equal to theta, then this is going to be cos of theta is equal to 2 times cos square t is going to be theta over 2 negative 1, right? So I've got a beautiful formula which I can use. So that is exactly what I'm going to do. So from here I'm going to use the space here. So from here I got cos theta positive 1 is equal to 2 times cos squared theta over 2, which would mean cos theta positive 1 divided by 2 is equal to cos squared theta over 2. I need only cos theta over 2, so therefore cos theta over 2 is equal to root of cos theta positive 1 divided by 2. But I know cos theta. Cos theta is 1 over 8. So I substitute that value. So this is equal to root of 1 over 8 positive 1 divided by 2. So which is equal to 8 added with 1, that's going to be 9 over 8 multiplied with 2, right? When you flip it, you're going to get 1 over 2, that's going to be 16. So this is the root value for this, which is nothing but 3 over 4. So this is my cos theta over 2. So take this value and substitute it here. So this is equal to root of 1 negative 3 over 4 divided by 1 positive 3 over 4. This is equal to root of 4 negative 3, that's 1 over 4 divided by 4 with 3, that's going to be 7 over 4. So you flip this, this is equal to 1 over 4 times 4 over 7, which is going to be root of 1 over 7, right? 4 gets cancelled, 1 over 7, which I can rewrite it as 1 over root 7. So what is this value? This value is nothing but tan of 1 over 4 of sine inverse of root of 63 divided by 8, right? So this is 1 over root 7. So let's go to the choice. So if you were to go to the choice, you will clearly see that B is the right answer. So let me take that. So that is the solution for this question, students. It's a lovely question. We will move on to the next one. Question is given as follows. If 0 less than x less than 1, then root of 1 positive x squared of x times cos of cot inverse of x positive sine of cot inverse of x. This entire thing is raised to the power of 2 followed by negative 1, and that is raised to the power of 1 over 2 is equal to what? This is required, right? Now there are a list of choices, so probably I will place in those choices. So choice number 1, is it x over root of 1 positive x squared? Choice 2, is it x? 3, is it x times root of 1 positive x squared? Choice D, is it root of 1 positive x squared? So you got 4 choices. So let's get the solution. So foremost, if you can see this question, the question asks cot inverse of x, right? So solution, I'm going to start it in this fashion. Let cot inverse of x be equal to theta. So this would mean cot theta is equal to x. I'm going to write it as x over 1. So if I were to draw the right triangle, cot theta is adjacent over opposite. So this is going to be x and 1. Of course this is theta. If I were to take this as a, b and c, I want to find AC. So AB squared positive BC squared is equal to AC squared. AB squared is x squared, BC squared is 1. So therefore AC is equal to root of 1 positive x squared. So this is going to be root of 1 positive x squared. So we got that. So having got that, if I were to take this as 1, so I can rewrite 1 can be rewritten as root of 1 positive x squared times x times cot inverse of x is taken as theta. This is theta there, positive, right, sine of cot inverse of x is theta, and this is raised to the power of 2 followed by negative 1, and that in turn is raised to the power of 1 over 2. So this is what we've got. So now from here I can get cos theta. Now what is cos theta here? From here, cos theta is equal to x over root of 1 positive x squared, that is cos, and what is sine? Sine theta is equal to 1 over root of 1 positive x squared. So if we were to replace that in the given function or in the given expression, that would give me root of 1 positive x squared of x times, now cos is x over root of 1 positive x squared, positive, sine is 1 over root of 1 positive x squared, right, and this is raised to the power of 2 followed by a negative 1, that is raised to the power of 1 over 2. This is equal to root of 1 positive x squared. Now if I were to take the LCM as root of 1 positive x squared, and that would give me x squared positive 1, right, this is raised to the power of 2 followed by a negative 1, and this is raised to the power of half. So this is actually x squared positive 1 divided by root of 1 positive x squared. So can I not write this as root of 1 positive x squared This is raised to the power of 2 followed by a negative 1 raised to the power of 1 over 2. Can I not do that? Now square root and square, they both get cancelled, giving me root of 1 positive x squared. This is going to be 1 positive x squared negative 1, and that is raised to the power of 1 over 2, right? Positive 1 and negative 1 can be cancelled, and that is going to give me x squared raised to the power of 1 over 2. What is that? Square root of x squared will give me x. So the solution is going to be x times root of 1 positive x squared, and we have to look for this value. So where is it? Clearly our focus goes on to this choice, right? X times root of 1 positive x squared. So this is the correct choice for this question. So that is the end of the solution, students. We will move on to the next one. Welcome, students. In this particular chapter we will deal with questions that are connected to domain and range. So we got the first question: find the domain of f of x such that f of x is given to be equal to sine inverse of x negative 3 divided by 2 followed by a negative sign log of 4 negative x to the base 10. Now we know that this is the solution. We know that the domain for f of x equal to sine inverse of x is lying between negative 1 less than equal to x less than equal to 1, and the domain for log is actually greater than 0, right? It's only positive values that can be affected by log. So knowing these two information, let us now place in the given quantity. So from the question we know that x negative 3 over 2 is less than equal to negative 1, and on this side it's greater than equal to negative 1 and less than equal to positive 1. So this is the region, right? Now what I wish to do is I would like to get rid of this 2. So I would multiply by 2. This would give me negative 2 less than equal to x negative 3 less than equal to 2. Now I would like to get rid of this negative 3, so I add positive 3, positive 3, positive 3. So that in turn would give me negative 2 added with positive 3 is going to be positive 1 less than equal to x less than equal to 5, right? So this is obtained. Now let us head to log. As I mentioned to you, this is only possible if 4 negative x is greater than 0. Now if I were to move x to the other side, I would get 4 is greater than x. In other words, I can also rewrite this as x is less than 4. Now you got two regions. Let me just draw the number line. This is 0, 1, 2, 3, 4, 5, and for the first set, for this x, this is going to be the region, right? But we will have to take the composition of this with this. Now x less than 4. X less than 4 is all values that are lying below 4. So this would be the point. So from here to there, right? But the only point that we have to note here is this is an open interval. So therefore when we are writing, therefore the solution is closed interval 1 comma open interval 4. Now there were 4 choices given for this question. choice 1 is it between 1 comma 5. So they're asking us to find the domain, right? Find the domain. So they have given it as an MCQ. And choice 2 is 1 comma 4, with the other end being open. And the other one is 1 comma 4. The final one is 1 comma 4. Right? This is open interval. So clearly we can easily see that choice B is the right solution. Right? So we will move on to the next question. And let's see the question. So we are expected to find the domain of the function cosecant inverse of 1 positive x divided by x. So we have been given the following choices. So A, negative 1 comma 1 over 2, of course there's a negative sign there, union 0 comma infinity, choice A. Choice B, negative 1 over 2 comma 0 union 1 comma infinity, and choice C, negative 1 comma 2 comma infinity negative 0, and choice D is negative 1 over 2 comma infinity negative 0. Right? Now we have to make the following observation for the solution. Now if f of x is equal to cosecant inverse of x, then the domain is given to be as all x less than equal to negative 1 or all x greater than equal to positive 1. So either this or this. So we are being given cosecant inverse of 1 positive x divided by x. Okay, now consider f of x is equal to cosecant inverse of 1 positive x over x. So this would mean 1 positive x over x is less than equal to negative 1 or 1 positive x over x is greater than equal to 1. Right? So from here, if I were to move this negative 1 to the other side, I would get 1 positive x over x, positive 1 less than equal to 0. And this would be, if I were to take x to be the LCM, I would get 1 positive 2x less than equal to 0. Right? On the other side, this is going to be, and I want to move this 1 to the other side. This is going to be 1 positive x over x negative 1 greater than equal to 0. If I were to take the LCM, I would get 1 positive x negative x divided by x greater than equal to 0. Positive x negative x gets cancelled, giving me 1 over x greater than equal to 0, which means x is strictly greater than 0. Over here, now clearly you can see that the points where this quantity will be less than equal to 0 would be from negative 1 over 2, and x cannot take the value 0. This point is 0, x cannot. So this is closed and this is open. So only in this particular segment this inequality will hold good. Right? So this is found out. And this is also found out. X is strictly greater than 0 means we have collection of all points between 0 comma infinity. Both of them are open. So we will have to unite these two intervals. So this is actually negative 1 over 2 comma 0. This is open, this is closed. So therefore the solution is going to be closed negative 1 over 2 comma 0 union 0 comma infinity. So let us check it out. Which of these choices, if you have to check this out, minus 1 over 2 comma 0, 0 is not included, 0 is not included, and we go all the way up onto infinity. So of all these choices, D is the right choice. Minus 1 over 2 closed to infinity and 0 is taken out, right? So this is the right solution. Students, now we will talk about decreasing functions. Now in inverse trigonometric functions, there are three main decreasing functions which we can focus on. Foremost, cos inverse of x. Number 2, cot inverse of x. Number 3, cosecant inverse of x. So cos inverse of x, cot inverse of x, cosecant inverse of x. Now, whenever you are multiplying an inequality with one of these, the inequality will get reversed. Say for example, you got 3 is greater than 2, and that you are multiplying this inequality by cot inverse of x. Say for example, you are applying cot inverse. So this is going to be cot inverse of 3. I'm not placing the inequality. Let me just place cot inverse of 2 on the other end. So now we started with this 3 greater than 2. Now when we reach for this, the inequality will get reversed. So instead of saying 3 greater than 2, now it's going to be cot inverse of 3 lesser than cot inverse of 2. Now if you were to find the value of cot inverse, this is going to be 0.322, and cot inverse of 2 is going to be 0.464. You can clearly see that our concept of reversing the inequality is holding good here, holds good, because cot inverse of 3 is 0.322 and cot inverse of 2 is 0.464, right? So that's exactly what we've been talking about. So have that in mind. Now if in case you are removing the decreasing function, so this is when you add. When I say add, it means the product, right? So it also includes, in case of systems of equations, if you are adding a decreasing function, that is also taken into consideration. So this is when you add a decreasing function, right? So this exactly happens. On the other end, if you remove the decreasing function, if you remove, say for example, you are removing cot inverse from this inequality. So what happens? It means this inequality has to be reversed. So 3 is greater than 2. You follow me? When you bring the decreasing function, the direction of the inequality changes. Similarly, when you remove the decreasing function, again the direction of the inequality changes. So this is a beautiful concept and it is worth taking note of. So next is we will be dealing with problems connected with decreasing functions. Let's do this question, students. We are expected to find the domain of the function f of x is equal to square root of 3 times cos inverse of 4x negative pi. Now there are two parts in this inequality. Now the first part is this entire quantity should be greater than or equal to 0, right? So that's exactly what I'm going to do. So 3 times of cos inverse of 4x negative pi should be greater than or equal to 0 for the function to exist. Now the second part, this is part 2, is this value x. Now we know that if f of x is equal to cos inverse of x, then the domain is lying between -1 and +1 for cos inverse of x. But instead of x, I've got 4x. So in this case, it's going to be -1 less than or equal to 4x less than or equal to +1. This is what we've got. Now let me handle this first. So if I were to divide by 4, this is going to be -1 over 4 less than or equal to x less than or equal to 1 over 4. So this is already completed. Now let me head to the part 1. Now what I wish to do is I would like to move this pi to the other side. So it's going to be 3 times of cos inverse of 4x greater than equal to pi. Now this 3 can be brought down, so there's going to be cos inverse of 4x greater than equal to pi over 3. Now I need to evaluate this pi over 3. So what I wish to do is I would like to multiply by cos on both sides. So this is going to be cos. Now I already mentioned to you, when you perform this, the inequality has to be flipped, right? So the new inequality is going to be cos inverse of 4x. This inequality gets reversed, so it's going to be less than equal to cos of pi over 3, right? Now this is 60. Cos 60 is less than equal to 1 over 2. Cos and cos inverse gets cancelled, giving me 4x. So x is less than equal to 1 over 8. So this is the solution, for this inequality, right? Now what we have to do is we have to club these two together. So the solution is going to be x less than equal to 1 over 8. In this case it's going to be between negative 1 over 4 and 1 over 4. So we will have to stretch all the way to 1 over 8. So closed interval negative 1 over 4, that's the smallest value, and then it goes all the way up unto 1 over 8. So this is the solution for this particular question. Now what happens is they have given us choices. So choice number A, let me write down those choices. Choice A is negative 1 over 4, 1 over 8. Choice B is 1 over 8, 1. Choice C is 1 over 8, 1 over 4. And choice D is negative 1, 1 over 8. Right, so clearly we can see that negative 1 over 4, 1 over 8, choice A is the right answer for this question. Students, we have been given another beautiful question. The question is as follows. We are expected to find all x satisfying the inequality cot inverse of x raised to the power of 2 followed by negative 7 cot inverse of x positive 10 greater than 10, it's greater than 0. Okay, so we are being given a list of choices, and the question continues. Lie in the interval. So we have following choices. A is negative infinity, cot 5 union cot 4 comma cot 2. B is cot 2 comma infinity, and C is infinity comma cot 5 union cot 2 comma infinity, and D is cot 5 comma cot 4, right? Now clearly you can see from the choices you cannot pick up a choice or pick out a choice by guesswork. That is not going to be working out. We need to really solve it. So foremost, let me just give you the solution, how exactly to get this. Now consider cot inverse of x raised to the power of 2 negative 7 times cot inverse of x positive 10 greater than 0. I'm going to take, let t be equal to cot inverse of x. So substituting this, if you were to take this as 1, therefore 1 can be rewritten as t squared negative 7 times t positive 10. This is greater than 0. Now this is a quadratic in t, and it can be factored as t negative 5 times t negative 2 greater than 0. So from here I can write, there are two values possible, right? So 2 and 5. So either t is less than 2 or t is greater than 5. But t is cot inverse of x, right? So that would mean I got cot inverse of x less than 2 or cot inverse of x greater than 5. Now if you were to see the graph of cot inverse of x, you will realize that the graph is actually contained with pi being the bound. So let me just show you the graph. So this is pi. It starts from 0, goes up to pi. If I were to draw the graph is going to be like this. Okay, and the value of pi is approximately 3.14. But over here it says cot inverse of x is greater than 5. So this is actually not possible. Not possible. And so we have to reject this value. So just drop this. Right? This is dropped. So we are left with cot inverse of x less than 2. Right? If I were to move cot inverse to the other side, I would get x is, in fact, if I were to apply cot on both sides, I have clearly mentioned to you that we are dealing with a decreasing function, right? So the inequality will get reversed. So this is going to be cot of cot inverse of x, and this is going to be cot 2. So the inequality will get reversed like this, and cot inverse will get neutralized, giving me x greater than cot 2. So all values of x that is greater than cot 2. So the solution for this is going to be cot 2 comma infinity. So this is going to be the solution. Right, so let's go back to the choices and see which of these is matching. Clearly you can see B, cot 2 comma infinity. So this is the right choice for this particular question. We got a beautiful question, and the question is as follows. If alpha is equal to 3 times sine inverse of 6 over 11 and beta is equal to 3 times cos inverse of 4 over 9, where the inverse trigonometric functions take only the principal values, right? We have already studied about principal values. Then the correct choices are, so the question can be the correct choices, or what I would want to say is it can either be a singular tone or a plural tone, right? So depending upon what the choices are. In other words, a question might have 3 solutions or 4 solutions or 5 solutions, right? So we should not restrict our thought process to just locating one solution. So that is exactly what the question wants. The question wants you to find out all possible solutions. So I am just placing here correct choices are. So it can even exist just one solution. So in that case, then the correct choice is, right? So you can rephrase it as you wish depending upon the availability. So I would like to suggest that you keep your mind broad and expect different probabilities of results. So having mentioned that, we got the choice. A, is it cos beta greater than 0? B, is it sin beta less than 0? C, is it cos of alpha positive beta greater than 0? D, is it cos alpha less than 0? So we have 4 choices. Now among these 4 choices, you might find only one choice that is suitable for this question, or 2 choices suitable for this question, or 3, or even all the 4. So that is exactly what I wish to say. Now we have been given alpha is equal to 3 times sine inverse of 6 over 11. Now you got 6 divided by 11, but I have no clue what is 6 over 11. Sine inverse of 6 over 11, I am totally not aware of a value like 6 over 11, a standard value. Of course, we can always adopt the use of calculator and extract the value of sine inverse of 6 over 11. But as of now, out of my mind, I wouldn't be able to tell the value of sine inverse of 6 over 11. So in that case, what I wish to do is I would like to make a comparison. Now clearly 6 over 11 is greater than 6 over 12, right? This we know. So this is one type of technique in mathematics. Whenever you are given certain challenging questions, you can always associate the question to a known question whose solutions are well aware to your knowledge, and then boil the solution down to the requirement. So that is exactly what I'm doing. I'm just taking 6 over 11 and I'm comparing it with 6 over 12. Of course, I know what a 6 over 12 is. So I am taking sine inverse on both sides. So this is going to be sine inverse of 6 over 11. This is going to be greater than sine inverse of 6 over 12, right? Now sine inverse of 6 over 12 is nothing but sine inverse of 1 over 2. This is a standard value, we all know. Now this is as such 6 over 11. So this is the next step. Now I need to have a 3 here. You can clearly see there is a 3 that's been multiplied. So let us multiply 3 on the left side. 3 times sine inverse of 6 over 11. And this is greater than 3 times sine inverse of 1 over 2. So that's fine. Now this is given to be as alpha. If you were to check the question, it says alpha is equal to. So let me just take alpha. It's given. So alpha is greater than. Now 3 times sine inverse of 1 over 2. That's nothing but 60 degrees. 30 degrees, not 60. Sine 30 is 1 over 2, right? So that would mean the value of this quantity, angle, is going to be pi over 6, right? Sine pi over 6 is going to be 1 over 2. So this is well known. So I would like to take that and place it here. So 3 times of sine inverse of 1 over 2 is pi divided by 6. So this implies alpha is greater than 3 divided 6 2 times. So pi over 2. Now when you see something like this, alpha is greater than pi over 2, the understanding that we should draw here is to first draw the quadrants. So this is 0, this is 90, this is 180, this is 270, and this is 360. Now 90 is over here. Alpha is greater than pi over 2 means it should only be in the second quadrant. So whenever we talk about a quantity greater than an angle, you have to always understand that it would be slightly larger, right? It won't be so large that it will skip to the next quadrant. From quadrant 2, it won't go to quadrant 3. It will be slightly larger. So in this case, alpha is greater than 90 degree means it would be present in quadrant 2. That is the understanding we should draw. Now in quadrant 2, if we were to represent this by CAST, only sine is positive. So having mentioned that sine is positive, so that would mean cosine is negative, right? So if I were to take cos of alpha would be less than 0. So let us go to the choices and examine it. So if you were to see here, this is beta, we don't need this. Alpha plus beta, we are still yet to find beta. So this is out of the question. Now you got cos alpha is less than 0. This is exactly what I was just mentioning you. Cos alpha less than 0. So cos is negative. So this is a exact right choice. We shouldn't say use the word exact. This is a correct choice for now. Now let us go up and obtain the value for beta. Now what is beta? Beta says 4/9. So I can very well do that working over here. So clearly, as I mentioned to you in the earlier case, just associate 4/9 to a value that you already know. Clearly I know 4/9 is less than 4/8. 4/8 is nothing but 1/2. Now this has got cos. So I'm attacking by cos. Now cos is a decreasing function. So whenever you are taking cos inverse of a value, the inequality gets reversed. You should understand cos inverse is a decreasing function, whereas we not reverse the inequality for sine. The reason being sine inverse is an increasing function. So since cos inverse is a decreasing function, the inequality will get reversed and we can write it like this. Cos inverse of 4/8 is nothing but 1/2. So that's fine. Now I wish to multiply by 3 both sides. So there's going to be 3 times cos inverse of 4/9. This is greater than 3 times cos inverse of 1/2. This is what we have got. So now what I wish to do is I would like to replace 3 times cos inverse of 4/9 by this quantity beta, right? That's the exact representation that is being given in the question. So let us use the data from the question. So we now have beta is greater than 3 times. Now cos inverse of 1/2, that's going to be cos 60, right? We know that cos 60 degree is equal to 1/2. Now how do I represent cos 60 degree? Cos 60 degree is nothing but pi/3, right? Cos pi/3 is 1/2. So this is going to be pi/3, right? So what happens here? 3 and 3 can be cancelled. So beta is greater than pi. No, beta is greater than pi. Let's go to the quadrant representation. So this is 180 degree. So this would fall in third quadrant. Beta greater than pi. So only tan is positive. So let's go back to the choices. Surely this cannot happen, right? They are saying cos beta is greater than 0. This is not possible. Sin beta is less than 0. Yes, sin is negative here. That's fine. So I've got B, I've got D. Now we need to check for alpha plus beta. Now this is the check for alpha plus beta. So what is alpha? Alpha is actually greater than pi/2. So let me just write that down. Alpha positive beta. Therefore alpha plus positive beta is greater than pi/2. Positive beta is greater than pi. So place that. So what is this? This is equal to 2 pi plus pi. So this is going to be 3 pi/2. So this would mean alpha positive beta is greater than 3 pi/2. Now what is 3 pi/2? That's nothing but 270 degrees. So alpha positive beta is 270 degree, means it will skip or it will just move to the fourth quadrant. In fourth quadrant, cosine is positive and its reciprocal is positive, right? Cos is positive along with its reciprocals. So let us go and check over here. So clearly you see this is exactly what they have given. Cos of alpha positive beta is greater than 0. So this is perfectly correct. So as I mentioned to you, you should have ticked if you were to encounter a question of this fashion in your examination, either in competitive examinations or examination for some scholarships or for some master's degree program, you should have selected B, C, D as the right choice. It doesn't matter if you were to select the C and then leave B and D off. You wouldn't get the score. So you have to select B, C, D. So this is the right choice. B, C, D. Right? So have that in mind. So having mentioned that, let us move on to the next question. Students, we are given another beautiful question. The question is as follows. If cos inverse of x added with cos inverse of y added with cos inverse of z is equal to 3 pi, then we are expected to find the value of x raised to the power of 2024 positive y raised to the power of 2024 positive z raised to the power of 2024 positive 6 divided by x raised to the power of 2023 positive y raised to the power of 2023 positive z raised to the power of 2023. So we have the following choices being given. Choice A is 0, B is 1, C is -1, and D is 2. So these are the choices we have been given. Now let us consider the question. Consider cos inverse of x positive, cos inverse of y positive, cos inverse of z is equal to 3 times 5. Now I would like to ask you, when is this possible? Left hand side should be equal to right hand side. When can this occur? Now clearly you can see that this is only possible if cos inverse of x becomes equal to pi, along with cos inverse of y becomes equal to pi, along with cos inverse of z being equal to pi. This is the only possibility that is available for us to make the left hand side equal to right hand side. There is no other way that left hand side would be equal to right hand side apart from these values that cos inverse of the value x, y and z can take. So having mentioned that, so I have made this point clear to you. So if cos inverse of x is equal to pi, then clearly I can write here as x is equal to cos pi, right? And also over here I can write y is equal to cos pi and z is equal to cos pi. But what is cos pi? Cos pi is -1. So you got x is equal to -1, y is equal to -1 and z is equal to -1. So I've got the value for x, value for y and value for z. Now let me take this as 2. So therefore 2 can be rewritten as x raised to the power of 2024. So -1 raised to the power of 2024. Why? Because x is found to be equal to -1, followed by -1 raised to the power of 2024, because y is raised to the power of 2024, followed by -1 raised to the power of 2024 positive 6 divided by -1 raised to the power of 2023 positive -1 raised to the power of 2023 positive -1 raised to the power of 2023. Now this is what? Odd quantity, odd number raised to the power of an even quantity, right? You got -1 raised to the power of 2. What are you going to get? You're going to get a +1, right? That is exactly what you have to place here. So this is going to be equal to +1, +1, +1, +6 divided by, this is a negative value, a negative quantity raised to the power of odd power. So you got -1 raised to the power of 3. What do you get? You get -1. So that's exactly what you need to place here. So -1 followed by addition of -1 followed by addition of -1. So what is this equal to? 1 added with 1 added with 1 would give you 3, followed by +6 divided by -1 added with -1 followed by -1 gives you -3. 3 divides 6 2 times, so this is negative sign, so this is equal to -3 followed by a -2. So what is this? 3 -2 will give you 1. So this is the solution, and let's go to the choices. Now clearly you can see the right choice is already there waiting for us to be selected. So that's the end of the solution, students. So this is a nice problem, and we'll move on to the next question. Students, we have another beautiful question. The question is as follows: find the number of real roots for the equation tan inverse of square root of x times x positive 1 positive sine inverse of root of x squared positive x positive 1 is equal to pi over 4. Now we have been given choices. A, is it 1? B, is it 2? C, is it 4? D, is it 0? Now foremost, to get the solution, we must know where the function is defined. Right? In other words, we are looking for the domain of the function. Now clearly, tan inverse of root of x times x positive 1 is defined for all values for which x times x positive 1 is greater than or equal to 0. So this is necessary. If x times x positive 1 is greater than or equal to 0, then only tan inverse of square root of this quantity is going to be existing, right? Because it cannot fall short of 0. That's the smallest value that is allowed so that this function is existing. So this is one side. We got the other side. Now we know that the domain for sin x lies between -1 and +1, right? But in this case, we are looking at root of x squared positive x positive 1. So that would mean if I were to place -1 less than or equal to root of x squared positive x positive 1 less than or equal to 1, there is a small adjustment we need to do, because clearly -1 cannot be an outcome for this. So the minimum value that root of x squared positive x positive 1 will produce will be 0. So we will have to rewrite this as 0 greater than or equal to square root of x squared positive x positive 1 less than or equal to 1. So this is what is the permitted domain for this quantity, sin inverse of root of x squared positive x positive 1. So we got two sides, right? So now what I would do is I would try to simplify and extract the value for x here. Now if I were to take root of x squared positive x positive 1 is less than or equal to 1 and square both sides, I would arrive at an inequality of this fashion. Now clearly I can get rid of this 1 on either side, and this would give me x squared positive x less than or equal to 0, right? So this is almost done. So let us move on to the other inequality. Now distributing x would give us x squared positive x greater than or equal to 0. So this is what I've got for this side. Now I've got an inequality here and I've got an inequality here. Now these two inequalities together have to be satisfied for this entire function to exist. So when would that be possible? On one side we got x squared positive x is greater than or equal to 0. On the other side we got x squared positive x is less than or equal to 0. Now to satisfy these two inequality would mean that there is exactly one particular point for which x squared positive x will be greater than or equal to 0 and x squared positive x will be less than or equal to 0, and that point would be x squared positive x equal to 0. Only at this particular point this inequality and this inequality will hold good. So having got that, let me just write it as x of x positive 1 is equal to 0. Clearly from here I write x is equal to 0, and then from here I write x is equal to -1. So those two values are obtained. Now what we need to do, we need to take this value and substitute it in this left side of this entire equation and find out if left hand side is equal to right hand side. So that is what we need to do. So let us just take x is equal to 0. Let me use this side of this space. X is equal to 0 and I substitute it here. 0, 0, positive 1. So this is going to be 0. So tan inverse of 0 is going to give me 0. And 0, 0 and sine inverse of root 1, that is going to be sine inverse of 1. Let me write that down, sine inverse of 1. And that should be equal to pi over 4. Now sine inverse of 1 is what? It's pi over 2. So we have something like this, pi over 2 being equal to pi over 4. Is it possible? No, it's not possible. Right? Pi over 2 cannot be equal to pi over 4. Not possible. Right? We cannot even dream of such a situation. Right? That is the best way to state. So x is equal to 0 has to be dropped. It doesn't serve our purpose. Now let me take x is equal to negative 1. So this is the case 1. So probably case 2. Let me just go to case 2. X is equal to negative 1. So if we were to substitute x is equal to negative 1, this is going to become 0. So tan inverse of 0 will be 0. X is equal to negative 1, positive 1, they get cancelled. Negative 1. Again I am getting sine inverse of 1, which has to be equal to pi over 4. Sine inverse of 1 produces pi over 2. Again I need to have a justifiable statement here, because this is basically giving us a contradiction, pi over 2 being equal to pi over 4. So again this is not possible, and so x is equal to negative 1 should also be dropped. So what is the understanding? We are unable to find values of x such that the left hand side is equal to right hand side. So that would mean we are not able to find any real root at all. So ultimately the choice of selection should be D. So this is a beautiful question, students. I hope you enjoyed it. Let's move on to the next one. Students, now it's time for us to understand the properties of inverse trigonometric functions. Okay, so let's get it started. First one, sine inverse of negative x is going to be equal to negative sine inverse of x. That's the first one. Now the second one is tan inverse of negative x is equal to negative tan inverse of x. And the third one, let me write this down here. Cosecant inverse of negative x is equal to negative cosecant inverse of x. Okay. Now you would remember, if f of negative x is equal to negative f of x, then we call f of x is an odd function. Right? So what is the meaning of this? So this means sine inverse of x, tan inverse of x, and cosecant inverse of x, they are all odd functions. So let's go on to the next set. Fourth one, cos inverse of negative x is equal to pi negative cos inverse of x. Very important. Number 5, cot inverse of negative x is equal to pi negative cot inverse of x. Number 6, secant inverse of negative x is equal to pi negative of secant inverse of x. Right? So make sure to write these in the corner of your mind and move on, students. Now we got the second set of properties too. So they are as follows. Let me write it as 7. 7. You have a trigonometric quantity sine, and then inverse trigonometric quantity sine inverse of x. When sine attacks sine inverse of x, outcome will be x, such that x lies between negative 1 less than equal to x less than equal to 1. Number 8, cos inverse of x will be equal to x, such that x lies between -1 and +1. Then number 9, tan inverse of x is equal to x, such that x is element of real number. We already know this. Number 10, cot inverse of x is equal to x with x element of r. Then we got number 11, cosecant inverse of x is equal to x, for which modulus of x is greater than or equal to 1. So the understanding for this is nothing but -infinity